Hey everyone, I welcome you all to the live session on Artificial Intelligence tutorial by Intellipaat. This session is conducted by multiple experts who are having more than 15 plus years of industry experience. Artificial intelligence is one of the most happening technologies in the 21st century. Artificial intelligence is the ability of the machines to perform tasks such as learning and reasoning like a human mind. AI enables machines to analyze large data sets to answer complex problems. There are several applications of AI, like artificial intelligence in agriculture. The AI technologies are helping the farmers in decision making. For example, AI helps to decide which seed and in which condition it will give a better result. AI also gives the information about weather condition to get more yield. By using AI, one can overcome traditional farming problems. On saying that, now let's see the agenda of the day. Firstly, we will begin with Introduction to Artificial Intelligence. Post that, we will be learning about deep learning, machine learning, and neural networks in detail. After that, we have covered hands-on demo on AI face recognition and HR analytics. Then later on, we will tell you how to become an AI developer. Then finally, we have covered artificial intelligence interview questions and answers. So guys, this is the agenda. Now let's begin the session.
One important aspect comes into picture when we talk about artificial intelligence. It is the year 1956, guys. Well, pretty much in the year 1956, the term artificial intelligence was actually coined. Well, how did this actually come to happen? I mean, I know a lot of us might actually know that it was coined at the Dartmouth conference and so much more, but what exactly is this conference? Well, in 1956, for a couple of years, basically, there used to happen, there used to be meetings and a couple of meetups where a lot of scientists and researchers used to come together under one roof. And this eventually was called the Dartmouth Conference. And here, basically, what started out as a summer research project and it lasted about 8 weeks. And at the end of it, the product of their research and the product of basically their entire project was one person who coined out the name what is artificial intelligence, and it has ever been stuck with us right back from 1956, right? So I hope you got the Lord of the Rings reference there. So it's one conference to rule them all. It's basically one ring to rule them all if you haven't got that. And coming back to the presentation, so even after 64 years of the term being coined by Mr. John McCarthy, he is regarded as the father of artificial intelligence, guys. Even after 64 years, the world is still going mad, still going gaga about artificial intelligence when you think about it. Well, especially in the last 10 years, right? I mean, everyone is on the everyone is on the trend of artificial intelligence, and it's just gonna go like this for the next couple of decades is actually what analytics tell us, guys. So here's a quick excerpt that I read. Pretty much this is from the person called as Daphne Koller. She's a scientist at the Stanford Artificial Intelligence Lab, and she says that John McCarthy believed in artificial intelligence in terms of building an artifact that could actually replicate human level intelligence. Replicating a human is pretty much the toughest thing that even these big scientists could ever think of, and this was thought about way back in the 1950s as well. And she says that he was very happy with a lot of artificial intelligence today, because at the end of it, it is not replicating the human level intelligence that it was actually sought out to be. And it is said that he wanted artificial intelligence to pass something called as the Turing test. Well, if you guys know about the Turing test, just head to the comments section and talk to your fellow viewers and let them know about the Turing test. And if you cannot hold on to the curiosity, give me 2 or 3 more minutes. I'm going to tell you what the Turing test actually is, guys. So on that note, we need to check out what artificial intelligence actually is. So let me give you the breakup of the textbook definition, guys. Well, the definition goes like this: it's the theory and the development of computer systems, basically, which are able to perform tasks normally, which actually requires a human to do the task. It might be something as visual perception, speech recognition, decision making, and translation between multiple languages as well. Well, that definition will make sense if you actually go through it twice. I mean, this is the textbook term, right? So I usually keep all the sessions very simple for all the viewers, from the beginners to the advanced level, guys. So you can have a lot of takeaway from it if we actually go about simplifying certain things for you. So The current goal of artificial intelligence, if I have to put it in one picture, is basically to tell you that it is just mathematics on steroids, guys. Because when you think about it, all artificial intelligence is trying to achieve is better ways and faster ways to do something that a human can do. A lot of terms like machine learning, deep learning, and come into the picture when we talk about mathematics as well. Because at the end of the day, to achieve artificial intelligence, we use so many concepts which involves a lot of mathematics and implementing this mathematics using code, guys. And at the end of the day, it's mathematics plus programming which will actually lead to us achieving cognition, guys. So what about the future? Well, again, achieving cognition has always been the goal, even of the even it's been the goal of the person who actually coined the term as well, and pretty much every one of his followers and everyone who wants to do something with artificial intelligence pretty much can tell you about how important and how amazing it would be to actually achieve cognition. Well, by cognition, I actually mean that getting a machine to replicate what a human can do exactly the way the human does, or even do it better as well, guys. So, what do you guys think about it? What do you think? In the future, what do you think artificial intelligence has a grip in the future? So head to the comment section and do let me know there. So then you might have heard of these terms, as I mentioned, right? Machine learning, deep learning, and so much more. Well, guys, I would love to explain all of these to you guys, but we've already put out a lot of videos on our YouTube channel, and we have amazing subject matter experts writing out blogs for us as well. So if you want to know more about these terms, machine learning, deep learning, or how they are used to achieve artificial intelligence in general, I suggest you head to our YouTube channel after this video, and then you can go about checking our blogs as well. But hey guys, make sure you stick till the end of the video, because I'll help you fast track your career to become an artificial intelligence engineer, and I'll be giving you a special coupon just for the viewers of this video, guys. So on that note, let us quickly check out the timeline of what artificial intelligence was, what it is now, guys. Let us head back to 1943. Well, it was the time of World War II, guys. It was almost ending, and pretty much this person is the reason, in my opinion, why World War II ended. I am a major history buff, and I believe personally, and many people agree with me, thousands of people agree with me when I say this. Mr. Alan Turing, who was a British mathematician, was the person who ended the world wars, because the Germans used a very nice coding system which was called as the Enigma, and they used to use that to send messages. And well, the Allied forces never got to know what these messages were, because they were all encoded and they just look like rubbish. But Mr. Alan Turing developed the first artificial intelligence machine. He went about using a lot of mathematics, a lot of formulas. It took a lot of days, months, and years to go about cracking this amazing encoding system, which was basically generated by the Germans to go about sending their messages, guys. There's also a movie on that, so if you could watch that, it would be pretty nice as well. So this person, alongside breaking the Enigma, also it was called the Turing machine, basically. And then he invented something called as a Turing test. Well, what does the Turing test do? Well, I just told you 3 slides back that I'm going to explain it, right? So here it comes. So basically, consider this scenario that you are a human, and you obviously are humans, right? So basically, you're just sitting in front of your computer and you're asking a couple of questions to random people around you. And instead of saying it as random, let us consider 2 situations. One, your questions are being seen by a computer, and the other, your questions are seen by another human. So whenever you ask these questions, if you cannot figure out the difference between the answers that the computer can give and the human can give, I mean, if the answers are equally good where you cannot tell apart between the computer answer and the human answer, that particular computer which answered for you has passed the Turing test, guys. So that computer is intelligent enough to pretty much give you answers just like a human, and it can do a damn good job at it, guys. So this particular test, this sets the bar for an intelligent machine, let's say. Because if a computer can fool someone into thinking that they're actually talking to another person, then we can say to a certain extent that pretty much that computer has achieved enough cognition, because it is pretty much going about, let's not say pretend, but it's trying really hard to replicate a human, and it's doing a good job at it as well, guys. So fast track to 1956, again the term was coined there, and scientists begin to tackle the concept. They were like, okay, now the term is set, let's work on it. And one of the top scientists, his name is Mr. Marvin Minsky. So basically his view, along with McCarthy's view, got him very good funding from the then American government, United States government, who basically hoped that, with the help of artificial intelligence, it will actually give them an upper hand in the Cold War, which was ongoing back then, guys. So pretty much Mr. Maron Mansky along with McCarthy actually got good funding from the government, and they went about doing that as well, guys. So this another important thing happened in 1956 was they basically, Mr. Marvin went about starting the artificial intelligence laboratory at MIT, guys. And this lab, right from 1956 all the way till 2019 and 10 years from now, has been punching out amazing solutions to the world's problems, and it has been the most efficient laboratory in terms of artificial intelligence that the world has ever seen. And there are very intelligent people, and very much a force in these people which drive them towards achieving artificial intelligence, is what I can tell you, guys. And then again, a quick fast track to 1981. Well, 1981, artificial intelligence actually got commercialized. So this person called Mr. Ken Olsen, he's the founder of Digital Equipment Corporation, guys. So basically here he realized that, as a business leader, we can actually, start making use of artificial intelligence and start selling artificial intelligence to the common folk as well. And then fast track to 1997. This was one of the most important key moment, in my opinion, back in the 90s regarding artificial intelligence, because this was the first time there was a chess tournament conducted between the grandmaster Gary Kasparov. He was a world champion multiple times in chess. He actually played against IBM's Deep Blue. Deep Blue is basically their then supercomputer, and then Deep Blue actually defeated the world's best chess player at that point of time, guys. And people were saying that IBM's Deep Blue could actually think like God, because it was evaluating over 200 million moves in the game of chess at once. So for every move, it could bring up 200 million combinations of how you could go about playing. How amazing is this, guys? This is still 1997, and then artificial intelligence was already on the roll, and people could say it could think like God. I mean, that is a huge statement, and every time I go about reading about Kasparov or Deep Blue, I am amazed by the fact that this actually happened. In fact, multiple tournaments happened. You can probably read about it after the video, guys. And then fast track to the 21st century. We are finally at 2002, guys. I'm sure most of you might have heard of Roomba. Well, Roomba is a company, pretty much, it's from iRobot. It's basically a carpet cleaner, and it's a vacuum cleaner, guys. So it's a robot vacuum cleaner. So, in my opinion, again, this was another big achievement, because all it took was just few layers of behavior generating systems, which basically guided this machine around your house, around your living space, and it could efficiently clean carpets and floors autonomously without your help. And this has been sold across the world as well. There is 15 million units sold, and I use pretty much Roomba every day. So it basically has a docking station where it comes out of its docking station. It cleans our living room. It goes into the bedrooms. It cleans the bedrooms, and pretty much it just comes back, knows where its docking station is, and just goes back, charges, comes back again 2 times a day. You can program all of these, and it is an amazing thing, guys. It doesn't even sometimes it starts doing it at the middle of the night, and I'm taken aback. Basically, you can set all of that. You can set the timings of which your robot actually starts cleaning and all of that. But it's actually amazing to know there is an autonomous system that I personally use to get my housekeeping stuff done, guys. So they've sold about 15 million units of these across the world, and that number is rising as well. And then coming to the maybe not so nice part of it, in a couple of people's opinion, but in my opinion, again, another amazing use of this is in war machines, guys. So many autonomous war robots were pretty much deployed to Iraq and Afghanistan. In fact, 2000 plus robots which are capable of war, everything from helping our soldiers carry heavy loads, diffusing bombs which would be a threat to the life of the soldiers, patrolling enemy area, till all the way till they could make a stable war robot which is capable of inflicting heavy damage on the opposition forces, guys. Well, this is good in terms where our forces or any country's armies, navy or military forces are not put into immediate danger. Well, if the robot pretty much is shot dead or whatever, if it's malfunctioned or something, or if it's taken a lot of damage during the war, there is no human life lost there, and that is the important thing. That is the good thing. Well, the bad part of it is if this pretty much keeps on going, then every superpower, every nation who's a superpower will want to go about hoarding these. And then, I pray to God there isn't another big war coming. But if there is, then we will, see a lot of these war robots, guys. That's the sad part of it. And I'm sort of confident it really won't come to that. But if it does, then you can see a lot of robots there, guys. Let's just pray it doesn't come to that. Well, the next important thing, in between the robots and the Tesla autopilot actually came about Google's self-driving car, guys. So I'm not sure if you guys know about Google's self-driving car, but instead of just telling you what the self-driving car is, I just thought of telling you the Tesla autopilot directly, guys. Here, basically, this was the biggest breakthrough in terms of artificial intelligence technologies, because Tesla, as a company in the United States, co-founded by Mr. Elon Musk, started providing cars to the public where the car could drive itself throughout, it could park itself, and all you had to do is basically sit in the car, and every 15 minutes or so you had to hold the steering to make sure that you're not sleeping or something. So how amazing this is this. There is a photo on your screen right now on the top right, if you can check it out. That is an actual photo from the car's dashboard, guys. So it basically, instead of having a huge speedometer or something, it has this amazing display where it shows you, it detects all the cars around it, it detects rain, it detects the shortest distance. Guys, you have to read about Tesla's autopilot, and I'm sure many of you guys will find it fancy, guys. In my personal opinion, if this is brought throughout the world, the capabilities of self-driving, that would be an amazing thing, guys. We've already seen a lot of companies actually bring out parking aids and autonomous parking, and it's basically called as parking help or whatever it is. A lot of companies like BMW, Skoda, and Mercedes, and all these big guys have already had autonomous parking capabilities. But when you think about when you think about how it goes about in every country, I'm sure it's very different. But then when you again contemplate about it, if this was brought to every country, it would be amazing, right? And then coming to 2019, guys, I mean, it's one more month to the end of 2019, and one amazing thing happened this year is pretty much in the field of medicine with respect to artificial intelligence, guys. Well, because artificial intelligence, as we all know it, has been helping the world in many different ways, and it has done so in the field of medicine as well. Well, it can be used to ameliorate reading time for digital breast tomosynthesis while maintaining or improving the accuracy of the reading. Well, what it's basically trying to tell us is that artificial intelligence is basically helping us to accurately make sure we detect cancer cells early on, guys. So this, again, we already know the victims of cancer, and we already know that it is an uncurable disease, and it takes a lot of time, endurance, patience, and so much more to go through with this, guys. But then if artificial intelligence can help us to check out what cells are harmful, what cells are harmless, basically what cells are benign, and so much more, then definitely this would help, right? Well, it has actually, the research has already been done, it is being implemented in many countries, and as a part of an artificial intelligence researcher, I am extremely proud of the fact that we've brought artificial intelligence down to the field of medicine, guys. So on that note, we need to check out what's next. We've seen all these different fields, and I'm sure there are hundreds of fields that I could have put in here due to the shortage of time, and pretty much to keep it to the scope of this tutorial for all of our viewers, I had to cut it down, guys. But take a second, head to the comment section, and let me know what you think about the views of artificial intelligence is, and what are the other applications that you find amazing, guys. So on that note, we need to quickly check out what are the types of artificial intelligence, guys. If we keep diving into the depth of these, then it might actually go out of the scope of this video. So let me quickly tell you what are the types of artificial intelligence. Well, we have three different types of artificial intelligence, guys. One is narrow AI, next is general AI, and then super AI, guys. With narrow AI, it's basically it is the concept which is meant to assist or take over specific tasks and do it better than a human would do. Basically, an example of a narrow AI would be pretty much your mobile phone assistants, right? It can be Siri, Alexa, Cortana, and so much more. So you just make your work easier. Instead of opening the calendar app, setting your calendar, all you do is say, "Hey Siri, set my calendar for so and so." So that again is a very good example of narrow AI, guys. Coming to general AI, it's basically taking knowledge from one domain and transferring this exact knowledge into another domain. Well, general AI will almost require the intelligence of a human. If it will not require more intelligence, but you have to match the intelligence of the machine with a human or something very, I'm sorry about that, very close to that. Well, a good example to give you about this is, when you think about it, it's usually very advanced level of chatbots. I mean, sure, Siri, Alexa, all these are amazing chatbots. And then general AI is, again, a lot of mathematics involved here as well. A very good example would be AlphaGo and so much more, guys. So AlphaGo is basically, again, another computer which beat the world champion at this game called Go. I wouldn't say it has the cognition level of a human, but pretty much, even though it sounds simple on the outside, it is actually very complex. And even the world champion said that this is the most intelligent Go player that I've ever met in my life. So that brings us to super AI, guys. Super AI is on another level, guys. This is I would say artificial intelligence, mathematics, programming, all on steroids at once. Because when you think about it, super AI consists of machines that are extremely smart compared to humans. They can outrun a human, outthink a human, outgun a human, and so much more. For either good or bad reasons, super AI is pretty much either in good terms or in bad terms, guys. I've never seen neutral sentiment about super AI, but for the scope of this video, all you need to know is that super AI is pretty much the domain which consists of machines that are extremely smart when you compare it to humans, guys. So on that note, we need to quickly talk about what is the cause for all of these intelligence, guys. So what makes artificial intelligence intelligent? Well, in my personal opinion, the art of training a machine is amazing, guys. When you think about it, you can go about showing your computer images of cats and dogs and asking it to classify it for you. I mean, from our childhood, we have been trained by either school or by family members or friends to know what a cat looks like and what a dog looks like, but your computer does not. It might have taken you 3 years to figure out the differences, or 1 year to, let's say 1 year, you took 1 year to figure out the differences. Your computer will probably take 5 seconds or 10 seconds to figure out this entire thing what took you 1 year, guys. So when you think about it, everything from a very simple cat dog classifier all the way till achieving cognition, in my personal opinion, is just art, guys. Because at the end of the day, taking a concept which does not exist and bringing it right up to the level of a human being, and in a lot of people's personal opinion, human beings are the most intelligent species out there right now. Well, unless there are aliens and all the conspiracy theories. Well, jokes apart, well, coming back, bringing a machine up to the level of a human is definitely achieving cognition, and it's being done right, guys. So we need to think about the challenges we face when we go about making artificial intelligence intelligent, guys. There are 4 important points which pose as challenges. One is knowledge, guys. Because again, when you think about it, when you have to train a machine to figure out stuff on its own and hold these and implement it later is very difficult. This brings us to the second point. Well, if you think getting your machine to hold information and to make sense of it is difficult, then think about learning, because you can learn at a rapid pace, at a slow pace, or whatever it is. But getting your machine to learn, getting your machine to understand about a new concept, contemplate about it, work with it, analyze it, store it, and use it later is something very difficult. And this brings us to the next thing, which is problem solving. Even though you got your machine to have all the knowledge and learn very easily, it needs to go about implementing all of these in a perfect way, guys. Well, it can have the knowledge of all the worldly things which goes by, but what is the use if it cannot solve a problem? Because again, all the artificial intelligence terms or whatever points towards artificial intelligence mostly is a problem, right? Anything in the field of military, medicine, or so much more, we give the developers, the researchers, the scientists a problem so that they can solve it for us easily using artificial intelligence, right? So if your machine cannot solve a problem, then it is pretty much no good, guys. And this is actually very tough to achieve as well. And next comes obviously cognition, as I've been telling you for so many times right now, because again, bringing your machine up to the human level is again a very daunting task, guys. And in the middle of this, let me give you a very quick fun fact. I'm sure most of you guys might have heard of it already. Artificial intelligence has been used in terms of litigation, litigation and law and court and so much more as well. How? Well, I'm sure you guys have heard of JP Morgan, right? They are the banking giants of the world. And they came up with an artificial intelligence model which basically was used to go through and analyze some legal documents. You wouldn't believe the numbers, and the first time I read this a couple of months ago, I was taken aback, guys, because when you think about it, it reduced the workload from 360,000 man hours to a matter of seconds. Think about it, 360,000 hours of job. This is what it takes a human to do it. But as soon as they implemented that model, it just took the model a couple of seconds to do it. And I have read that the model is very accurate as well. So when you think about it, think about the odds: 360,000 hours and a couple of seconds. So if you didn't know this fact, then I hope you find this very entertaining, and I hope you guys feel very interested about this fact at the same time, because we already know artificial intelligence is being used in every field, but not many of us know how it was actually used in litigation, right? So I just found it very interesting to tell you guys about that.
First, let's talk about object detection. So object detection, you might have seen these kinds of images rolling on the internet, right? Where if I give you an image, you can tell me, you can localize inside the image where the particular object is. So this particular, let's say, image contains a dog and a bicycle. Now I am not just only telling that it contains a dog and a bicycle, but I'm also telling where inside this image is the bicycle and the dog. Correct? Right? This is object detection. Second is image segmentation. Now this is on the same lines, but it does a little bit much more cleaner way. So you can see here what is happening. We are identifying that there's a car, there's a person on the road, but we are identifying exactly, not just with a bounding box, but with the exact position where it is. Right? Now this image explains it in a very good way. That this is image segmentation, right? This is local classification plus localization. This is object detection, and this is instant segmentation. Instant segmentation and segmentation, how they're different? That in segmentation we can only identify that okay, these are cats, but if I want to, let's say, identify three different cats, then we can also identify them. What is deep learning versus machine learning versus data science versus AI? So let's talk about first data science, right? Data science is not new, right? It is way older than you think, right? And it is a very simple thing. It says any type of a science, if it is applied on data, that is called as data science. Any kind of a science that is applied on data is called as data science. Now what kind of a science can be applied? These sciences are applied to generate insights from the data. So let's say that if this let's say if you're talking about data science, right? Let's say if you are a CEO of this Fortune 500 company, right, and your company is working in 100 countries, and you want to know that which country is performing good or bad in terms of revenue, what will you do? You will, let's say, calculate all your revenue of the company and aggregate that revenue based on the country wise, right? And then you will see that okay, my Middle East is doing good, Asia is doing good, Europe is doing average, and US is also doing average, right? So you'll say okay, we need to buck up our things in Europe and in USA, right? So these kind of strategic decisions, these kinds of insights, when you see from the data, right, this is called as data sciences. Now what techniques can be applied? It can be as simple as a simple plus minus addition, and then some group also, right, grouping by other data. And it might go a little bit complex towards statistical calculations also, right? So data sciences is more of, let's say, trying to trying to generate insights, right? Try to generate insights. Let's write down, try to generate insights from data. Correct? Try to generate insights from data. That is called as data science. It is not new, it goes as old as the mathematics is there, right? This is called as data science. Then you have machine learning. Now data science was doing very good, right? And it was telling us all the insights that okay, this country is doing good, this is bad, but it was not telling us the future, right? It was not predicting something. So then came machine learning. Machine learning said that I can predict the happening of an event, of an event based on patterns generated from historical data. What does this mean? So what is machine learning? Machine learning says that if you give me the historical data, if you give me the revenue data of your company for last 10 years, right, I will generate some patterns inside that thing, right? I will generate some patterns inside inside that thing using the historical data, right? And from that pattern, I can tell you what is the next thing that can happen, right? So let's say if a particular trend of a thing is going like this, let's say up, down, and then up, and then down, and then up, down, up, and then down. So next time when this happens, you tell me what is going to happen now. Is it going to go more up or is it going to go down? Down, right? Why are you all saying down, right? Why? Because you saw the pattern, right? That 2 times small up, then a big up, then 2 times small up, then big up. So right, this is 2 times small up, it has gone up, now it's time for going down, right? So same way, machine learning also generates these patterns from the historical data. And once these patterns are generated, it can then say that, okay, because the pattern is this is what is the next thing that will happen to you. Correct? That is called as data science, machine learning. Now machine learning, brought a revolution now, because people will predict now what is going to happen next, right? People were predicting that, okay, this much supply is going to be there, so like this much demand is going to be there, so I should have a supply of this thing, right? People were predicting things now on their earlier, and they were making better decisions. But still the problem was that machine learning was able to handle only tabular data. Tabular data means all the data which is written inside your Excel or CSV, which is in a numerical format inside a sheet, right? It was not working on cognitive data. What is cognitive data now? Cognitive data means any kind of when you use any kind of a senses to generate that data, that is called as cognitive. It means you use your eyes to view videos and images.
Just a quick info, guys. Test your knowledge of AI by answering this question. In which of the following application does AI has its expansion? A. Planning and scheduling. B. Game playing. C. Robotics. D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
You use your mouth to generate speech. You use your ears to listen to that speech, and you write something that is called as text, right? So there are majorly three cognitive domains: computer vision, natural language processing, and speeches. These three are called as cognitive areas. Now machine learning could not work very well on these cognitive areas, right? And it failed. So deep learning came and it said that I can predict, I can also predict what is happening, right? But using, but more efficiently, let me say, but more efficiently, but more efficiently on cognitive data, right? But more efficiently on cognitive data because it uses same methods as humans, which are called as neural networks. Deep learning is based upon a neural network terminologies. And the last thing that you have is, it is called as AI, artificial intelligence. Now what is artificial intelligence? Any kind of, let's say, product that you make, final product that you make by using, let's say, a final product that you make by using, let's say, deep learning, or let's say machine learning, or data science, and sometimes static rules and all those things. When you apply all these things to make a product, right, that product is called as artificially intelligent product, right? That is called as AI, deep learning, right? You guys are going to study deep learning, and that too deep learning focused on computer vision. You are going to learn deep learning, and you can apply this deep learning on almost every image problem, right? Your course is focused very much on computer vision. Now computer vision there are, let's say, multiple things that we are going to learn, but before learning those things, we need to learn something theoretical also, right? Now see, the point is that machine learning was happening in the world and everybody was very happy. So I'm talking about, let's say, some 2000ish, right? Okay, let me take you more back. In 1980s, 1980s, this computer was very much accessible to research labs only, right? Research labs and the big corporations, they were only having these computers. Normal people like you and me, they never had computers at their home. And in 1980s, but there was this guy, one guy in Canada. There was this one guy in Canada, and he was saying that why cannot computers think like human? Why cannot computers think like human beings? And why cannot they be trained to be like human? So if I take a step back again, right, and how does a human learn? So a human is born as a very small kid, right? And then that kid is being fed multiple things, right? The kid goes to school, the kid attends, let's say, multiple educational programs. He or she also learns from day-to-day activities also, right? So this Canadian guy, right, this very intelligent and very wisdom guy, he thought that why cannot I do this thing for computers? Why cannot computers also learn if I show them multiple things again and again, again and again, right? And if I teach them like a kid, why cannot they also learn? So he proposed something called as a learning, let's say a human based learning. He proposed something, and he said that I am going to, let's say, uh, specifically focus on a human brain. He proposed this theory and everybody said that you are a mad guy, you are very, 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 very mad, and this all cannot happen, close this thing. And the world demotivated this guy. The world demotivated this guy. This guy went back and he could not have, let's say, focused on these things because he was demotivated. So what he could do, he kept on doing his research in the background. He came back in 2000s, after exactly 18 19 years back. He came back to the world and he proved them that, see, my theories are better than you. And how did he prove this thing? So every year there is a competition which happens. Every year there's a competition which happens, and it is called as ImageNet. It is called as ImageNet. So what is ImageNet, my friends? ImageNet is a competition that happens every year, and they have 10,000, let's say, 10 million images for you. Let's go and check this, the oldest one, and if we can see the Explorer here, that they have collected over the time, and they would ask you to make a computer program, to distinguish between these images. Now what were these images? These images were of, let's say, of multiple, let's say, multiple categories like animals, birds, uh, like this kind of a structure was there. I don't know if you can see this thing or not. Yeah, so this kind of, let's say, categories were there, and there were 1,000 categories. So just imagine, they almost covered every animal, mammal, and it is aquatic animal, everything, plants, humans, cars. They had multiple categories over there, and slowly this ImageNet database was, let's say, increasing. Today they have almost around 14 million images, but at that time, when I'm telling you about 2008 and 2007, right, they had some 1 million images. And this mad Canadian guy, he came. So everybody was still making handwritten rules. They were still making those handwritten rules, like that if they should have 2 ears, 2 nose, and this, then it is a cat, it is a dog, it is this, right? If they're straight and this, they are a tree. So they were, all of them were writing, let's say, handwritten rules, right? They were writing handwritten rules for these things. This Canadian guy, he said that, okay, I am not going to do this thing. I am going to, let's say, make a computer vision system based on deep learning, and I will show it all the images. The model will learn on itself, and then I will, let's say, show them. And that Canadian guy, he won that competition that year. And he didn't just won it just by a margin, right? Humans who were making, let's say, normal people who were making handwritten, let's say, codes, they were at almost 40, 45, 50% accuracy, whereas this guy, he just defeated everybody. His first score, if I'm not wrong, was around 70, 72. This number was there, and everybody was shocked. They saw what it is. So what was that? This guy, he used something called as deep learning into his systems. And who was he? He was none other than Geoffrey Hilton, our AI godfather. Now things started to ramp up. Joffrey, when he presented the first thing, right, then another Canadian guy joined him, and his name was Jan LeCun. He solved that time's greatest problem. Now US postal code here, was facing a biggest issue. What was the problem? That they had to manually read every, let's say, envelope for the pin codes, and they were manually distributing this thing. So they came to these guys and they said that, see, we have a biggest problem here, and the problem is that we have to manually read these things. Can you make a computer system which can read those images and can detect what is the pin code written over these envelopes, and then we can just, let's say, move them to bucket A, B, C, D, and that's so we don't have to read it, right? Read it and then apply the mind and do this thing. Yanli Kun and his team, let's say, made that system in that year, and they showed it to the world that yes, it was possible, and they solved the first real world problem using deep learning. So he is known as the second godfather. And then there was another Canadian guy after Geoffrey Yan. He was called as Joshua Bengio. Here it is. And he's the third person, Joshua. So all of them were, let's say, in Montreal, in University of Montreal, and they were all in this artificial intelligence lab. All three of them together, they started the new wave of deep learning into the market, right? So this is the origin of deep learning. Now, I told you that deep learning, the idea was earlier 1980s, right? The idea was still very 1980s. But why did things started flying up in 2000, let's say 5, 6, or 7? Why all this thing happens so lately, right? Because to process deep learning, we require a lot of data and a lot of computation. And before, let's say 2000, right, we were not so capable of doing a lot of, let's say, data handling, data manipulation, and the data, all these things. So that is why in 2005 and 2006, when when we started, let's say, ramping up in this era of data capturing and data manipulation, things started flowing up. Today you can see your normal mobile phones, they have cell phones, they have almost, let's say, 16 or 32 gigabytes of RAM. And just imagine in 2005, you can hardly even imagine that phones were having, let's say, RAM, right? Forget about, let's say, forget about phone also, right? Let's focus on, let's say, just laptops. I remember I had a Pentium 1 which had what 256 megabytes of RAM there at that time. So just imagine, it was 1998 Commodore. I also had a Commodore before that. So just imagine that things were not so interesting like today they are, right? Today Google Colab is giving you a free 13 gigabytes of RAM. That time 13 gigabyte was a dream. So yes, so all these things started happening because of this thing. Now we have packages like Google Vision, AWS, Tesseract to identify text. Yes. Advancement is very high, and it is not a nice, let's say, it is not a linear advancement that you see. It is not a linear. So what you were expecting that if with time we have increased the RAM like this. No, the computational power has increased like this. No. The computational power has increased somewhat like this, exponentially. Exponentially, it has increased. Today a terabyte is very normal, right? Kids, they carry this 10 terabyte of hard disk in their pockets, right? And that and similar to your computation also, right? Today you see Pentium 9 is there, right? It has almost equivalent to forget about a Pentium 9. My iPhone today has more processor that as compared to my Commodore that time. So yeah, things have, they have, let's say, convoluted exponentially, right? That's my point of telling you, and telling you that, because see, I don't want you to be a blind. Let's say if somebody asks you that when did the, let's say, adventure of deep learning started, everybody would say around 2005, 2004, 5, right? Somewhere this era only. But this idea was seeded way back by Joffrey in 1980 only, right? It was because of these problems of, let's say, computation and data that we had to, let's say, step back, correct? So okay, let's now talk about what is this deep learning then, Shivam. Okay, you have made a very good hype about this, all these things. We have talked about godfathers, everybody, right? But what is this deep learning and how is it associated to humans, right? For machine learning, what is machine learning? Machine learning is just a mathematical equation which is running your, let's say, logics. right? Learning from the previous patterns. But how is deep learning different? How is deep learning different? So see, first of all, now let's talk about what is how they derived as a human part of it, right? So you might have seen this kind of a structure somewhere. Remember this thing? Do you remember? Have you seen this kind of thing somewhere? So my friends, this looks like to you what a scary animal is not, right? Don't worry, it is nothing. It is a part which is present in your body only, right? Don't worry about this thing. Okay, so I'll give you an example. Let's say you have accidentally, let's say picked up a hot water glass, right? And it's very hot. It is very hot. So what will happen? The moment you'll pick up, your brain will suddenly ask you to throw it, or let's say leave it, right? And you would shake your hand then, and then you will curse yourself that why did you pick it up, right? This thing all will happen. But I'll tell you what is the behind the stories, right? uh, Behind the stories, the moment you try to pick up that glass, right? The moment you try to pick up that glass, hot glass, right? The receptors on your finger, the receptor on your finger, they have this kind of a structure which is called as a neuron, and multiple neurons attached one after another, multiple neurons attached one after another make a nervous system. Yes, exactly. I know some of you are very like, what is this in my body? Yes, it is inside your body, and this is let's say one of the smallest part of your nervous system, right? So you might be thinking the nervous system, yeah, exactly. So this is, let's say, what is going to happen if you, let's say, concatenate one neuron after another, right?
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
And then after another, and then after another, and if you make a very long chain, right? This long chain is going to connect from your fingers receptor, and it goes back into your mind, your head, right? And I'm again pretty much not sure that what is this cerebellum or medulla which connects to this thing, and then it connects to, so I don't know which one comes first, medulla or cerebellum. I think cerebellum comes second. So it connects to medulla, and you don't need to remember all these things, right? I'm just telling you, uh, just to set the context, right? So this thing happens. Now what is happening? The moment you picked up that hot glass, the receptors on your finger, this dendrites, these dendrites, they sense something. They sense that it's very hot, and they ask nucleus, that nucleus, should we do something? The nucleus says, yes, the intensity is very high, please send this signal to forward, right? Send this signal to forward. Now this dendrites, they took one signal, gave it to nucleus decides whether to send it forward or not. So let's say they said yes. These are called as axons. Axons are again connected to the dendroids of another, let's say, neuron, right? Another neuron. Again, this, let's say, the pain is going to go from, let's say, one neuron to another, and then second to third, fourth, fifth, sixth, and it goes till your brain. Now brain thinks there that, okay, yes, this is very hot temperature for us, and it might, let's say, destroy the finger receptor, right? It might burn the finger also. So let's ask them to leave that glass, leave that glass. So what's going to happen? Now the signal is going to come back. Now that signal is going to come back from, let's say, axon to, let's say, dendrite of the last one, then second last, third last, and then it's going to come to the first one. This axon is going to say a message to the dendrite, and dendrite will, let's say, leave that glass. The finger receptors will leave that glass. Now I told you this thing into 2 minutes, right? I took this journey starting, and but this really does not happen in 2 minutes. It happens in less than a blink of an eye, right? You pick it up, you throw it. So that is the intensity of a basic human neuron, like it looks, right? Those of you are from biology, if I've done something wrong, like, do let me know. This is what I know about the structure, and this is how it is, let's say, framed in your neural networks also. Now you saw this thing. What is the main advantage of the system is that everything is paired one after another. Everything is paired one after another. Let me do one thing. Let me just copy this image into your sheets so that you'll remember this thing. Okay, so this is the neuron, right? And similar to this neuron structure only, right? Joshua, Yan, and let's say Jaffrey and his team, I'll say ETL, all these people, right? They sat down and they said that we are also going to make a similar kind of a structure like this. Now, I am pretty sure whenever you, not whenever, let's say you might have seen this kind of a, let's say, thing already. And then everything is again connected back to the next one. This is exactly how our dendrites are also connected, right? Every dendrite needs to connect to the next one, correct? And my friend, this is nothing but this is the actual neural network also. So this was the neuron that a human has, and this is what is a neural network. See, if I show you the image, this is the first one which would come, obviously, if I write the correct spelling. So you can see here, this is what a simple neural network looks like. Here you can clearly see this is every input cell is connected to every cell in the hidden layer, and every cell in the hidden layer is connected into the output layer, right? I will give it a heading called as ANN, artificial neural network. So neural network is something that is, let's say, can be of a human also, but when I attach a word called as artificial neural network, it means it is somebody which is made by a human artificially, correct? This is called as artificial neural network, which is made by this. Now again, I know that you're thinking what it is, how is it going to solve the problems. Don't worry about it, right? Don't worry about it, just be with me. Let's talk about what does it say. I'll try to replicate this thing here, and then 4 here, and then 2 here. Now the first thing that you all have to understand is that these are called as input. Now what was the input in your case when you picked up that hot glass of water? Your finger receptors, right? Similarly, for every neural network, there will be a input. There will be a input. And obviously for every, let's say, input, right, you had output also, that you have to drop that glass. Similarly, the decision that the brain makes, that whether to keep it, picking it up, or let's say drop it, that is the output. Do you agree or not, my friends? And between your fingertips till your brain that made the decision, there were multiple other neuron systems also, right? That is called as, these are called as hidden layers. Now I know this terminology is going to be a little difficult for you. Input output, I know you will understand, but this hidden layer, what it is, right? So this is input, this is output, and this one is called as hidden layer, right? This one is called as hidden layer. Now we understood these are the finger receptors. This output can be understood as a brain, and the signal is going to come from input to this hidden layer, and hidden layer will transfer it to the output, correct? So let's make a connection now. Now one thing to remember for everybody is that we are right now making the most basic neural network, and every neuron, input neuron, will be connected to every cell in the hidden layer, right? You can call one circle as a neuron or a cell, whatever you like, right? You can call it as a neuron also, and you can call it as a cell also. Do you agree, my friends? What we have done is, my friends, that we have connected every input to every neuron. We have connected every input to every neuron in hidden layer. So it means what is happening when I'm connecting all the inputs to this hidden layer? It means that every neuron in this hidden layer is listening to the input. They are not biased, right? They are not biased. They are listening to everybody, right? Can I say this thing that this particular, the first neuron that you have taken, this neuron is not biased, because it is not just listening to, let's say, the first input. It is listening to all the three inputs, right or wrong? Right? Exactly, my friends, exactly. That is what is happening here, that it is not getting biased. That is the first advantage. That if somebody asks you that what is the advantage that you're connecting to everybody, the advantage is that we want our neurons to be biasless. They should not be biased, and we want to listen everybody's, let's say, you know everybody's report, right? We want to listen to everybody's aspect, right? Everybody's opinion matter to us. In similar way, the inputs have, let's say, transferred their, let's say, knowledge to the hidden layer. Now hidden layer will transfer the knowledge to the output. Very good. Now hidden layers are also connected to the output. So now what is happening? Outputs are also connected to every to every neuron in the hidden layer. So it means they are also not getting biased, because they are listening to everybody, right? And they will make a decision, right? Now I have one question for you, that what is input and what is output? How do I understand this thing in my real world terminology, right? How can I understand this thing in my real world terminology? So let's spend next time into understanding what is this life cycle of a machine learning or any deep learning, let's say, to be very specific. Let's say life cycle of deep learning. Let's just talk about what how will you perform deep learning. Let's say deep learning is a black box magic. What actually happens? Let's understand that magic, right? So my friends, the first phase is called as training phase, right? The first phase is called as training phase. What happens in training? Whenever you want to learn about deep learning, right? Whenever you want to learn about deep learning, just think about a small kid. Think about a small kid. Now, my friends, let's say that today somebody says to you that this kid knows any kind of addition problem. If you give them an additional problem like 2 plus 2 or 3 plus 3, right? If they are able to answer that question, how they are able to answer that question? If a small kid today can answer a question, let's say 2 plus 2 equal to 4, how they have, how did the kid learn this thing? How did the kid knew this thing? They have learned this thing prior to answering something. So it means if the kid is saying 2 plus 2 equal to 4, it means the kid was taught this thing beforehand, right? He might have learned either from somewhere, right, from mother, teacher, or from the surrounding. Somewhere he might have learned this thing, but the common theme that all of you are conveying is that the kid has learned that thing. And exactly, that's true, right? The kid does not, let's say, was sleeping one night and then suddenly in the morning he might say 2 plus 2 equal to 4. No, the kid has spent a lot of time in the school, and that is why he's saying this thing, he or she is saying this thing. Now what do they do in the school? In the school, I'll tell you what happened. In the school, what happens is, you know there's a teacher, right? There's a teacher who teaches them, and she, the teacher, right? She or he, the teacher, right? They show them how to solve this problem, right? 2 plus 2, how to do this thing, right? They'll do this, if I remember, like, take a finger, right? They count on fingers, 1 2 3 4, 1 2 3 4. They'll do this thing, right? So what is happening? There are two important people in this role. One is the teacher who's teaching them, and then second is the data, right? The training data that they are being used to train. So they are being trained to then count 2 again after 2, so they'll say 1 2 and then 3 4, right? So they're doing this practice, right? They're doing this practice. Or if I make, let's say, things much more easier, let's say if we go to your uh, English classes, right? In your English classes, let's say you're reading some very high aesthetic, let's say some poem there, right? And or let's say you're solving a little reading comprehension, let's say, very simple, right? So when you're solving it for the first time, the teacher does not ask you the question. No, the teacher first teaches you that this is the paragraph, this is how a question can be framed from this paragraph, and this is how you find the answers also, right? So while the teacher trains you, she or he never asks you the question directly. They first of all teach you with both question and answer. They say, see, this is the question, this is the answer, this is the question, this is the answer. That is exactly what is going to happen in deep learning, my friends. So let's take a very small example that you have to make a model to classify cats and dogs. Very, let's say, nature loving model that you have to make, that if you give a image of a cat, the model should say cat, and if you give an image of dog, the model should say dog, right? This is exactly what you do while you, let's say, ask your kids, right? You at the training at the exam day, you give them some questions and you ask them to tell you the answer, but they don't give you the answers on the very first day. No, first of all you train them. So that is what is going to happen exactly in the training phase also. You will provide both the images and the labels. Image is what is the input, and label is what output. Now I know most of you are like, what? I have to give input and output both to the model. Then what is the model doing? Exactly, that's the question. You have to give both the input and output to the model in the training phase so that the model can learn, right? Through a DL algo. I'm going to write this thing, right? Now the model will learn the relationship between input and output. Do you all agree with this statement or not? See, I know this statement is going to be a little bit tricky for some of you who come from, let's say, traditional background. Those who have written code in Java or let's say in C++, they'll say that no, we make a function, we only give an input, we never give an output. But deep learning is not your traditional coding, right? Deep learning is a learning that is being done for the computer. The system has to learn this relationship, right? It is not you and me who have to learn this relationship.
Just a quick info, guys. Test your knowledge of AI by answering this question. What is artificial intelligence? A. Putting your intelligence into computer. B. Programming with your own intelligence. C. Making a machine intelligent. D. Putting more memory into computer. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Right? So in the training phase, my friends, what is going to happen? You have to give the images of cats and dogs and also their labels, that what are they? Is this image a cat? Is this image a dog? Is this image a cat? Is this image a dog? You have to give both the things of the image and the label to the model, and then, sorry, to the algorithm, and then the algorithm will train a model which will learn the relationship between input and output. Do you agree or not, my friends? The next phase is called as, my friends, testing phase. The next phase is called as testing phase. Testing phase means, see, when you teach a kid, right, and the kid starts giving correct answer, you say, oh yes, very good, my kid has started learning this thing. But you don't believe the kid, right? Because it might happen that you might have taught him or her that, let's say, 2 plus 2 equal to 4, and they might have memorized this thing, right? They might have memorized this thing, that 2 plus 2 4. Now every time you ask them 2 plus 2 4, 2 plus 2 4, they'll say 4 4 4 4 4. So it might happen that they might have not understood the underlying concept, but they might have memorized it. And do you want them to memorize 2 plus 2 equal to 4? No, right? You want them to understand the concept of addition, right? You want them to understand the concept of addition, and that is exactly what you want from your deep learning also. You do not want your model just to learn these 4 or 5, let's say, cat images or dog images, because in the next time when it is going to be deployed at a very big website, right, people might give it any cat, any dog. So the model needs to be very generic, right? The model needs to be generic. It cannot be just, let's say, saying that okay, I have learned. And that is why there are exams for kids also, right? That is why there are exams for kids. That's why they exist, because they want to test that whether whatever we have taught you, did you understood that thing or not. And that is what is going to happen exactly here, my friends. In the first phase, you gave the input and output to something called as deep learning algorithm, and the algorithm returned you something called as model, right? Very good. Now what you are going to do in the testing phase is that you will take the same, you will take some input, right? Some input that you have, and you will give it to the model. Now what will the model do? Model has learned a relationship between input and output in the first stage. It has learned that if you will give me input, this is the output. This is for this input, this is the output. This is the input, this is the output. So when next time when you give it an input, right, to the model will return you something called as output predicted. Correct? This is exactly what happens in exams also. This is what exactly happens in exams. In exams, the kid is sitting there and the kid has the question paper. On the question paper, there is just question. This time there is no answer on the question paper. This time it is just question there. Now the kid goes back into the memory of his brain and he thinks that for this question, what is the answer? For this question, what is the answer? And then the kid writes down an answer. Now we don't know whether this answer is going to be correct or wrong, right? The kid just writes it down. And that is what the model has done. The model does not think it is right or wrong. The model, based on its old memories, based on the relationship that it has made for input and output, the model thinks that for this particular input, this is the output, which is called as output predicted. And that's it. Model's job is over, and the kid's job is also over. In the examination center, they go there, they write the answers, whatever they remember, and they come out. Kid's job is done. That's it. Now whose job is next? With the answer sheet in the hand, whose job is next? It's a teacher's job now to evaluate. So in testing phase, we evaluate. Now how does the teacher evaluate? The teacher evaluates because the teacher knows that what is the correct answer to this input, right? They know what is the actual output of this thing, and they will compare this actual output to the output predicted, right? So can we say compare output predicted versus output actual, right? Same thing happens. The teacher takes all the answer sheets, and the teacher would go home and they would check the copies and they would compare that, yes, for this question, this was the expected answer, but what have you given? Oh, that's wrong, 0. Oh, it's very good, 10. Right? They would evaluate you on each question, and that's what is going to happen in the testing phase. In the testing phase, we will evaluate the model on some images. And for those images, we already know the correct answer. We, on the very first hand, we know what are the correct answers. We're just going to ask it to the model, and the model will tell us something about it, right? Now there can be two answers to this evaluation. Either the model has, let's say, given all the answers correct, so you will say very good. Now what do you do when the kid gives all the correct answers in the examination center? You promote that kid. You promote that kid to the next class, right? And you say very good job done. And this is exactly what we will do also. We will promote the model to the next phase, which is called as prediction phase, right? Or it might also happen that the kid performs not so well, right? Unfortunately, the kid does not perform so well. So what do? We call the kid and we say that, sorry kid, you could not do good. So this time you have to repeat this class again, right? You have to repeat this course again. And that's what happens with the model also. If in the testing phase the model appears to be very bad, then we send this model back to the training phase and we say go back and learn more, come back when you have learned more, right? So deep learning can't be creative. And with creative, what do you mean, my friend? Okay, In the prediction phase, what happens? In the prediction phase, this is what is going to happen, that your model is very good. It has performed already very well, right? And now what you just do is you have to, let's say, deploy it, right? And what is going to happen next time, on websites, when people would come, they would give it input, and model will return the output. That's it. I'll tell you what is a static rule. Let's say if today I ask you that let write a code for me to understand that this is a cat, right? And I'll say what is the difference between deep learning and a static rule. So my friends, if I ask you to differentiate between a cat, and if I give you this image, right, what you will do, you will say very good, I will write a code. If you have, let's say, this color, if you have, let's say, this color of shape, this triangular kind of a shape is there, right? And it follows this kind of a structure, and then it has green eyes, right? Green eyes is a distance like this, and it has a nose like this, and if it has a fur like this, right, fur going like this, it means it is a cat. You will write this kind of a code, right? That go in the image and find this. Let's say if you find, let's say, this facial hairs here, and if they're in this location, then this is a cat, or this is the eye, right? But the next time, if I give you a image of, let's say, top view, your code will fail. If I give you a image, let's say somewhat like this. If I give you this image, right, obviously your model will fail. Your code will fail, sorry. Why your code will fail? Because you have taught your code what? You told in your code that it should be like this, right? And it is nowhere. This kind of a structure is nowhere in this whole image. So your static rules are going to fail. Your static rules are going to fail. Now, what does deep learning does so differently that it understands the cat exactly? The first thing is, it does not rely on one image. It relies on multiple images. It does not rely on one images. It takes multiple data points, and then it says that this is that is why there are multiple inputs, right? It takes multiple inputs, right? First thing is that. Second thing is, it does not just see the correct answer. It sees that negative answer also. So when you train a model for cats, right, you might want to put some dogs also there. You might put some dogs also there, and you might say that yes, these are not cats. What they are, we are not interested in them. You can put some images of elephant also, some rabbits also, but the model says, see, I'm not interested in what they are, but I know these are not cats. So one thing where deep learning is very much differentiated is that, then the first thing is that deep learning does not rely on one image. Deep learning requires tens and thousands of images to perform any kind of a modeling, right? So in static rules, you make rules just by seeing one image, and in deep learning, we make rules by internal rules. And again, see, you and me are not making those rules, right? Deep learning is learning on its own. So deep learning is making rules based on multiple images and their behavior, correct? So if tomorrow, even if you give a top view of the cat, right, the model can identify. Let me ask you this question: can a human identify a cat if you, let's say, if you show them the top view? Obviously, yes. Same way, deep learning can also do it. In data science, where do we use deep learning? That's the next question. And the answer to this question is especially in cognitive space. Now, what is cognitive space? Cognitive space means that whenever you are dealing with data such as videos, images, speech, text, right, where you need more computational power to perform things, then you use deep learning kind of thing. Now let's go into real deep of one neuron. Now let's talk about this very interesting thing that I have for you, and this is this. What is a one neuron architecture? So it means I'm going to focus on, let's say, forget about everything, right? Let's start from the very basic example, like how things work in neurons, right? How do they flow, right? So let's try to understand this thing. First of all, there is a input layer, and we have one neuron in this thing. Second, we have the output layer, right, which will give us the output. It has one, let's say, neuron in it, and in between you have something called as hidden layer. You have something called as hidden layer. Very simple to understand. Now, what actually happens inside this whole, hidden layer? That is very important, because how it is trying to tell that this is the output. How can somebody say with just making 3 circles? How can someone say that this is the output as cat, right? I tell you. Hidden layer does something called as an operation, right? A operation, and we need to understand what this operation is. So first of all, my friends, understand that for each hidden neuron, when there's an input coming, the input comes with a weightage towards it. Comes with a weightage towards it. So let's say there's an input coming called I. There's an input coming called I. So you will attach a weight to it. You will attach a weight to it. Now you will say, who is going to give you this weight? I'll tell you. And then you will attach a bias also to it. Who will give it to you? I'll tell it to you. Wait, don't worry. So let's say when this input comes into this hidden layer has to do 2 operations. First of all, it multiply this weight to the input and add a bias to it, right? Remember these 2 terms, weights and bias. What is weight? Weight means that you have multiplied some number to the input, and bias is that you have added to it. I'll tell you why they are important, right? But just for the time, just focus on this thing, that this is a, and this is a multiplication, my friend. This is not x, this is multiplication, right? Very good. And then this particular, let's say, processing which is happening inside this, let's say, which is happening inside this neuron, it has to pass through something called as activation function, and then it becomes the output of this thing, and it again goes to output, right? Again at output there will be one weight which will be applied, and there will be a bias which will be applied. So can I say that W2, let's call it as W2, and this as B2, W2 multiplied by what? What is the input to output? What is the input to this output neuron? That is the, which is coming from this hidden layer, right? And what is it coming from hidden layer? Hidden layer coming is this thing, activation of W1 into I plus B1 whole bracket close 2 times plus B2. I told you that every neuron except input will do one operation. Whenever it will receive an input, it will multiply that input by a weightage. It would multiply that input by a weightage and add an extra number to it called as bias, right? So this is what happens. This is exactly what happened here, my friends. What happened here? That input had an input called as I. Very good. It went to H, right? H said that, see, I will do operation on you. I said, okay. What is the operation? Multiply by weight, and see this happened here. Multiply by weights, and then addition with bias, and then it has to pass through something called as activation function, which is totally fine. We understand this. Now it says, okay, I have to leave you. It leaves the hidden layer and it starts going towards output layer. Output says, I will do the same thing. I will multiply you with a weightage and I will add a bias to you. And see, the same thing happens here. Whatever came out of the hidden layer becomes the input for output neuron, multiplied by the, let's say, the weight 2 and the bias 2, right? There are 3 terms which you will not understand right now: weight, bias, and activation. Don't worry about it. But for the time being, focus here what I'm trying to say, that how is the journey which looks like, right? And what they're trying to do. It is very important. Important thing is that every cell needs to perform three operations. First, multiply the input by the weightage, add a bias to it, and then send it to activation function. Do you agree or not? Let's write it down. Let's write this down. The first thing is what? The first thing is that flow from input to output, right? Operation at every cell except input, right? What is the operation? First of all, multiply input by weight, correct? Multiply input by weight. Second thing is what? Add a bias, and then apply activation. Now I know that you don't know all the three things. That's totally fine. That is totally fine. For now, just understand that what is the journey, right? So if I say, let's write down, input is, let's say, I. So what will be at the hidden layer? Hidden neuron. Hidden neuron will say W1 multiplied by I plus B1, bias 1, correct? And then send this whole, let's say, thing to something called as activation function, correct? Now this hidden layer will go to whom? Output layer, output neuron, output layer or neuron, whatever you want to call it as, because it has only one. What will happen? W2 multiplied by the input. Now what is the input for output neuron? This thing. Do you agree or not? And then B2, and then activation, correct? So yes, we are talking about this artificial neural networks, right? Artificial neural networks says exactly same kind of a structure, right? Somebody who's taking the decision will come in between, right? And these are inputs and these are outputs. I'll try to draw them, obviously not with a yellow pen but with a red pen. So this is your hidden layer, the middle one. This is your input layer, which takes the, let's say, all the inputs, send it to the hidden layer. Hidden layer does some processing and send it to the output layer, and output layer gives the output back, correct? Very simple terminology and very simple, let's say, things. Now what is happening inside this thing, that's another day's story, right? That we said that, okay, we'll talk about it later. Then we talked about the life cycle of deep learning. Three life cycles: training phase, testing phase, and prediction phase. Whenever you want to learn about deep learning, right, I always say, think about a small kid. Think about a small kid, right? A kid, what would a kid do? A kid's analogy is the best analogy that you can give while you are explaining to somebody as deep learning, right? A kid first of all needs to do some kind of a training to understand these things. Then you test the kid, right? And once the kid understands this thing, you promote that kid to the next, let's say, class, or let's say he's ready to go in the world and do the real world problems. That's exactly what you do with your deep learning based algorithms also. First of all, you train them. Now when you said train them, it means you give them input also and you give them output also, right? Input output both. Input output both. You give input output both to the algorithm, then algorithm tries to make a relationship between input and output and makes something called as model. Makes something called as model. Now this model is used in the testing phase. Now the model which was prepared in the training phase, now this model is taken and it is taken in the testing phase, and you give a image to it, just an image, right? A cat image. And then you will see what does the model say. Does it say a cat or a dog? If it says cat, you will say very good model. If it says dog, you say very bad model. Based on this good and bad comparison that you do, right, you take your next step. If it is very good model, then send it to the next stage. If it is a bad model, then you send it back to training. If it is a good model, then you send it to the prediction phase, right? You send it to the prediction phase. Prediction phase, what happens? Prediction phase is nothing but the real world environment in which you work, right? The real world environment in which you work, that's exactly like this. Like Netflix, when Netflix is recommending you something, That is the real world example, right? This is where the model is being deployed. The Netflix model have been deployed. Whenever they see your profile that you're active, they throw in some recommendations to you, right? Curiosity. I made this kind of a structure. I said that there is a input called I, right? Whenever a I goes and whenever there is this neuron which does the processing, I said that it will multiply a weightage to it and add a bias to it then this whole thing will go under a activation function. What is this activation function? We never talked about it. And then it becomes the output. Similarly, at output also there will be a weight which will be multiplied, then there will be a bias will be added, and then there will be another activation function that will be applied, and that becomes the final output of this neuron. Now if you read this thing, right, what is the operation at every cell except the input was, first of all you multiply the input by a weight, add a bias, and then apply activation function. Now at all the three stages we don't know what is a weight, what is a bias, what is the activation function, and why are we doing all these things. Now then afterwards I told you that a hidden neuron, if let's say it does some calculation, it is like this, right? Activation is equal to W1 is the weight multiplied by the input which comes from here, and then multiplied plus a bias to it, and then you send this whole thing into activation function. This whole thing then becomes a input for the output neuron, correct? It becomes the input for the output neuron. Output neuron first of all multiplies it with the weight. See, this is the input which comes from the top, multiply with the weight, add a bias, and then do the activation for the whole. But what is all these things? Why are we talking about these things, right? Today we'll talk about this particular topic. So let's write it down here. What is a weight? What is a weight, and why do we multiply a weight by the input? See, whenever you take a decision, right? Whenever you are trying to take a decision, there are multiple parameters which will influence that decision, right? Let's say if you are trying to go and buy let's say this car, right? Let's say you're going and you're trying to buy this sports car. Now there are multiple things that you are going to, let's say, take a decision on, that whether this has a what kind of a horsepower engine it has, right? Is it a V8 or is it a V6 or is it a V4, right? What kind of a base tires it is using, right? What is the let's say, does it have a tail or not, right? Or does it have a sunroof or not, right? You'll have all these questions in your mind, right? You have so many questions into your mind that you try to, let's say, understand. So buying a car is not just a binary yes or no. Obviously the answer is yes and no, but it is dependent on multiple inputs. That is why, my friends, when I say to you that you take a image, see, you take a image and then you say it is a cat or a dog. Let's say the answer is cat. When the model is saying cat, it is dependent on multiple things, right? There are so many things inside images on which it is dependent, right? There are so many things inside the image on which this answer cat is dependent. Now let's say there are 9 input features. Let's say to, let's say, predict our image, there are 9 input features: I1, I2, and I3. Let's say only 3 because I don't want to write 4, 5, 6, 7, 8, 9, right? So that's why. Let's say 3 inputs are there which are dependent. Now, can it be true that all of them have same weightage? Or it might happen that no, some have higher weightage, some have less weightage. If you're trying to buy a sports car, your sunroof option is a very least priority, right? You want to focus on a very high quality engine, right? You want to deal with a thirsty high thrust engine or not, right? You'll go for a V8 even if it does not have a sunroof or not, right? Or it's a convertible or not. It really least matters. So my point of saying is that whenever you try to take a decision, I have 2 things for you. First of all, there are multiple parameters which are responsible for that decision, right? There are multiple parameters which are responsible for that decision, and each parameter might have equal weightage or not equal weightage. That is what, my friends, exactly deep learning is also doing. When you send inputs to it, it attaches a weight to it, right? Weight can be understood as an importance, right? Weight can be understood as an, first of all, let me write, every decision that we take is dependent on multiple factors, right? First point is this, that every decision that you can take has multiple factors. Second, that each factor might have its, not might, but yes, every factor has its own importance, right? Third thing, to justify the same importance, we multiply weight with the input. We multiply weight with the input. Right now, in our example, when I'm saying one neuron architecture, it means you have only one input, but still every input has its own weightage, right? Now, let's say that somehow your weightage becomes 0 for everything. Let's say your weightage becomes 0 for everything, right? What is going to happen? What is this cell going to give to the output cell? This is your input cell, which gave you the I, right? And this is your hidden neuron, which is doing all that calculation of I multiplied by W plus B. If your weightage is 0, what is going to happen? And then your output. What will you give to output? Let's say there is no B right now. There's only just I and W. If this W becomes 0 because you have multiplied W with I, so if it is a 0, it means it is going to, the whole term is going to become 0. So to prevent this 0, from flowing into the system, we add a small number to it, right? We add a small number to it called as bias, right? Which makes sure that the whole system is not getting corrupted anywhere, right? And it never becomes 0 there. In what scenario will the weight be 0? See, this is your input cell called I. Now, if you do not have a bias, what will be the operation? I multiply by W, right? Let's say somehow the weight is 0. Let's say there is no importance of this particular feature into the system. So what is going to flow now ahead? What is the thing that is going to the output? 0, right? So to prevent this 0, we add a bias to it. Then the question is, who is giving us weights and biases? See, the user will give you only two things, right?
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts. Just a quick info, guys. Test your knowledge of AI by answering this question. In which of the following application does AI has its expansion? A. Planning and scheduling. B. Game playing. C. Robotics. D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
The user will give you only two things, the input and what is the current output for that, right? The actual output for this thing. Now input is sent into a neuron, and then you have to create a output O, which should be almost equivalent to this thing, right? Do you agree or not? In a real world scenario, whatever comes out of a neural network should be equivalent to the actual answer, right? Now tell me, what should I do? Let's say I give you this box. And I only tell you this thing. Let's say I've given you this box. I say to you that you will enter a I here, and I want a O out of it. How can you give me this thing? I can assume here that I and O, they have a linear relationship. I and O have a linear relationship, right? And then can I say like this, that O is equal to I into M plus C. What is this equation? Y is equal to mx plus c. I'm going to write it down. Have you seen this thing? That is exactly what we are trying to do here, my friends. We are trying to say that input and output, we don't know what relationship we have. We are assuming that they have a linear relationship, right? I am assuming that they have a linear relationship, and that is what is this weights and bias doing there. right? We are assuming that input and output have a relationship, and that is linear, right? Do you agree? So now what is happening? Output is equal to input into weights plus bias. Now the problem is, who is giving this weights and biases? Okay, let me ask you a question then one more time. Let's say, my friend, the output is 10. This is called O, the output is 10, and the input is, let's say, 5. And then I say to you that, please friends, make a linear relationship with me. So what you will say? You will say that, okay, multiply a term with the input and add a bias to it. Now what are you guys doing? You try to find a relationship between O and I, and you are suggesting me W and B, right? You are trying to suggest W and B with me, but in your mind, I'll tell you what you guys are doing. You guys are taking one value of W, multiplying it M into W, and then you are seeing what is the value of B, right? That is exactly what, let's say, to find the relationship between input and output, right? The model will try to give itself this chance, and what it will do, I'm going to write the most dangerous line here. We will, for one time, and that to the first time, give them random, let's say output is equal to 10. What is going to happen? Let's say if you give a random weight which is equal to, let's say, 1, and let's say random bias which is equal to 2. So what is going to happen? 5 multiplied by 1 plus 2, which becomes what? 5 ones are 5 plus 2, 7, right? And then you will calculate error. Error is what? Actual value minus predicted value. You will calculate the error and you will say the actual value should have been 10, but what you have given me is only 7. So it means the error is for what? 3. The model will traverse back, and read this line very carefully. The model will traverse back and change the value of weights and bias in such a way that the error becomes maximum. See, what is the goal here? Try to understand the goal here. Try to understand the goal here. I am just giving you an image and I'm saying this is a cat. So what I have to do is I have to, let's say, try to find a relationship between input and output. Now, how do I start this thing? I don't have a starting point. So what I'll do is I'll start very randomly. I'll just randomly take my weights and biases and I will say this is the output. The algorithm will laugh at me and say, hey, this is the wrong thing. Go back and correct yourself. And then he will give me a matrix that how much am I wrong. So now I have the answer that I am 3 wrong. I am 3 wrong if I use 1 weight and 2 biases. So the model will go back again then, right? It will go back again then, and it will try to update its weights and biases in such a way that they become correct. Now, how do I start making this relationship? I have to start from somewhere, right? So where do I start? I say that I will start randomly pick up any point, and then the error is going to guide me. And the error is going to guide me. So I will randomly take a weight and randomly take a bias, and based on that weight and bias, there will be an output in front of me. I will say, okay, the algorithm will say to me that yes, whatever error that you have brought is actually the value you have predicted is very wrong. This is the error that you have. It will say you have an error of 3. I will say, okay, very good. Now I have a starting point. Now I understand that if I take a weight of 1, a bias of 2, I will have an error of 3. So I will now go back and do some changes in my model, again the weights and biases, and will again go with the predicted value. Again there will be error. Again I will go back, go forward, go back, go forward, go back, go forward, and this thing is going to continue this thing, right? Very good. Now we have only one question, that how do we make sure, how do we bring this change in the weight in such a way that it is directional in decreasing the error? Correct? We are trying to find the minimum error or almost the predicted value be equal to actual. Exactly, yes. Right? What is the level cat? Level cat, no, sorry, label of the cat. right? Yesterday, you remember we were talking about a problem where I give you an image and then you have to tell me what it is, if it is a cat or dog, right? It looks like back propagation. This is exactly what is called as back propagation. I didn't want it to, let's say, throw just a big word in front of you. And now I'm going to tell you that whatever we have learned till now is called as feed forward and back propagation, right? So in this case, the error will be the output will be 3. No, the output is not 3. The output is 7 only. The output is 7 only. Based on this output and the actual value, I have calculated the error, right? The above feed forward and back propagation. Okay, so let's now, right, let's run this thing one more time. So what is feed forward? Feed forward is when you go forward with your weights and biases, right? When you say input multiply by weights and then add a bias to it, that is called as feed forward. Next stage is error calculation, right? Let's say it has predicted output. Error calculation will be there. Error calculation is what? Actual value minus the predicted output, correct? First of all, there is a feed forward. Weights and biases are random for the first time only. See, I am also writing that first time only. Please do not think that every time they are taken random. No, for the first time only they are taken random, right? Let me write down 1 2 3 so that you can understand. 1 2 and step 3. Step 3 is what called as also back propagation. Back propagation, right? What is going to happen? Based on the error, change your random change your weights and biases in such a way that error minimizes error is minimum. Now keep repeating 3 2 and 1. I mean, you should not do 1. Let's do one more thing actually. Fourth is what? Once you have done the way back propagation, go back and change the weight and bias, right? Now you can keep on repeating this step until and unless your error is minimum. Let's talk about this thing now. This thing. Let's say if you plot a diagram of error versus the weight, right? It's going to be, let's say, somewhat like this, where for different values of weights, the graph is going to be like this, right? Sorry, 4 points. This is 1, this is 2, this is 3, and this is 4. Which one do you want to go to? And why also? Less error. Now, my friends, these are called as locus points. It means where the tangent of the line changes. If you have noticed carefully here, what is happening? The line was earlier going in the lower direction, but whenever these changes come, the line now goes straight up, right? Here it was coming down, it is going straight up then after this point. Here it was going up, now it goes down, right? So the point is suddenly there is a shift in the line's motion, right? Earlier it was going down, then up, then going down, up, down, up, down, up, down, up, right? So by using slope, what, my friends? Some of my friends are saying using slope. Okay, so first of all, to my non-mathematical friends, my friends, do you all understand this thing? Let's see, this is error and this is weight. For different values of weight, there will be different errors, right? And we want to choose that error where our error is minimum. We want to choose that point of error where the error is minimum. Very good. We want to choose that weight where the error is minimum. Very good. Now the problem is, how do we choose this W? I mean, I don't know how to get to this point. Actually, it is available. Those of you who know about differentiation, right? If you know about differentiation, or if in geometry, if you know about tangent, it means any line drawn at a point of that graph which is perpendicular to it, and whenever it is parallel to the x-axis, that line means that the graph has now suddenly changed. Either it was going up and it is now going down, or it was earlier going down and now it is going up. And you can check for all the points. So here, let's say if you draw a perpendicular line, this is a slope. But here, if you draw a line and if it is parallel to the x-axis, right, it means earlier it was going down and now it is going up. Correct? It was going up, then saturate here, and then goes down. Right? So my friends, if I talk to you about geometry, it means that if you have a slope, or let's say, not to confuse, let's say a tangent, and which is parallel to this x-axis, right? If it is parallel to your x-axis and if it is a tangent to the graph, it means that is the point where you will have either your maxima or your minima, right? Now I cannot tell you whether it is a maxima or a minima, right? But I can still tell you that this is a at least a interesting point for us, either a maxima or a minima. And those of you who are from mathematical background, to explain them, it is very simple. And I think, and if I explain you in mathematical terms, it means you're trying to find differentiation of error with respect to weight, dE by dW. It means differentiation of error with respect to the weight. To see maxima and minima, we have to do one more differentiation. Very good. But my friends don't know this thing, that you are thinking that this is a 2D graph, so you can tell me and do all these things. Now just imagine, error is not a one-dimensional thing, neither is weight, right? They are multi-dimensional things. So my friends, when I say to you that errors should, the weights should adjust themselves in such a way that the error is minimum, how they will do? They will say that we will try to find that who is responsible, right? So they will try to, let's say, do a derivative of error with respect to, let's say, weights, and a derivative of, let's say, error with respect to bias, weights and bias. We are talking about this line right now, that the model will traverse back and change the values of weights and bias in such a way that the error becomes minimum, right? We were talking about our own very small neural network, right? So we said that first of all, there's something called as feed forward neural network. Feed forward, what will happen? We will have an input which will get multiplied by the weights and plus the bias, right? And it will try to predict out some output prediction. Irrespective of it is good or bad, we will calculate the error, right? Let's write it down. ERR, error is equal to actual minus predicted. Third step is called as back propagation. Now we know that the error, based on the error, change your weights and bias in such a way that the error is minimum. Very good. We saw that how can we do that thing? We'll talk about it. Go back and change the weights and biases. Very good. With the updated weights and biases, again do feed forward and back propagation. Repeat the step 5 until the error is minimum. Very good. Now let's do it mathematically also. We wrote it theoretically. Let's write it down in mathematical way. First, there is the input. Then you multiply the weights plus the bias to get, and you calculate the error. Error is what? Error is actual minus predicted. Predicted is what? IW. W multiplied by I plus B. Very good. Find the weight which is responsible for error, right? So what we'll do? We will do dE by dW and dE by dB. Now adjust the weight. New weight is equal to old weight minus old weight minus dE by dW, right? Tell you. Now see, the point is, why did I took differentiation, right? Let's talk about it again. Let's make that error graph, right? And we want to find this error. So what we are saying is, this is the slope. So geometrically, I told you that we can find it by saying that try to find the slope on this graph which is parallel to the x-axis. Now this is a geometrical interpretation. I cannot go and make this, let's say, back again with my hand drawing, and I cannot just do it, right? So what I can do is I can do this mathematically. Now what is a slope? Slope is nothing but let's say differentiating and particular graph with respect to that thing will give you the slope when it is equal to 0. This is the location where either it is maxima or either it is minima, right? Differentiation is the point, equal to 0 is the point, like these points. So this dE by dW is going to give you, let's say, the area at which it is let's say the differences that you need to bring in, right? Ultimately, what is going to happen? I'll tell you. But that's a good question. One of my friends says that dE by d0 is going to be 0, right? No, it's not going to be 0. We are calculating this thing. I told you that dE by d0 at whichever point it is equal to 0, that is the point where it is, right? So I'm saying, so these are two different things. Understand it here. This is the condition where you will get your ups and downs, right? And what we are doing is we are gradually, let's say, shifting towards a point which will have error equal to 0. So differentiation of minus differentiation, what it will do, let's say, see, check here, listen to me just for 1 minute, right? One small minute. So let's say right now, if you are here at this green point, minus dE by dW, what it is going to do, it is going to, let's say, shift your, let's say, point to at this point where it is equivalent to where, let's say, it is shifting towards the optimal point. It will not, let's say, shift exactly at this point at the very first stage. No, it will take small baby steps. It will take more baby steps. Now let me draw it again. Let's say this is the point, a bigger font, right? So let's say if this is the original point through your random points. So when you calculate this new error, what do you think? Is it going to come at the very first point at this point? Are you thinking this thing that directly at just one? No, it's not going to happen. It will move slowly. You will shift it towards this thing. Slowly you will go to shift it towards this thing. Slowly it's going to shift towards this thing, right? This is what is the thing is. This is what I'm trying to say here. Does it make sense? IMG SRC is equal to da 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 da. So let's complete this theory first of all, right? So what you'll do, you'll adjust the weight. The new weight is equal to old weight minus dE by dW. So what is going to happen that with this dE by dW, you're asking your weight to shift a little bit in a direction in which the new weight contributes to a lesser error, right? My friend says that why are we subtracting? Can't we just add this thing, right? See again, but the problem is you need to understand. We need to go into mathematics. See, whenever you want to drop a thing, you are originally here, you want to reach here. This is the error, which is some substantial value, let's say 3, and you want to reach to 0. So what does it mean, my friend? What do you want to do? You want to subtract a thing out there, right or wrong now, right? To my non-mathematical friends, see, nothing there. I'll tell you. So the simple problem is that we have an error here and our job is to, let's say, reach the minimum error, right? This is the graph of error, let's say, and we want to reach here. That's it. To reach here, because we have taken random weights, random old weights, right? Obviously they will never give you 0 error. Random weights can never give you 0 error, right? They will give you some error. So we are gradually asking our weights to shift in such a way that the error becomes 0. That is it. That is what we are trying to do here. And we do here, and then we'll keep on iterating this thing that weight should change themselves in such a way that the old weight minus dE by dW by new weight. So this is the actual value. This is a constant, so it becomes 0. I into W, so this becomes I. W is the one for which we are representing, so W becomes 1. I remains a constant. Again, B is a constant, so 0. It means it is minus I. Let me write down something there. Assuming error is root error and not square. See, generally we don't take error like this, right? Generally we don't take error like this. Why? Because we want to penalize every person based on the error that they have done. Let's say you are the judge of the court, right? You are the judge, you are standing here, and let's say you are the J, and let's say there are two people. This is criminal C1 and this is criminal C2, right? Criminal C1 has done a jaywalking only. He just simply, let's say, crossed the road without the zebra line, so he has done a jaywalking. Or let's say with the signal also, he ran away and crossed the road. And this guy, he's a serial killer and he has done 10 plus killings. Will the sentence for both of them be the same? No. Then if somebody is, let's say, doing a smaller error, would you like to penalize it equivalent to the one who is doing a bigger error? No, right? That is why exactly we use something called as squared errors. What? Squared errors. Now let me tell you what is a squared error. The graph of a square is like this. y is equal to x square. Y is equal to x square. It means what is happening? If you have a smaller number like 4, if you take a square of this number, it becomes 16, right? But if you take a bigger number like 40, it becomes exponentially high. It becomes 1600, right? And if you take much more smaller number like 0.4, now just see here what is happening. 0.4, it actually becomes less than that number. So earlier 4 was done a square, it becomes 16. If you take a square of 40, it becomes 1600. But here, if you take a square of 0.14, it actually decreases that number, right? That is what is, let's say, the funda of x square is. Square functions are so intuitive and so explainable that if you are a smaller number, let's say if you've done a very small mistake, they will say it's okay. It's okay. 0.4 error, it's okay. You take a square of it and you become 0.1 only. We will not even penalize you, right? But if you are a bigger number like 4, they will say, sorry, you have done a bigger crime. We'll penalize you more, 16. If you are 40, 60, 100, right? So always remember, squared function are used for penalizing, and they have a very good graph. If you ever get time to watch this thing, right, the graph is like this. Those of you who are from mathematical background, they should definitely check out this graph. What is this graph? What I've done is I have made 2 points here. This graph is actually like this. If I zoom in there, right, it's like this small area. If I zoom in, it is somewhat like this, that the graph of y is equal to x square was below y is equal to x, but after some point it becomes greater than 1. What is that some point? Can someone tell me what is the sum point at which both the graphs intersect? What is the value of x where both the graph will give the same value? Y, 0. Very good. X is equal to y will also give 1, and x is equal to y square will also give 1, right? So that is why, my friends, what we generally do is we never use a absolute error, right? We always use a squared error. This is called as absolute error, and we generally take something called as squared error. What is a squared error? Squared error says that E error is equal to actual value minus I plus B, and take a whole square of this thing. Take a whole square of this whole thing. Correct? Now who can tell me what is the differentiation of dE by dW? Actual minus predicted to the whole square. So this becomes what? So it becomes actual minus predicted, and then you solve for the inside bracket, right? So actual is equal to 0, 0 minus, then it becomes minus I plus 0. So it becomes like this, dE by dW is equal to 2 into actual minus predicted value and into minus of input, minus 2e. This is the answer, right? And let's write it down here that this is for squared squared error. Right now, which error will be used? So we are going to use an let's say equation called as gradient descent. We are going to use the equation called as gradient descent, and gradient descent always takes a squared error, right? Absolute errors are not very powerful, they just penalize everybody equally, so that is why we take squared errors. Take the input, multiply them with random inputs, random weights and random biases, then calculate the error, penalize the error, and then change the weights and biases that you took randomly first, and now change them slowly in such a way that you will reach to a minimum error.
Now let's look at the subcategories of machine learning. So we have supervised learning, unsupervised learning, and reinforcement learning. So in supervised learning, you can consider that the learning is guided by a teacher. So we have a data set which actually acts as a teacher, and its role is to train the model or the machine. So once the model gets trained, it can start making a prediction or decision when new data is given to it. So let's take this example. So over here, we are training this machine by giving it samples of data. So over here the data is nothing but different images of apple, and along with each image of apple we are also giving it the label of the image, right? So this image goes with its label, which is apple. Again this image goes with its label, which is apple. Again the same with these two, right? So we are teaching this machine that whenever it sees an image something like this, it is nothing but an apple. And after time, when we give it a new data from whatever learning it has done, it will predict whether it's an apple or not. So on the basis of its learning, this machine predicts that there is a good possibility. There is actually 97% possibility that the image which has been fed to the machine is nothing but an apple. So a use case of supervised learning could be spam classifier. So spam classifier basically means that whether the email which we get it's a spam or not, and that is done on the basis of different textual parameters. So let's say a genuine email wouldn't contain too many exclamation marks, it wouldn't contain a catchy headline and so on. But on the other hand, if it's a spam email, maybe it'll contain a lot of exclamation marks with maybe a lot of numbers, and it'll have statements like, hey, congrats, you've won a lottery, or hey, could you help me out? So this spam classification is basically an example of supervised learning. Then we have unsupervised learning. So in unsupervised learning, the model learns through observation and finds structures in the data. So once the model is given a data set, it automatically finds patterns and relationships in the data set by creating clusters in it. So what it cannot do is add labels to the cluster. Like it cannot say this is a group of apples or mangoes, but it will separate all the apples from mangoes. So over here we have this set of images. Now this unsupervised learning model which is applied on this, it will segregate these fruits on the basis of similar characteristics. So over here we have segregated these four into one cluster, these three into second cluster, and these three into the third cluster. Now even though the unsupervised learning does not have any labels, it has still segregated these three into three clusters, right? So the machine over here does not know that these are apples or these are oranges or these are bananas. Yet it has segregated these three on the basis of similarity of characteristics.
Just a quick info, guys. Test your knowledge of AI by answering this question. What is artificial intelligence? A. Putting your intelligence into computer. B. Programming with your own intelligence. C. Making a machine intelligent. D. Putting more memory into computer. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
So it found out that these four objects are similar to each other, and there is quite a bit of variability when it comes to these four objects and these three objects. Similarly, this machine was able to figure out that these three objects, they are quite similar to each other, but when compared with these three objects they are very dissimilar. So this is the underlying concept of unsupervised learning. And a good example of unsupervised learning would be again Netflix movie recommendation. So over here the movies are segregated on the basis of different genres. So over here TV series like Friends, How I Met Your Mother and Silicon Valley are clustered into one group because those come into the same category. Similarly, movies such as Secret Superstar and Dangal could come under the same category because they have the same lead actors. So over here we are segregating the movies on the basis of similar characteristics even though there are no labels in it. And it's finally time for the third machine learning type, which is reinforcement learning. So over here there is an agent and there is an environment, and the agent interacts with the environment and finds out what is the best outcome for it. So it basically follows the concept of hit and trial method. The agent is rewarded or penalized with a point for a correct or a wrong answer. And on the basis of positive reward points gained, the model trains itself. So let's take this example. So over here, this self-driving car would be our agent and the road is the environment. And this car is interacting with this environment. So it will observe the environment and it has two choices over here. So either to go straight or turn right. Now, let's say this agent or this self-driving car decides to go straight. Then what happens is it goes and bangs straight into this barricade. So then it realizes that the action taken by it was not in its best interest and that is why it is penalized. So since it is penalized, it realizes that the action taken by it was wrong and that is why from the next time onwards it will do the opposite action. So instead of going straight, it will take the right turn. And when it takes the right turn, it realizes that the road is correct and the agent is rewarded. So this is how reinforcement learning basically works. So the agent interacts with the environment, it takes an action, and if the action turns out to be incorrect, it is penalized. And if the action turns out to be correct, it is rewarded. So this cycle goes on and on till it completely learns its environment properly. And the best use case of reinforcement learning is again self-driving car. So companies such as Tesla and Google are working on these self-driving cars. So just to sum it off, these are the three different types of machine learning algorithms. So we have supervised, unsupervised and reinforcement machine learning. So under supervised we have regression and classification, and in unsupervised we have clustering techniques, association analysis and hidden macro model. And then the third is obviously reinforcement learning, which works on trial and error method. And if you want to do some really cool machine learning projects, you can check the sites out. Now let's look at some limitations of machine learning. So when it comes to machine learning algorithms, they would require massive stores of training data. So again, as I've told you, machine learning is totally based on the data which it has. So if you have more amount of data, only then it will be able to give correct accuracy. So let's say you take in very small amount of data and there's a good possibility that the results which you're getting are very biased or very incorrect. And also error diagnosis is quite difficult when it comes to machine learning, because again the amount of data is very huge and wherever there's a mistake you'd have to go through the entire algorithm which you've written and then find out that particular mistake by yourself, which is very difficult. And also when it comes to machine learning algorithms, they're not really that creative. So these ML algorithms are built only for one specific purpose. So let's say I'll build a machine learning model which will predict whether it will rain or not today. Now, if I want to use the same model to predict the stock prices, that will not work, right? So basically one model is built only for one particular task. So this is the lack of creativity that I'm talking about when it comes to machine learning. And also there are a lot of time constraints as the model has to learn through a lot of historical data. So that was everything about machine learning. Now let's start off with deep learning. So deep learning is a subset of machine learning where it learns through data representations as opposed to task specific algorithms. So we saw that the drawback in machine learning models was that the models are specific to only one particular task. But this is not the case with deep learning models, as these deep learning models are based on the data representations. And these deep learning models are mostly built with something known as deep neural networks. So this is how a deep neural network looks like. So these deep neural networks completely learn the data which is fed to it. So this is the data. So let's say if this image of woman is fed as the data to the deep learning model, then it will completely extract all the features of this data by itself. Again, the difference between ML and deep learning over here is that the feature extraction in machine learning is manual. But when it comes to deep learning, the feature extraction is automatic. So the deep learning model automatically extracts all of the features associated with that image. And when new images are fed to it, it automatically is able to tell whether the image is same to this or not. So this over here we have a graph which tells us how does performance vary with respect to the amount of data. So what happens in machine learning is that as we keep on increasing the data, the performance increases only up to a particular threshold. After that, if we increase any more data, there is no increase in performance. So this is another problem when it comes to machine learning. But on the other hand, when it comes to deep learning, the more amount of data you give it, the better will be its performance. And that again is because deep learning is based on learning data interpretation. So the more data you give it, it'll automatically learn all those features of the data by itself, and it'll be keep on increasing its performance gradually. Now let's look at some applications of deep learning. So speech recognition is one application of deep learning. Now you need to understand that you cannot build speech recognition applications with machine learning. So this is where machine learning fails and deep learning comes in and helps you to build speech recognition applications. Also another application of deep learning is self-driving cars. So we see over here that the person is just sitting. He is not even touching the steering wheel and the car is driving by itself. So just an amazing application of deep learning. And then we have language translation over here. So this again is a part of deep learning. So over here we are typing something in Spanish and it is being automatically converted into English. So we also have visual translation over here. So over here this text or this board is in some random language, and this app over here which uses deep learning automatically converts this visual into English. So those were some applications of deep learning. Now let's actually understand how does deep learning work. So most deep learning methods use neural network architectures, and that is why deep learning models are often referred to as deep neural networks. So a deep neural network basically has these three models: an input layer, the hidden layers, and the output layer. And the term deep usually refers to the number of hidden layers in the neural network. So traditionally, neural networks only contain 2 to 3 hidden layers, while deep networks can have as many as 150 hidden layers. Now that's a very huge amount, isn't it? So deep learning models are trained by using large sets of labeled data and neural network architectures that learn features directly from the data without the need for manual feature extraction. So all of the input data is given to this input layer, and this input layer automatically extracts the features by itself. Now that data is sent to this hidden layer which performs all sorts of processing tasks, and then the final result is given out through the output layer. So now let's also understand what exactly is a neural network. So a neural network is a computing model whose layered structure resembles the network structure of neurons in the brain with layers of connected nodes. So it can learn from data which can be trained to recognize patterns, classify data, and forecast future events. So the neural network is based on the biological neural network of our brain. So that is why it is given the name neural network. So the layers are interconnected via nodes or neurons, with each layer using the output of the previous layer as its input. So its main function is to receive a set of inputs, perform calculations, and then use the output to solve the problem. Now, as I've already said, these artificial neural networks are based on something known as a biological neural network. So, our biological neural network has dendrites, cell body, and axon. So, dendrites are where the input is taken, cell body is where the processing is done, and axon is where the message is transferred to other neurons. And the same thing happens in artificial neural network as well. So first we give in the data, that data is processed, and then the final processed result is given out as the output. So over here, let's say we train the data with images of cat and the labels would be either cat or not cat. After that, we give in a new image of a cat, and then we basically try to predict whether the model correctly classifies this as cat or not cat. And since the model has learned the data properly, it correctly classifies this image as cat. Now, there are many ways of knitting the nodes of a neural network together, and each way results in a more or less complex behavior. Possibly the simplest of all topologies is the feed-forward network. So when feed-forward neural network, signals flow in one direction without any loop in the signal paths. And typically, artificial neural networks have a layered structure. The input layer picks up the input signals and passes them on to the next layer, known as the hidden layer. And there can be more than one hidden layer in a neural network. And at last comes the output layer that delivers the result. Now, the first question to pop into your head would be, what is the inspiration behind these artificial neural networks? Well, the answer to that is the biological neural network of our brain. So let us first understand the architecture of a biological neuron. So as you can see in the slide, our biological neuron has these three main components. So we have the dendrite, the cell body, and the axon. These dendrites receive the signals and the cell body processes these signals. And the axon finally sends out these signals to other neurons. So just like the biological neuron, the artificial neuron has a number of input channels, a processing stage, and one output that can fan out to multiple other artificial neurons.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So now let's understand these artificial neurons in detail. These artificial neurons are the most fundamental units of deep neural network. It takes an input, processes it, passes it through an activation function, and returns the output if the condition is met. Or else it will process it again until you get the correct output. And such type of artificial neurons is called as a perceptron. So they are basically like a linear model which is used for binary classification. So as the figure shows, we have x1, x2, x3 and going on till xn as inputs in the input layer. Now, to which we add the weights and the bias that are randomly selected. So here we have w1, w2, w3 going on till wn as weights. So we multiply these weights with the corresponding inputs and add all the values together, and finally we add bias to that sum. So this final sum is passed through an activation function which finally gives us the output. So let us see this in detail. So here we have three arrows which correspond to the three inputs coming into the network. Now for these three inputs, we have corresponding weights associated with them. So input 1 is associated with a weight of 0.7, input 2 is associated with a weight of 0.6, and input 3 is associated with a weight of 1.4. Now, these inputs are multiplied with their respective weights and their sum is taken. So if the three inputs are x1, x2 and x3, the sum would be x1 into 0.7 plus x2 into 0.6 plus x3 into 1.4. And to the sum, we add an offset which is called as bias. So this bias is just a constant which is used for scaling purpose. Now let us understand the concept behind these weights. So these weights basically determine the relative importance of the inputs. So let's say we have two inputs, humidity and wearing a blue shirt. So here we can see that wearing a blue shirt has almost no correlation with the possibility of rainfall. So that is why the weight assigned to input x2 would be low in order to bring down its importance. Now let us see why do we need activation functions. So consider this scenario where you have two different classes. One class is represented with triangles and the other class is represented with circles. Now let's say I ask you guys to draw a linear decision boundary which can separate these two classes. So is that really possible? Can we draw a linear line which can segregate these two classes? Well, the answer is obviously no, isn't it? So let me tell you guys how can we do this. So we'll have to add a third dimension to create a linearly separable model which is easy to deal with. So the logic is when you're going from 2D to 3D, you're making your equation non-linear. So with the third dimension, I have introduced non-linearity in our data, which helps in creating a linearly separable model. And in real world situations, you don't always get linear problems. So you should know how to deal with non-linear problems as well. And this is where activation functions help us to convert the linear equation to non-linear form. So these activation functions bring in non-linear functional mappings between the input and the response variable. Their main purpose is to convert an input signal of a node in an artificial neural network to an output signal. And if we do not apply an activation function, then the output signal would just be a simple linear function neural network. Then we have the leaky ReLU, which is just a modified version of ReLU. So the leaky ReLU, instead of just completely removing the negative part, it just lowers the magnitude. And finally, we have the softmax function, which is ideally used in the output layer for classification problems. So the softmax function basically gives a set of probability values for each class of the output. And that particular class, which would have the maximum probability, will be our output class. So that was all about activation functions. Now let us learn more about perceptrons. So like we were taught how to behave in certain conditions, perceptrons also require training. So they have a learning algorithm through which they produce the output. By training a perceptron, we try to find a line, plane or some hyperplane which can accurately separate these two classes by adjusting the weights and biases. So consider this image where we give the dogs and horses as input. So here after the first iteration, error value is 2 since the horse has been classified as dog and there is one dog which is placed in the horses class. And in the second iteration, the error value is reduced to 1 as it is just the dog which is classified as a horse. And finally, in the third iteration, we get the correct output as the perceptron has been trained well with no error. So all the dogs have been placed in one class and all the horses have been placed in one class. Now let's understand the perceptron training algorithm. So this perceptron over here receives multiple inputs and each input is initialized with a random weight. So after these, we multiply these weights with their corresponding inputs and then we get the sum. Now this input is passed through the activation function which would give us a non-linear output. So this process until here is known as feed forwarding. Now if the output which we get is not optimum, we calculate the error in prediction and then go back and then update the weights and bias. So this process where we go from output to the input layer is known as backpropagation. And we keep on backpropagating until we get the desired output. So that was the perceptron training algorithm. Now let's have a look at the benefits of using artificial neural networks. So the artificial neural networks can learn organically. This means an artificial neural network's outputs aren't limited entirely by inputs and results given to them initially by an expert system. So artificial neural networks have the ability to generalize their inputs. This ability is valuable for robotics and pattern recognition systems. Artificial neural networks also help in nonlinear data processing. So nonlinear systems have the capability of finding shortcuts to reach computationally expensive solutions. These systems can also infer connections between data points rather than waiting for records in a data source to be explicitly linked. This nonlinear shortcut mechanism is fed into artificial neural networking which makes it valuable in commercial big data analysis. Artificial neural networks also have high potential for fault tolerance. When these networks are scaled across multiple machines and multiple servers, they are able to route around missing data or servers and nodes that can't communicate. And these artificial neural networks can also self-repair themselves. So if they're asked to find out specific data that is no longer communicating, these artificial neural networks can regenerate large amounts of data by inference and help in determining the node that is not working. This trait is useful for networks that require informing their users about the current state of the network and effectively results in a self-debugging and diagnosing network. Now, to implement these artificial neural networks, you would need the help of a deep learning framework. So the first question to pop into your head would be, what are the different deep learning frameworks available? So today we'll cover just that. So let's start with TensorFlow. So TensorFlow is arguably one of the best deep learning frameworks that we have today. It is an open source software library developed by the researchers and engineers from the Google Brain team for high performance numerical computation. One well-known use case of TensorFlow is Google Translate. So Google Translate is coupled with capabilities such as natural language processing, text classification, forecasting, and tagging. So TensorFlow basically comes with two tools, TensorBoard and TensorFlow Serving. So building massive deep neural networks could be complex and confusing. This is where we can use TensorBoard to visualize our TensorFlow graph and plot quantitative metrics. And then we have TensorFlow Serving, which is a flexible, high-performance serving system and can be used for rapid deployment of new algorithms while retaining the same server architecture and APIs. So now let's look at the next deep learning framework, which is Keras. So Keras is actually a high-level API which can run on top of other deep learning libraries such as TensorFlow, Theano, or CNTK. And with the help of Keras, we can implement both convolutional neural networks as well as recurrent neural networks. And the best thing about Keras is, model building is extremely easy. It's like stacking layers on top of each other. So next, we have PyTorch, which is a scientific computing framework developed by Facebook. So we can get from the name itself that PyTorch is Pythonic in nature. That is, it can leverage all the services and functionalities offered by the Python environment and also smoothly integrates with the Python data science stack. Another great feature of PyTorch is that it offers dynamic computational graphs which can be changed during runtime. This is highly useful when we have no idea how much memory will be required for creating a neural network model. And the next deep learning framework is DL4J. So unlike deep learning frameworks which we saw till now, which were all based on Python, Deep Learning 4J is a deep learning programming library which is written for Java and the Java virtual machine. And the biggest advantage of DL4J is it includes inbuilt integration with Apache Hadoop and Spark. So it helps in getting state-of-the-art results on image recognition tasks. So it shows matchless potential for image recognition, fraud detection, text mining, parts of speech tagging, and also natural language processing. And finally, we have MXNet. So MXNet is a deep learning framework developed by Apache Software Foundation specifically for the purpose of high efficiency, productivity, and flexibility. And the beauty of MXNet is that it gives users the ability to code in a variety of programming languages, such as Python, R, Julia, and Scala. This means that you can train your deep learning models with whichever language you're comfortable in without having to learn something new from scratch. And this deep learning framework is known for its capabilities in imaging, speech recognition, forecasting, and NLP. So when you hear the term TensorFlow, the first question to pop into your head would be, what exactly is a tensor? So in TensorFlow, data is represented in the form of tensors. Simply put, a tensor is a multi-dimensional array in which data is stored. So you can consider these tensors to be the building blocks in TensorFlow. Now, these very tensors are given as the input to the neural network. So as I've said, a tensor is nothing but an n-dimensional array. So the number of dimensions used to represent the data is known as its rank. So if a tensor has just one element, In other words, if it has just magnitude and no direction, then its rank will be 0. If a tensor has magnitude and direction in one plane, then its rank will be 1. Similarly, if a tensor has magnitude and direction in two planes, then its rank will be 2. And this goes on higher up the order. Now, TensorFlow, as the name states, is a combination of two words, tensor and flow. Here, the data is stored in tensors, but the execution is done in the form of a graph. So this is not like your traditional programming where you just write a bunch of lines and everything gets executed in sequence. So first, you'd have to prepare this computational graph, and then this computational graph is executed inside something known as a session. Now, in this computational graph, all the mathematical operations are depicted inside the nodes, and all the tensors are represented on the edges. So the entire computation process is done in two stages. In the first step, the code is depicted onto the computational graph, and in the second step, a new session environment is started and the graph is executed inside this session. So that was all about the computational graph. Now let's look at the program elements in TensorFlow. So we have three program elements: constant, placeholder, and variable. So let's start with constants. So constants are program elements whose value does not change, or in other words, the value is fixed. So let's head on to Jupyter Notebook and work with these constants. Right, so my first task would be to import the TensorFlow framework. So I'll type import TensorFlow as TF. I'll click run. So let me just wait till the import is done. Right, so we have successfully imported the TensorFlow framework. Now, as I've said, let's go ahead and start working with the constants. So let me just type in constants over here. So I'll create the first constant and name this constant as con1. Now this is how we can create constants in TensorFlow. So I will use this TF and then put in a dot and then type in constant. Now inside this, I will give the value of the constant. So let's say the value is 10. So this is an integer type constant. Now similarly, I'll also create a floating type constant and I'll store this in con2. So I'll type tf dot constant and the floating value would be 3.14. Now after this, I'll create a string type constant. So again, this would be tf dot constant, and the string which I'd be giving would be this is Spara. And finally, we have a Boolean type constant, and I'll store this in con4. So this will be tf dot constant, and let's say the value is false. Now I'll run. Now let me print all of these values. So I'll use the print function, and then I'll go ahead and print all of these values, con3, con4. Right. So we see that this first constant is a tensor of type integer. The second constant is a tensor of type float. This third constant is a tensor of type string, and this fourth constant is a tensor of type Boolean. Now we see that we only have the data types of all of these tensors, but we don't have their values. This is because, as I've already told you guys, we have to create a computational graph and then execute that computational graph inside a session. But till now, we have not started our session. So let's go ahead and start a session first. So I'll type ses equals tf dot session and I'll hit run. Now I will run all of these inside this session. So I will type ses dot run.
Just a quick info, guys. Test your knowledge of AI by answering this question. In which of the following application does AI has its expansion? A. Planning and scheduling. B. Game playing. C. Robotics. D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
And let me go ahead and run all of these: con1, con2, con3, and con4. So this time we have the values of all of these tensors. So the value of constant 1 is 10, the value of constant 2 is 3.14, the value of constant 3 is this is Sparta, and finally the value of constant 4 is false, right? So first we'd have to create all of the constants, then we'd have to create a session, and inside this session we'd have to run all of these constants. Now let me go ahead and perform some simple operations on all of these constants. So let me just type in operations over here. So I'll do a simple addition operation. So I'll type addition over here. And let's say the value of the first constant is 20. I'll put a plus symbol and then I'll take in the next constant, and the value of the second constant would be 30. So I am basically adding two TensorFlow constants. The value of the first constant is 20, the value of the second constant is 30, and I'm storing that result in addition. Similarly, I will multiply these two constants now. So multiplication tf dot constant. So I'll give the value of 20. Now I'll put the asterisk symbol, and then this would be tf dot constant of 30. So this time I'm multiplying these two values, right? So I'll hit on run. So now again, if I'd have to see the resultant addition and multiplication values, I'd have to run these two inside a session. So I'll type sys dot run and then put in these two values over here, addition and multiplication, right? So we see that 20 plus 30 gives us an addition value of 50. And similarly, when we multiply 20 with 30, we get a result of 600. Right. Now, so this was basic operation with scalars. And we already know that tensors can have higher dimensions. So let's go ahead and perform addition and multiplication with these higher dimension tensors. Right. So again, I'll just put in addition over here. And I will take in the first constant, and inside this, I will give in a list of values. So let's say I will take in 1, 2, 3, 4 and 5, and I will add this list with the next constant. And this time the second constant has the values of 5, 4, 3, 2 and 1. Similarly, I'll also multiply. So multiplication equals tf dot constant, and this will have values, let's say the same values, 1, 2, 3, 4 and 5. Let me put a comma over here. Right. Now I'll put the asterisk symbol. Again, I'll type tf dot constant, and I will give in the list of the values 5, 4, 3, 2 and 1. Now I'll hit run. Again, I need to run these two inside a session. So sys dot run. Let me put in addition over here. After that, I would also need the multiplication value. Right, so this is our result. So when we add 1 plus 5, we get 6. When we add 2 plus 4, we get 6. Similarly, when we add each of the corresponding elements with these elements inside the list, we get all of the 6s over here. Now let's take this multiplication result. So over here, when we multiply 1 with 5, we get 5. When we multiply 2 with 4, we get 8. 3 cross 3 gives us 9. 4 cross 2 gives us 8. And again, 5 cross 1 gives us a 5. So this was addition and multiplication with respect to lists. Now let me also do a simple operation on strings. So let me take in the first string and name it as str1. So this is a constant. So tf dot constant. And let's say I type over here, I love, and then I give a space. Now I will take in the second string, which would be str2. And inside this, and again, this would be a constant. So tf dot constant, and the value of this constant would be TensorFlow. Right. Now I will run this, and let me execute this inside a session. So sys dot run of str1 plus str2. So the result which you get is I love TensorFlow, right? So the first string is I love, and then there's a space, and the second string is TensorFlow. So when I add these two strings, the resultant is I love TensorFlow. Right, so that was all about constants. And then we have placeholders. So when it comes to placeholders, we don't have to provide an initial value and can specify it during the runtime. So this allows us to build our computational graph without needing the data. And this is how we can create placeholders. So tf.placeholder is the syntax, and inside that we just give the data type of the variable which we will substitute later on during execution. So let's head back to Jupyter and work with these placeholders. So let me just type in placeholder over here. So let me create my first placeholder. So I'll name that as A and tf dot placeholder, and this would be of integer type. So tf dot int 32. Now I will create another variable which would be b, and the value of b would be actually a cross 2. So let me run this. Now I will run these two inside a session. So sys dot run, and I want to see the result of b. So I'll put in b over here. Now, since we know that a placeholder takes in a value during runtime, so this is when I'll feed the value to this placeholder a over here. Now to do that, I would have to create something known as a feed dictionary. So feed dict equals, let me create a dictionary over here. So it would be a, and the value which I'll be giving to a would be, let's say, 5. Now let me run this and let's see what do we get. Right. So during the execution time, I have assigned a value of 5 to a. And when we multiply this 5 with 2 over here, we get the value of b, which is 10. Right. So all of this is happening during runtime because with the help of a placeholder, we can assign it a value during execution. Now, similarly, let me go ahead and give a list of values over here. So instead of 5, let me give the list of values 1, 2, 3, 4, and 5. Now I'll run this. So over here, 1 cross 2 gives us 2, 2 cross 2 gives us 4, 3 cross 2 is 6, 4 cross 2 is 8, and 5 cross 2 is 10. So you get an array of values during runtime. Now similarly, let me also create a placeholder for strings. So I'll type string placeholder over here. So now let me create this variable and name this as string name, and this would be your placeholder. So tf dot placeholder, and I am taking in a string. So tf dot string. Right. Now let me create another string over here. So the name of this string would be my name, and let's say the value of the string is I am. All right. Now let me run this and I'll execute this inside a session. Sys dot run, and I want the result of my name when I add it with respect to string name. Now let me also create a placeholder for strings. So I'll just type string placeholder, and let me create the first placeholder. So I'll name that as str1 name. And since this is a placeholder, tf dot placeholder, and I will be giving in a string during execution time. Now I'll also create another string value over here and name that to be my name, and the value of this string is I am, and then I'll give a space. Right. So now I'll hit run and let me execute this inside a session. Now let me also create a placeholder for strings. So this will be string placeholder. Right. So let me create this placeholder. I'll name this as str name. And since there's a placeholder, I need to use tf.placeholder, and I will be assigning a string to this during execution time. Now I will also create another string, which would be my name, and this would be equal to I am, and there's a space, and I will be adding this with str name. So let me hit run. Right, now I'll execute this inside a session. So for that, I'll type sys dot run, and I want the result of my name. So I'll just put in my name over here, and then I'll provide the feed dictionary. Feed dict equal to, let me put in the dictionary over here, and I will assign the values of str name over here. Right. So the values of str name would be Sam, Bob, and Charlie. Now let me hit run and let's see what do we get. Right. So what we are basically doing is we are adding this with the placeholder value over here, and we are giving the values during the execution time. So I am Sam, I am Bob, and I am Charlie. Now these three values are coming from this feed dictionary during the runtime. Right. So this is all about placeholders. And finally, we have variables. So a variable is just a program element which allows us to add new trainable parameters to the graph. And this is the syntax to create a variable. tf.variable, and then we give the value, or we initialize the value, and then we specify the data type of that variable. Right, so let's head back to Jupyter now. I'll just type in variables over here. Right, so let me create my first variable, and the name of that variable would be var1, and we can create a variable like this, tf.variable. So guys, you need to keep in mind that this v over here is actually capital. Right. So now after this, I would have to assign a value to it. So let's say I assign this variable a value of 20, and this is of integer type. So tf.int32. I'll run this. Now another thing to be kept in mind is whenever we are declaring values in TensorFlow, they have to be initialized. So this is how we can initialize all of the variables. So we have something known as global variable initializer, and when we invoke this function, all of the variables which we have declared would be initialized. I'll hit run. So now let me execute this inside a session. So sys.run of init, and I have initialized this variable over here. Now let me also go ahead and run that variable, sys.run var1. Right. So we have the result of var1, which is 20. Now since this is a variable, the value of a variable can be actually updated. So let me go ahead and update the value of this. So I will name this as updated var1, and the function would be tf.assign. And inside this, the first parameter would be the variable which I'd want to update. And after that, I need to give the value to which I'd want to update this. So I want to make this value of 20 to 25. Right. Now I will run this. So now this is actually a variable. We can actually update the values. So let me go ahead and do that. So the name of the updated variable would be, let's say, updated var1, and the function for that would be tf.assign. And this takes in two parameters. The first parameter would be the variable which we are supposed to update, and the second parameter would be the value to which we are updating it. So I want to make this 20 to 25. I'll hit run. Right now, let me run this inside a session. Sys.run, and I need to pass in the variable which would be updated var1. Let me make it small v over here. I'll run this. Right. So initially the value of var1 was 20, but we have updated it and made its value to be 25. Now let's also go ahead and create a small linear model. So let me just type in linear model over here, and this is how our linear model would look like. Wx plus b, where w and b would be variables and x would be a placeholder. Right. So let me start off by creating w. So w is a variable, so w would be equal to tf dot variable, and I am initializing it with a value of, let's say, 10, and this is of integer type. So this would be tf.int32. Now,
Just a quick info, guys. Test your knowledge of AI by answering this question. What is artificial intelligence? A. Putting your intelligence into computer. B. Programming with your own intelligence. C. Making a machine intelligent. D. Putting more memory into computer. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Similarly, I will also assign the value for b. So b is also a variable and its initial value would be 5, and this is also of integer type. And finally, we have x, which is a placeholder. So x is equal to tf dot placeholder. And since placeholder does not actually take an initial value, it just takes a data type. So the data type is again tf dot int 32. So I'll run this, and now what I'll do is I will multiply w with x and add b to it. So the equation would be w cross x plus b, and I will store it in a variable and name that variable to be linear model. Right, so this is w cross x plus b. I'll run this. Now again, if I have to execute this, I have to run this inside a session. And since also I have created two new variables, I'd have to initialize them first. So init1 equals tf dot global variables initializer. I'll hit run. So now I will create a session. So sys dot run, and I will execute init1 first. So I have successfully initialized these two variables w and x. Now I can go ahead and run this linear model. Sys dot run. Now I would want the result of linear model. So linear model, and then I will use the feed dictionary. Now inside this feed dictionary, I would have to assign a value to this placeholder x. So x equal to, let's say I give a list of values over here, and the list of values would be 1, 2, 3, 4, and 5. Now I'll run this and let's see what do we get. Right. So if the value of x is 1, we get 15. So this basically means that 10 into 1 plus 5, which is 15. Now after that, if the value of x is 2, so this would mean 10 into 2 plus 5, which is 25. Similarly, if x is 3, that would mean 10 into 3, which is 30, plus 5 is 35, right? And same is the case for 4 and 5.
Okay guys, a quick info: if you're looking for an end-to-end training in artificial intelligence, Intellipaat provides a master's in artificial intelligence in collaboration with IBM, which covers everything you need to know about AI. So the details are available in the description box below. Let's continue with this session.
So let's go back in 1980s. There was this crazy guy called Geoffrey Hilton. He proposed that we could mimic somehow the mind, how a human mind works, and we can mimic the way it works, so that we can also try to make a thing out of it, so that whatever our mind is doing artificially, we can also do that thing. So he proposed a paper, and everybody said that, Hilton, listen, you are doing something wrong. This is not what is right. And everybody, didn't like the way things were going on. But after 20 years, almost in late 90s, around 1999, he again came up with this paper. He brought in his paper, but this time with a proof, and he won a contest that is called ImageNet in 2004. This time he came back and everybody had to listen. So we were at 2004 when he won the ImageNet. I have two people who I've already told that ImageNet is actually in a competition. It is held by a joint vision of Stanford plus Princeton University. These guys come up and they downloaded a corpus of images. Now they have a very large collection of images, around 1 million images, around covering 1,000 categories. They have. You can just click on explore and you can see this tree around here. So what you have to do is that you have to make a model out of it, so that you can classify the images. So people used to make hand coded classifiers, and they were working, but at some stage they had to fail, because now let's say that fish, you are trying to detect a fish, but fish cannot every ways be in the same manner in which you are building the hard coded thing, right? Or let's say that you are trying to detect a cat, and then you say, okay, top right if it is a eye, top left it is a eye, and then it's a squishing mouth, then it's a cat, right? But now the cat face will not always be available to you in that particular fashion, right? It might be a top view, a side view, a bottom view, any view might come up, and at that time people used to fail. But in 2014, 2004, when Geoffrey Hilton came with his paper, the competition he won was with 94% accuracy, and that was never achieved, and it surpassed the human accuracy also. So that was where, when people started listening to him and he came out, then he proposed slowly that, okay, that this is what I think, that artificial neural network is nothing, but that we are trying to mimic what is happening in our own mind, right? So if I say that what is the theory, what Joffrey said about neural network is that he said that artificial neural network is a computational model that is inspired by the way biological neural networks in our brain human information possesses, right? So I mean, most of you know this thing, that that our nervous system is made up of axons and okay, I'll show you the photo, that it is made up of axons and brains. A human nervous system is most basic diagram, and everybody of you might have seen this. So how this works is that there is a exact replicate copy of this. If I copy this, and you can attach it back here again. So these are the axon terminals that are connected to dendrites again, and this is how it flows. So let's imagine that your fingertips you can have your dendrites, and these are like small particles again of your pure neuron connected to your brain. So this is how there are like millions of these connected, and they're connected. If I take this, okay, one more feature of Jupyter Notebook that you already know, that you can add a markdown language. So what I do is I do escape M, and then I'll write HTML inside it. So I write img src is equal to, this is how you can write your, in this you can add that this is, right? Let's now look at it one by one, slowly. Okay, so these are called dendrites. These dendrites are the one who are like septicles. These are the one who are responsible for catching all the information and sending it forward to the nucleus. Now nucleus processes this thing and it sends to this axons, and again throws it out to the axon terminals. Now imagine again that this is this copy, this is again replicated here, back here. So you can imagine that these dendrites are connected to these axons, right? And then they're flowing. Now imagine, let's say that you touched a very small, a very hot glass, right? The moment you touch the hot glass, the dendrites at your fingertips, they sense that something is very hot there. So they send this information to your brain, okay, that this is hot. Now imagine this dendrite is processing the information, sending it to terminal to dendrite, and dendrite to terminal. It goes on until it goes to your brain. Now the brain says that this is very hot. You should remove your hand. Okay. Now this process is again flowing back to the dendrite, the original dendrite here. Let's say that this is the original dendrite here. Okay, and your brain will say that this is really hot. You should remove remove the fingertips from the glass. And now when I'm saying that this information is going on, believe me, from your fingertip to your brain, there are like millions of these dendrites who are connecting and flowing this information. Now again, a process of reversal information flow is going on, and this time your brain is sending a signal that remove your hand from the glass, and this is again going back to the fingertip, and then you release your hand from the glass. But in real life, when you touch the glass and when you remove it, how much time do you take to remove this? It's just some nanoseconds, right? I mean, less than. Your reflexes are very strong. You just remove the hand out. But imagine what is happening when you do this. Your brain is not, your hand is not taking the decision of removing that. You might think that, okay, my hand is taking the decision to remove that. No, the hand is like a slave of brain. So every body part of ours is like a slave of a brain, right? Whatever we are doing, it is sent by the brain. The information is sent by the brain, and then it's doing. This is how your body works, right? So it's a slave of your brain, and the brain sends the information, remove or attack, whatever it is, then it reacts. But it's really fast, right? Similarly to this way only, Joffrey said that, okay, this neural network, this is how even I will also build a neural network. Now I'll show you how a basic neuron looks like. Here it is. This is the image. You write it. Basic neural. It's not a network. It's just a neuron. But this is an artificial neuron. So Joffrey said that okay, this is how I propose. Let's do the following. Let's say that your hand is not doing anything. Your dendrites or your nervous system is not, this basic neuron is not doing anything. Imagine that it's doing nothing. But it is reciprocating the information. But how it is reciprocating the information? By activating itself. So when you touch a hot glass or something, it activates itself and then only it's transmitting the thing, right? Now imagine if this would have not activated, it would have sent nothing, right? So this is also playing a very crucial role. See, brain is sitting somewhere like a million neurons far, right? He doesn't know what is happening to your hand until and unless this neuron is sending the information. So what information will the brain process if it doesn't have the information? So these guys are very much responsible for sending the information, and they send the information only when they're activated. So this dendroid will become, this nucleus will become activated, then only it will send the further information. And see, there is also a basic kind of a information processing is going on. It doesn't mean that these dendrites are just sending blank signals. See, I'll tell you more depth inside. See, these dendrites, they collect the information. These dendrites, they collect the information and they send it to the nucleus. Now, nucleus thinks that should I process this and send it forward? Yes or no, depending on that, nucleus send it further. Right. Now, how is nucleus sending is? Nucleus has a particular threshold value. After processing it, it says, okay, if I am activated by that processed value, it will send it further. If not, it will keep it to itself. So this is also how a basic artificial neuron, when I say artificial, it means that the one that we are building right now in deep learning, right? This is also built. Now what is happening is that imagine this round thing that you're seeing is the nucleus. This thing is a nucleus. But this is a nucleus, right? And these are the dendrites to it. This one, this X1 and X2. This is the way of thinking how we are intimating, and this is the tail, axon tail, and it is again connected to a neural network. So it's a chain of multiple neurons going on. Now if we go mathematically, what is happening inside this? It is nothing but a linear combination of all the inputs with a bias. I just went to the very human biological way and I just sent the sentence. It's doing nothing. What it's doing is that it collects the input. Let's say that you have two inputs. Let's say that you have two inputs, X1 and X2. These are your two inputs. Now to every input, you will give some weightage to it. Let's say our weightage is here. This weightage is called W1 for X1 and W2 for X2. Correct? Now what I said, it is trying to build a linear regression, right? So what it does, it multiplies the weight of the corresponding input to itself. So W1 X1 plus W2 X2 plus it adds a bias to it. Now you will ask what is a bias? I'll say imagine that there is another input called X0. There is another input called X0 and the value of X0 is equal to 1. The value of X0 is equal to 1 and there is this weight associated to it that is called W0, right? So this bias is added to it and then you add this. That's it. You plus all these values, multiply plus all these values and you give this output to something called Y. This is all a neuron does. Make sense? Any questions? Please ask. It's very important that you build the intuition that what is happening here. So this is the most basic, it's the smallest part of a neural network that you can pick. And the smallest part of a neural network is doing this. That it takes all the inputs that are coming to itself, give them some weightage, multiply the weightage to the corresponding input, and then sum all these, and then add a small bias to it also. That's it. Over.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts. Just a quick info, guys. Test your knowledge of AI by answering this question. What is artificial intelligence? A. Putting your intelligence into computer. B. Programming with your own intelligence. C. Making a machine intelligent. D. Putting more memory into computer. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
How is this weightage and bias being introduced? That who is okay, x1 and x0, x2 and x1, I can say okay, someone is giving to us the input that what is the temperature of the glass. Let's say it is coming from the outside environment, x1 and x2 is coming outside, but who is giving this w1 and w2? So okay, so the answer is that in a artificial neural network environment, at the very first instance, they are randomly allocated to it. So see, you all guys have learned ML, right? So how does ML work? ML says that I know the output, and depending on the output, I have to give some weightage to these inputs so that they can give me the output. Now you know that the output will be Y. You know that the output is going to be Y, right? Now you want to make some equation where Y is equal to x1 plus x2. Okay, and now this is not the correct answer, right? X1 and x2 will never give you y1. So what you do, you add some w1 here, some random w1, and then here random w2. What it will do, it will not give you the answer. W1 and W2 will not give you the answer. You will do some corrections again in W1, W2, and ultimately it will give you Y. So this is what is happening. At the very first instance, you will take W1 and W2 as random. First is that does the process is reverse? Yes, it also reverses itself. The model will not only go from x1 x2 to y, but it can also come back from y to x1 x2. And second, let's say that he's asking Shivam, does it process recursively? Recursively, just imagine that there are like thousands of, now I'll draw it again to show you. This is just a very basic one, right? Now imagine what is going on here is that this is the small that you saw, right? X1 x2, and it is giving some y. Now here it is again, there is a x1 x2, and then this is giving me y. Now this y and y1 will become an input for some other cell, and then it is giving here. So are you imagining how will it look like? This becomes this, and this will become again an input for some other. So these are like connected, these are like throwing information from one to another, right? But this is how it works. This is how a small network looks like. And this is if I write down the theory, it says that the basic unit of computation in neural network is a neuron, or often called as a node, right? And came write it very right. This is called a node, or you can say it a unit also. So it receives input from some other node, from an external sources or external source, that I was saying, right? Also, right? The x1 and x2 might be an input from another neuron, or it might be given to you directly from the external environment, right? Computes the object. Each input has an associated weight to it, which is assigned on the basis of its relative importance to others. The node applies a function f to the weighted sum of this input, right?
So we'll be having the students' data, so whatever the marks, based upon their marks, so we have to decide the grade. So we have to adjust whether the student is passed out or failed. So we will be adjusting the marks based upon the grade.
This is a very hard-coded problem, I think. But let me take an example that you're working on a machine learning problem where you are trying to find out the loan defaults, right? That in bank you have multiple people who take the loan. Now the bank wants to know how will this person repay the loan or not, right? Now you already have a historical data with you. The bank will give the data to you. Okay, let's say that this is the data with you. So in that data, you already know that if this is the feature of a person, this is the credit history of the person. Based on that, they will also give you that, okay, he paid, he didn't paid, he paid, didn't paid, right? And based on that, you adjust your model, right? So there also you have a x and y with you. You will have your x and y with you at that particular instance also. Okay, so everybody gets this this function thing, right? That's how this function is working. This function f is called the affine. So the f function that you see, this is called the affine thing, and it's doing nothing, right? You saw that it's doing a linear thing here, just multiplying the weights to the corresponding x1 x2, and you might now consider x1 x2 as the importance feature. So the more important x1 is, the more higher the value of w1 will be, right? The more lower the value of w2 is, it means it doesn't make much sense to y. So everything that we will now talk will be with respect to y. So the x2 is not making much sense to y, so the value of w2 will be very less. Let's say y is dependent on x1, so this value of w1 will go more higher, right? And then your bias you already have, this is a static thing, right? Because the x naught associated to it is equal to 1, right? Let's now go back at what further happens here. Now you get the y out of here, right? Now this y thing is a little, you have got the answer, and this might be greater than 1 or less than 1 also, right? So there is no measure of this answer. It might happen that w1 w2 is very small. Let's say w1 w2 are very small, then the value of y might be almost equal to 0, right? Or let's say that w1 value is very high, like very high, so the value of y might also get very high, right? So now this might bring some bias, this might bring some ambiguity to our model. This y might be sometimes, next to infinite, it might be equal to infinite, or it might also be equal to 0, right? Depending on the variables. And we don't want that. We want our y to be in some particular range, right? We want our y to be in some bonded weights, right? Then comes next guys whose names are activation functions. Activation functions. Now we got to know that how this y is made, right? How this y is ultimately achieved. Now to adjust the value or squeeze the value of y, we need some other thing, right? We need something that can control the value of y, and these are called activation functions. Now what activation functions does is that they will take the value of y and they will squeeze the value of y in some certain range. What they will do, they will squeeze the value of y in some certain range. So we have multiple, let's say we have a step function, we have a 10h function.
Shivam, Sanjay this side. Can you please come again about this activation function? Not getting you properly.
So let's come back what this activation function is. So you understand that the value of y, how it is calculated, right? It is now totally dependent on w1 and w2. If the value of w1 and w2 is very less, I mean 0.0000, or let's say 10 to the power minus 23, then the y is going to be very less, right? Next to 0. Or let's say that the value of w1 and w2 is like 10 to the power positive 48 plus 48. So this might be very high. The value of y might be very high. There might be no standard to control this value of y, right? Mathematically, there is no, this value can go from negative infinite to positive infinite, right? And this is not a very good range to get about a particular output, right? So what we do is we introduce something that is called activation functions. Now what this activation function will do is activation function will make sure that your output that you have got y should be in some particular range. What it should be? It should be in some particular range. Now how do you decide that who is going to be in what range, and how is that range called? See, the activation function, if I ask you mathematically, the mathematical purpose of introducing an activation function is to squeeze the value of y between some variable called 0 to 1, right? Majority times. So the purpose of activation function is to bound the y in some range, right? And this range might be minus 1, say 1, 0 to 1, or sometimes 0 to infinite. It might be different range, right? I was at this thing that mathematically the value is to be squeezed between 0 to 1. But if I talk to you about statistically why I am doing this is, now imagine till here, till this particular range, your model is a linear model. Everybody agrees with me, right? This is a linear model. Nothing non-linear have been done till now, right? All the things that we have done till this step in this circle, everything is linear. There is no non-linear thing, right? Now, linear things are a little bad at classifying things if there are more than 3 classes, right? If I ask you, if let's say there are 3 classes, one is like crosses, right? One is circles, right? And one is some triangles. Now, can you make a single line and can divide these 3 data? No, right? If it would have been 2 classes, you might have, drawn a single line and you might have divided the data into like 2 classes, right? But if it is a 3 class data, how will you divide this? You have to ultimately make a triangle kind of a shape or this kind of a shape, right? Then only you can divide this thing, right? So I'll show you a photo also. Let's say, let me give you an example, then I'll show you how this works. Okay, can any one of you, let me hide it here. Now this is this thing in front of you. Everybody can see your data. There is this red dots and there is a blue triangle in the screen, right? Everybody can see this. Now, can you make a linear model that can separate these two things? This can only do in a 2-dimension, right? But if I say you that, okay, see a magic, anybody wants to try this thing? How will you do? No? Okay. What I'll do is, I'll remove this now. So what I did was, I introduced a third dimension. And now I could easily separate by introducing a hyperplane here. And then I can say, okay, something that is above this hyperplane is red, something that is below this hyperplane is blue. Makes sense to everyone, right? So this is why we do activation function, to make sure that we want to classify things more better, to make things more clear. We do an activation function. So mathematically, why we are doing activation function? Because we want to squeeze the value of y somewhere. But if I talk statistically, what we are doing, we are introducing non-linearity in a linear model, because linear models are very much not capable of classifying things in when the number of classes increases. So now we saw that as soon as we increase the linearity, if we increase a dimension in the data, if we introduce non-linearity in the data, what it is doing? It increases the chances of making a linear separable model, right? Right. So if I say in three times, first mathematically squeezing the y. Second, if I say graphical thing, why we are doing this? Because we want to introduce a new dimension. And statistically saying why we are doing this, because we want to introduce non-linearity inside it. Now you might be asking what these functions do. It's a very good question. I have activation functions graphs. See, this is how a sigmoid looks like, a tanh looks like, a ReLU looks like. And see, everybody is bounding. So see, sigmoid is bounding between 0 to 1. Tanh is bounding between -1 say 1. ReLU is bounding from 0 to infinite. So it lets go everything that is going above. Yes, we have step function also. Step function says that you can go, if something can be only have two things, either 0 or 1. If something is negative, it goes 0. If something is positive, it goes 1. It's a step function, sigmoid, tanh, ReLU. So there are multiple things. These are doing the same thing that we want to do for a activation function. ReLU, you can understand that if something is negative, it says it's a 0. And if something is positive, it lets go whatever the value of this is, right? I write the variables in here. This is what brings in. Sigmoid is this, tanh is this, and ReLU is this, right? What is the maximum of 0 to 1? Whatever value it will take, right? This is what activation functions is. Let's say that you have this thing called y1 and y2, right? And now the value of y1 and y2 is very large, right? So this y3 will become ultimately also very large, and this y4 will become also very large. And we know this is not the exact thing. We always expect our output to be in the form of 0 to 1 if it is a classification problem, and if it is regression problem, then it will always be in some range from 0 to 1, right? You all agree with me, right? In machine learning also, whenever you did a classification problem, you one hot encoded the problem. So you never said that the output is going to be a C80 cat or DOG dog, right? You always said that, okay, if 0 comes, this is cat, 1 comes, then it's a dog, right? You did the same thing, right? In machine learning also. Or if it was a regression problem, then you always regress a value from 0 to 1 with a multiplicative factor, right? So this is what is happening here also. The y3 and y4 ka value can never go up beyond a limit. To control that limit, we have to squeeze the value. And see, when I'm saying squeezing the value, that is in mathematical format. But if you see in statistically, what we are doing is that we have to introduce non-linearity into the data, right? Because linear data are not, linear equations are not good in separating non-linear data. right? Right, this becomes separable. You see, now it is very much separable just by a simple hyperplane. Okay.
So, suppose you are a computer vision engineer and a client has approached you with a problem statement in which you have to detect the faces from a set of images that they will be providing, and you have taken up this project, and these are the following steps that you have to follow while building up this project. So, these are the images that they have provided to you. These are some of the images that have taken from their dataset, and here we'll be working on Python with OpenCV. In this project, we will be using the Haar cascade classifier for detecting the faces from multiple images. So, firstly, you have to perform the downloading part for the Haar cascade system. So, here I have written download Haar cascade frontal face default.xml and this raw GitHub code. These are the raw datas for the Haar cascade. You have to just simply save as, and you can save it as desktop, and you have the Haar cascade classifier. So now next we will be just importing the CV2 and glob. So now we will be practicing it in the Jupyter notebook. So firstly you have to import the CV2 library and glob. So I want to tell you that glob is the function which returns us the array of those file name which we will write in the next line. Like we just have to perform face detection on those images which have .jpg extension. So for that I will be writing gimage equals to glob dot glob. So here I am calling the object glob and with the function glob, and here inside the function I will be writing the star dot jpg. So it will take up all the images that have extension .jpg. So after that we will detect, after getting the glob images, now we will create cascade classifier so that we can, so as it helps us in getting the face detection. It contains all the features of the images like nose, ears, face, object. These are some of the features of the image. So here we will be writing detect equals to cv2 dot cascade classifier. Then inside the braces we will be writing which classifier. We have downloaded the Haar cascade frontal face default classifier, so we will be mentioning the same name, Haar cascade. Okay, Haar cascade frontal face default.xml. So now after creating the Haar cascade frontal face default XML file, then what we will do, we will now traverse the glob images so that we can detect the faces. So for traversing we will be creating a for loop for traverse, or you can also write t image for traversing the image, t image in g image, the glob image. Okay. So now it will take one image at a time. Now in the for loop we will read the image, a particular image. So for just reading the image we will write like I have taken image equals to cv2 dot im read, and what is this reading? The t image. Okay, so after reading the particular image from the G image, now we will convert the images. These are the colored images. The image that it has read, it is the colored images. So in this phase detection, we will first have to convert the colored image into the grayscale image. So it is easier for the classifier to handle the image and detect the faces from it. So for converting the image from converting the colored image to grayscale image, we will write gray image. I have written this gray image equals to cv2 dot cvt color color, and in the braces it will have this image that you have to convert it into grayscale, this image comma the we will write cv2 dot color and underscore bgr to gray. Okay, so after converting it into grayscale, now we will detect the faces from the images. So for detecting the faces, I will be writing the face equals to detect. I am calling this object here and with the function detect multi-scale, and it has 3 parameters. So the first one is in which image you want to detect the face. So we will be writing this gray image here, and the next parameter is the scale factor. So we have to see the value of the scale factor, as the scale factor is that value which decreases the volume of the whole grayscale image by 5% until the face is detected. So it basically what does, it decreases the value of the image so that it can find the face from the image. So I am writing 1.25. The smaller the value is, the greater will be the accuracy. So I am writing 1.25, and the next parameter is the minimum neighbor. So we don't have to bother this value. Now after that, after detecting the face, now we will be describing the rectangle shape for the face. So for that, create a for loop for. Now in this braces, we will be writing all the dimensions for the rectangle like x, y, w, h, length, breadth, height and width. Okay, so after the parameter, now in face, we are actually we have detected the face, but now we have to define that face with a rectangle shape. So for that, we will be using the dot rectangle function. So here I am writing cv2 dot rectangle. Okay, rectangle. Now in this we have 4 parameters. The first one is the image that you have to detect the face image, this image that we have read it here. Okay, the second parameter is the RGB value. RGB value means the colored value. So here I am writing the x, y, and then the other parameters for the rectangle. We are basically defining the parameters of the rectangle, how it will look on the image. So we will be writing x plus w, y plus h. Okay, so after defining the parameters of the rectangle, now we will be look at the color of the rectangle. So here I am just taking the green color. So this is the code for green color. Okay, 0, 0. Okay, so now after that the last parameter is the thickness of the rectangle. So I am giving 2. So now after defining the rectangle, now we will just show the image. So for displaying the image, cv2 dot imshow, in the parenthesis we will be writing detect. Any message you can write like detect images. Okay, and comma, which image? This image. So image. Okay, so after displaying the images, now we will be defining the wait key function. What does wait key does is we will define some intervals between the images. It's just a time period that what will be the intervals between the images. So cv2 dot wait key, and how many? I am taking 200 milliseconds. Sorry, 2000 milliseconds, and we will be writing cv2 dot destroy all windows. So destroy all windows will closes all the windows based on the wait for key parameter. So here I am writing the 2000 milliseconds, so it will destroy it for that. So here, okay, so I am running this code. So here you can see that all the faces have been detected.
So have you ever shopped online? Let's say you're searching for a mobile phone on Amazon. Now you would have noticed that the site recommends you mobile phones which are in the same price range or by the same brand. Now, if you leave the site without purchasing the product, then you'd be getting ads recommending you to purchase the same product on almost all the websites that you visit. So how is this really happening? Well, all of this is possible because of machine learning. Now, there are thousands of real life applications of machine learning which you use on a daily basis, either knowingly or unknowingly. Confused? Well, let's go through some of the examples. So all of you would have a Gmail account. Now, how do you think Gmail is able to segregate your emails into different folders such as primary, promotions, social, spam, and so on? Or let's say you're sitting on your couch and happily browsing Netflix. So you get a list of movie recommendations which are very similar to your past watch history. So have you ever wondered how is this possible? Does the machine know you personally to suggest movies similar to your interest? And even while driving, Google Maps suggests you which route has more traffic, which route would be faster for you, and how long will it take to reach the destination if you continue on that route. So how do you think Google Maps does this? Well, all of these are just applications of machine learning. Well, all of which arises over here is, what exactly is machine learning? So it's not just about robots. Machine learning is a sub-branch of artificial intelligence which focuses mainly on machines learning from their experience. Let me explain this to you with an analogy. So consider a newly born child who initially knows nothing. So he goes to school to learn. Now, the teacher starts with the alphabets. The teacher shows picture of letter A to the child and tells him it's A. He repeats the process again and again till the student learns all the alphabets. So here the student is being trained. Once the training is complete, teacher conducts a test to verify how well the student has learned. Now, we'll use the same analogy to a machine. So initially we have a machine which knows absolutely nothing. So we start training the machine in a similar way. So the machine has no idea about what is A or what is B. So we start by showing our machine various pictures of the letter A and teaching it that it's A. Once the training is complete, we test the machine by showing it the letter A of different fonts and styles. And if the machine is able to identify the letters accurately, then it means that the machine was trained well. If not, then in order to increase the efficiency, we have to train a machine with more images of A of different fonts and styles and again test it and check its accuracy. So the more training we give, the more accurate our machine would become. So this is the concept of machine learning. Now, machine learning can be broadly classified into three categories. So we have supervised learning, unsupervised learning, and reinforcement learning. So when it comes to supervised learning, we teach the machine using data which is labeled. Let's say we have a basket of fruits and each fruit is tagged with a label. Now the machine is trained on this label data. So once the training is done, it is given test data or new data to determine how well the training has been done. Now let's take another case where the training data doesn't have any labels associated with it. Here the machine understands the underlying structure of the data to identify similar patterns. And the data which is similar in nature is grouped together. So here the machine understands that all the apples are similar in nature and thus they are grouped together. Same is the case with bananas and mangoes. So this type of machine learning is known as unsupervised learning. And finally we have reinforcement learning, where the algorithm learns through a system of rewards and punishment. Let's say if we feed the machine the image of apple and it labels it as an apple, then it will be rewarded. But on the other hand, if it labels the apple as pineapple, then it will be given negative points. So the greed of getting more and more reward points lets the machine make thousands of decisions, and this is how the machine is trained.
So let us now get started clustering. Certain terminologies which I am writing for your final carousel or takeaways, like I will be discussing something about the segmentation. We'll be discussing about the various algorithms into that clustering, I will also discussing something called targeting. K-means is the fundamental idea we are going to discuss, and so on and so forth. So these are all the terminologies which are there into the support of K-means clustering or the overall clustering as an idea. How and where these things falls into the picture, let us discuss that. So the overall perspective would be focused on three basic questions, my dear friend: why and how. That means our primary agenda would be focused on what is clustering, why clustering, how clustering. And in line with all of these concepts, we will be going through with these terminologies. Before I move forward, there is a fundamental question, what is very genuine to be known and understood, how this keyword of clustering is different and same as of segmentation. In industry, particularly into the data science and data analytics, there are two keywords called clustering and segmentation, which are being used interchangeably. But there is a significant difference in between them too.
Just a quick info, guys. Test your knowledge of AI by answering this question. In which of the following application does AI has its expansion? A. Planning and scheduling. B. Game playing. C. Robotics. D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Fundamentally or theoretically, there is a difference in between them too. But in the industry, formally, professionally, knowingly or unknowingly, these two keywords are being used interchangeably. How? When I talk about segmentation, segmentation is actually a mathematical, descriptive, conditional, basic cutoff and split in the data. Like if you have, I have a column of salary for all the bank account holders or the income of all the bank account holders, I can split that into 4 or 5 chunks. And based on that only, I can offer the titanium card, credit cards, like I am offered with the gold card many of the times or silver card. So when I say segmentation, segmentation is actually a conditional, mathematical conditional based descriptive cutoff or split in the data. When I say data, you guys must be realizing the fact that you are grouping the rows. And if you will connect the dots based on what we have been discussing earlier during the statistical classes, when I was explaining you the concept of deciles, percentiles, and quantiles, I hope you remember the concept of deciling. Yeah. So this actually is deciling. If you will see this diagram, you have been deciling all the salaries of the folk, maybe 1 lakh or 20 lakh or 10 lakh or millions of the records are there. All of those records are either marked in first decile, second decile, third decile, and 10th decile. 10th decile being the highest one. So if you will understand the sketch, needless to mention that this is the first top 20 or 30% customer group. So this is nothing but a simple Pareto rule. 80-20 rule, you remember that? Pareto rule in your life? It's a basic simple rule, right? Would be coming from the top 10 or 20% customer. This is what the Pareto rule comes, which is being alternatively called as 80-20. 80-20 rule. This is ideally the way out. 80% problems are being, they are responsible by the 20% persons. You should read about that actually. A recommendation from my side. So when you are talking about all of these things, so this is the top 30%. This is the another 30% or 40% group. This is the another remaining last 30% group. So this is a basic rule in the industry as well for the segmentation, my dear friends, by and large done by the concentration curves. So we used to put it like high potential customer, medium potential customer, or low potential customer. So it might be a possibility these 30% customers gives you 80% sales, and these last 30% customers gives you only 5% sales. Might be a possibility. So which 30% group I should be targeting precisely? Obviously this one, right? I should be focused on this group in a detailed concerned fashion. So this is a global phenomena. This is what the segmentation is either what you are doing with the basic cutoff, like average salary is greater than this and that, or with the deciling even. Whatever you are doing, you are just grouping the rows appropriately. So the concept of segmentation is also grouping the rows, whereas the concept of clustering is also grouping the rows, but how clustering is different of segmentation is now what we are going to explore. So to conclude this conversation, segmentation is what? A mathematical, descriptive, conditional cut or split in the data, be it with the decile, percentile, or with the other checks. Now comes clustering. Clustering can be considered as grouping the rows, but how? This is nothing but algorithm-based approach or methodology. When I say algorithm-based, that means it is something which you are getting the data being grouped into several groups without any conditions being mentioned or deliberately passed on. And you are leaving the overall data with all the required variables to the statistical algorithm to understand the in and out overall characteristics and the properties. And when I say characteristics and the properties, this actually takes the count of or takes into the consideration of the behavioral aspects of the data. When I say behavioral aspects, like overall basic difference in the attributes collectively based on your age, income, location, or XYZ other thing. Whatever the variables you are passing on, this will take all of the columns into the consideration on a very common note altogether, and then will identify the groups, which is ideally being called as clusters. So what is clusters? Clusters are the groups being created by the statistical algorithm, considering all the demographics and the other columns into the consideration or the characteristics in such a way that each group is homogeneous internally and heterogeneous across. I'm repeating my statement once again. The groups, the clusters are being created in such a way that each group is homogeneous internally and heterogeneous across. Let me now revisit the entire episode and conversation so that you can have a decent, fair understanding and you can connect the dots in a moment. For example, 3 or 4 examples I will be giving to you. I think I should be giving only 2. 2 are enough. To start with the concept, let us assume that I am now quitting my full-time MNC job, and in the beginning I have 100 soft leads. When I say 100 soft leads, so if you'll understand that from the business perspective, from my perspective as a trainer, then ideally I should have teach you, each one of you individually on a one-on-one basis. If I will understand that, if you will understand that from my business perspective, from the business objective, ideally, in order to get the most satisfying results, outcome, and the services, to get the best feedback, bottom line, I should ideally be having a one-on-one sessions with you, teaching with you, so that you guys can continue with your own pace, learning curve, your IQ, your grasping skills, your aptitude, and so on. So he can get me continued or adjust the pace of the course accordingly. But this is not possible with the fact that all of you guys are into the same one single batch. Hence, long and short, if ideally, if you'll understand that from business perspective, I should have 100 batches being started for each one of you. Isn't it so? But considering the point, I don't have really the time bandwidth to get 100 batches being started simultaneously. I can't really go for that. So hence, what I will then do is, I will split this data into 2 or more than 2 cluster or groups ideally. Either I call it like a group or a cluster, same thing. I will overall split those 100 students into or more than 2 groups in such a way that every group being created, be it red, orange, or green. So I will be distributing the overall folks, like 100 students are there. So let us assume 40 are there, 25 are there, and 35 are there. Just assume, okay? So this comes to a conclusion that all these 40 students there in the green cluster are very much similar to each other. That means the clusters are being created in a way that all the clients, folks, customers, patients, doctors, on whatsoever you are doing the analysis on, with the almost similar liking, choices, interest, behavior, characteristics, properties, expectations would be there in one batch or one group. That means this is going to be homogeneous internally. When I say internally, as an example, Akash in this batch would be overall expecting or having the same input, properties, expectation from the course what Aditya might be having. Not exactly, but to a certain extent or almost. Okay, that means people in this green cluster would be very much similar, not exactly, but very or almost similar, and would be very much different from the folks in the another group. This is what clustering as a property, as an idea does. Now, the reason for me to do is that rather than getting the 100 batches being started at this point of time, because I know that all these 40 students are almost having the same aptitude, same interest, same type of background, academics background, all of them are actually fresher. They are all looking for the job to start with. So I will be then drafting a course content for them and will be putting them into a same one batch. Because I know that might be all of them are absolutely new to the entire data science industry with zero experience in the analytics world or data science world or the IT world altogether. So I will keep Microsoft Excel, SQL, then the basics of statistics I will keep. I will keep one BI tool like Power BI or Tableau, and then I will start with Python. So I will keep all of the Excels and the SQL content. When I say Excel and SQL content, this is by and large overall curriculum gets fit for this entire group. Might be a possibility Aditya can say that, Ankur, I know Excel, so I don't want to read Excel, but this is not a possibility for Aditya to get another batch. So he fits best into this cluster. So the point is, I can't really get started with the 100 batches, but yes, I can at least get started with 3 batches altogether, which is like one for green group, one for orange group, one for red group. And the important part, which I would like you to understand, my dear friend, that as far as the statistical operations and the processes are concerned, you would be just thrown with the clusters, in which cluster a particular row is falling in. Then it comes to you back into your code. The ball gets back into your code to identify the similarity of all the items into one group and how it is different from the another group. That means you need to somehow introspect, track the pattern of how this is homogeneous internally and how it is different or heterogeneous across. And that is only the basis how you can then plan how to reach out to these groups. That means another answer, why you are doing the clustering, to target the group, so that you can best possibly target the audience with the best of your possibilities with the available resources. So this is what the clustering is, and this is why you are doing the clustering. So if you're asking and having an answer of question of what is clustering and what is segmentation, I told you why clustering and why segmentation, even again for the same purpose, targeting. In your previous learnings, I remember I must have discussed one RFM segmentation with you. Do you guys remember that? Akash, Ankita, Arshad? RFM segmentation, did you discuss that? Transactional data, active customers, and so on. Yeah. So at that time also, when I say you have to target them with the cross-sell upsell policies or the retention activities or the reactivation campaigning, that was nothing but a targeting approach. So if you will ask me why clustering, the answer goes like for targeting. And that is the reason in many of the organizations and companies, to be very true, in my company also, I have been a part of a COE, which is like Center of Excellency, which has been named as segmentation and target. We are actually targeting the customers and planning the strategies for them after doing the clustering and segmentation. In fact, in all the leading organizations, be it KPMG, PwC, and the core data science companies.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
We have the division like this. Clustering can be considered as a primary approach even before the classifications or defining the groups. As an example, I think I already discussed that example long way before, but I am still repeating that. After doing some clustering, I got some clusters which I am now showing into the different colors, like orange, red, and so on. In this episode, let us suppose these are the clusters being given by the algorithm. Now the point is like how I should be targeting them. The way how you should see is like, let us assume these are all the folks who are currently using the two-wheeler. So I did some survey and the data is about the interest being shown by the various car users or car purchase interesting people, like potential customers who are interested to buy the four-wheelers or cars as a vehicle. So this is the group I could see, folks using currently the two-wheelers. They don't have very much high income and they are now looking to buy a car, not as a luxury, but for a family need or a family purpose. So obviously, I will be targeting them with the basic entry-level hatchback cars like Santro in India, Alto, K10, Quid or Baleno, so on. Whereas this red group seems, after understanding the internal properties, I could see that this group seems to all those folks who are decently earning well, already have the car with them. Now they want to upgrade that car as per their increased living standards and status. And they want to have a luxury car. So obviously I will be offering them the latest sedan car with the latest features. Then comes the another group. This group seems, as I'm seeing that you will be reading the homogeneity and heterogeneity. Now this group, after my investigation or studying the similarity and dissimilarity, this group seems all the folks in this batch are very much rich. All the family members are already having the car with them, but now they want to have an additional car in their family with the adventurous purpose. Because they are very good with the money, they are filthy rich people. So I will definitely be then offering them with the SUV cars, a luxury SUVs. But coming back to the last group, this one, I can see something like this group is having very high ambition and dreams of purchasing and taking the fun of the luxury SUV car. But one thing common in all the clients, customers in this group is that they don't have enough money or their budget is not appropriate to get into a comfortable SUV car currently into the market. So in order to satisfy their expectations or the requirements, company will think about how to target them. And in order to get into the gist of all of that idea, they can probably come up with the concept of some new products for the overall fitment of this group. And when I say they will draft a new product, that is the only reason you can think of something new into the market. As far as this example is concerned, something like compact SUV. This is a budget class SUV, which in Indian context was not there before 2010, right? So after that, there came Creta or Brezza. So Creta or Brezza is what? The compact middle class SUVs, right? So you are getting these products to target the group is what the objective of clustering is. I hope this example tells you everything now. So to get some more constructive learning, I will be discussing few of the additional things with you, what I have. Just take an example. So this is actually a chart I got created on a data after clustering. And the clustering has been done primarily on two columns, the spending score and annual income. To get this idea being discussed, this is the first group, this is the second group, this has been the third group, and this has been the fourth group. From this group, you can take the insights directly that this is the group which is low on income and low on spending. This is the group which is high on income but low on spending. This is the group which is high on income and high on spending. This is the group which is high on spending and low on income. Considering in which particular cluster it falls and the homogeneity and heterogeneity, I can better plan to target them. Like as an example, for this green group, I can target them with the upsell strategies because I know they are the rich people but not spending that much. Whereas to this orange group, I can target them from the cross-sell strategies because I know they are good to spend the things. Their earning is also good and they are very much interested to spend the money without any pain. So considering in which particular group certain thing falls, you can target the groups accordingly. Hence, there is one single learning and keyword, my dear friends. Why you are doing the clustering? The answer will be targeting. That's all, full stop. So this is what the basic bottom line is and the idea. I will prove all of these points in a moment. Let us continue with this idea. There is a data set called IRIS. IRIS is a very commonly used data in the entire data science, data analytics space across the globe, globally, geographically, be it in India or in the other geographical locations, be it in R or Python even. In Python also you have this data set. I will show you right away. There are several data sets in every platform, be it R or Python, which are preloaded. These data sets are actually preloaded. Why preloaded? For your better learning experience, for training and development, for the demonstration, and for the better learning experience across the globe geographically. So a lot of things are there which you can look for. Not only this one, but you have so many other data sets as well. So you can clearly see in Python, we are getting this pulled from datasets.load_iris. So dataset is actually a preloaded library there in sklearn. Can you see that? And this contains the dataset called iris. So not only this, but you have a lot of other datasets as well, like Boston dataset and so on. So at least 50, 60 different datasets are there, which you guys can use for the better learning, training, and development purpose. So yeah, this is what the idea. So whatever the data I am now using on R is also there available in Python. So nothing is absolutely going to be different here for you. There is a magic which I want to create here for you guys, and you would be surprised to see. First of all, let me show you how this data looks like. Iris, I got this triggered line number 1 and loads my data set in my system. Currently, this is the Iris data set having 150 records and 5 columns. Out of those 5 columns, 4 of them are numeric, which is sepal length, sepal width, petal width, and the 5th column is categorical, character in nature, having the species of the flower. This Iris dataset is actually a dataset based on a flower or the various varieties of that flower of iris. Its overall dimension, the length of sepal length, sepal width, petal length, petal width. Needless to mention that 4 of the variables are numeric. Last variable is categorical. If I will continue putting the cluster over this data set as a whole, what I am now doing, it has thrown me an error. This is the error. When k-mean is not the right name, and the correct keyword is k-means. K-means algorithm, as is important. When I triggered that, you can see this has shown me an error because of that same problem of categorical data. Hence, instead of passing all the 5 columns, I will now be getting continued with the first 4, which are numeric columns. And you can clearly see, I literally got the results being generated automatically without any trouble. A couple of the interesting things for you now, which I am getting discussed. For your interest, my dear friends, you have literally done the clustering. So clustering is done. Congratulations. Thank you so much. Done with the exercise. Isn't it interesting now? As I told you, the major effort is not to get the clusters being created, which is just a quick way. What important is to understand why the rows are being there in group 1 or group 2 or group 3. Before I move forward, there are certain basic conceptual know-hows I would like to reiterate, which I am sure and I am remembering I got this discussed at the time of discussing that earlier as well. Now, what I literally want you to understand that, let us assume if I am increasing the number of clusters in my data from 3 to now 4, what will be the change in homogeneity and heterogeneity? When I say change, which one is gonna increase and which one is gonna decrease? What will be the impact overall if I will be increasing the number of clusters from 3 to 4 in the data? How the homogeneity will change, how the heterogeneity will change? Over to you guys. Correct? I hope everyone is convinced with what Arshad is saying. Every group will start getting more homogeneous, other way around, or synonymously or simultaneously. The groups will start getting dissolved further and further. That means they would be, so heterogeneity will decrease and homogeneity will increase. Isn't it so? Cool. You guys are brilliant actually. Thank you. Now, considering this idea, you have to really go into a very detailed input, which I am now discussing with you. When I got this code being triggered, I actually got a model created in the form of my mod. So when I got this model being triggered, you are actually getting a lot of the components within that clustering model being created. So somewhere like 7 to 8 components are there. One of them is cluster centers dot ss within ss, total within ss. But certain keywords are there like the split size of every cluster. So out of 150 records, so altogether you have 150 records. Those 150 records are being by and large splitted into 3 groups, whereas the group A is having 50 records, or not A, I would say 1, 2, and 3 here. So these are just the numeric sequence where 1 is not superior or inferior than 2 and so on. So there is no order, just 1, 2, and 3. So 50 elements are there in group 1. 38 elements are there in group 2. 62 elements are there in group 3. These are all the rows being allocated to every cluster. 150 records are there. That means 150th row is in third cluster, first row is in first cluster, and 30th row is in first cluster, and so on. In all such scenarios, there is one interesting thing which you would find called within SS. Let me get this explained. Within SS, full form of within SS is within the sum of squares. And this within the sum of square, if I will be getting the 3 clusters being created, turns out to be how much? 15 for the first cluster, 23 for the second cluster, and 39 for the last cluster. Within the sum of square is nothing but within the cluster distance, error, square of the error. That means, let's suppose this is one cluster in a round and I have 2 objects. What is the overall distance I have, largest distance in between the group? Ideally, this somehow tells you how homogeneity, what is the component of homogeneity I have in every cluster. So obviously, more the number of clusters are, homogeneity will be higher, and higher the homogeneity, the within the SS will decrease. I am writing that for you. Higher the homogeneity, lesser the within SS. This is like scatterness. This is scatterness. Within SS is scatterness within the cluster, and which translates into the fact that larger the number of clusters, okay, lesser will be, so larger number of clusters, more homogeneous they are. Yes, and that translates into the fact that lesser within SS you should have. Clear? Just read that line number 6 for me before I move forward, because this is the game changer. This line number 9, I am getting the sum as an overall homogeneity being identified. I am showing to you. It is coming out to be 78. This result of 78 is actually nothing but what you have the additional another component which you guys can see called taught within SS. Can you see that? So this taught within SS is nothing but the sum of the overall individual clusters, what you are getting individually from within SS. I will show you right away. So just try to take a look on what the results you are getting in line number 9 and 11. Both of them will be giving you same output as 78.8514. I'm running this, and here you go. Can you see that? This is also 78.8514. This is also 78.8514. That means this is nothing but sum of the individual clusters, and this is the overall sum. That's all. Now, this unit, what you are getting is actually telling you the overall scatterness when you are having 3 clusters as a whole. Now, I'm doing something for you, and make sure that you are understanding what I'm doing. I'm running my piece of code with one cluster and then notifying how the scatterness looks like. With the one cluster, the overall scatterness is 681, which I'm keeping there for you to consider. With only one cluster into the picture, the overall scatterness is very high. Obviously, there would be very different elements if I just have one cluster only. Instead of one cluster, now I'm showing that on 2 clusters. And when I'm getting that executed with 2 clusters, now the scatterness comes out to be 152 instead of 681. Clearly, you can see it is decreasing a lot. We don't create that, Ankit. I'm actually getting this continued. I mean, this is overall data, in fact. One cluster is nothing but the overall data set, right? I'm just getting the demonstration on scatterness. The focus area is this scatterness is what the point of the conversation is. Yeah. So you can clearly see that after splitting the data from 1 to 2, you got a very much achievement into the scatterness. When I'm getting that continued from 2 to 3, you can see this comes out to be 78.81547, or whatever the number is, which I was actually having a couple of executions before.
Just a quick info, guys. Test your knowledge of AI by answering this question. What is artificial intelligence? A. Putting your intelligence into computer. B. Programming with your own intelligence. C. Making a machine intelligent. D. Putting more memory into computer. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Then again, if I will do that with 4 and so on, I can continue to n number of times, which is now getting 57 actually. So there are some inputs which I would like to get this shared with you or convinced that more the number of clusters I am having, I am getting the scatterness being decreased, hence homogeneity is improving. Correct or not? You can clearly see from 681 that got reduced to 152, that further got reduced to 78, that got further reduced to 157. So if you are asking me what is the optimal number of cluster, this is what the basic question is, what Arshad is asking for. Okay, let me put that for you. How to determine the optimal number of clusters. Because too many clusters is also not good and too less clusters are also not good. Everyone convinced with this thought? Too many clusters is not good, too less clusters is also not good, because the clusters are too much, then they would start getting similar to each other and you will end up unnecessarily wasting your resources to tackle each one of them individually. And if the clusters are less than required optimally, then there would be disturbance, dissatisfaction among the clients and the customers, because I would not be able to tackle their requirements in a largest appropriate fashion. Correct, everyone? So I just have to find the optimal number of clusters. And in order to search for the optimal number of clusters, I will be then taking the help of the statistical inputs, what I am now trying to explain to you guys. In this demonstration, I have been running the model starting from 1 cluster, then 2, then 3, then 4 for a potential reason to get you familiar with the results manually. But if I have to get this demonstrated in a decent fashion, there is something called elbow-like chart. This is the fundamental way for me to get to know what is the optimal number of clusters. To find the optimal relevant number of clusters, the answer lies is like elbow chart. What is elbow chart is what you are going to describe and determine. If you look into the code, instead of running the code manually, what I was doing, changing the cluster from 1, then 2, then 3, then 4, I have been simply getting a for loop. I hope everyone knows the relevance and the significance of having a loop based on the perspective I developed at the time I was discussing the loops with you. Do you remember that? When something needs to be done iteratively, repetitively, n number of times, then you would be using the range loop. And this time I am trying to get something being done 10 times starting from 1 to 10. And for that, what I'm doing is running the model with the clusters ranging from 1 to 10 and getting their scatterness being recorded into a bucket in R, which is called as vector. In Python, the very same thing is nothing but a list. So like the way in Python you have a list is what now you have a vector in R. Clear? So don't get lost. So for that reason now, I am now storing all of these scatterness one after the another in this empty bucket called cluster or class, and then plotting a chart, a line chart with the index of 1 to 10 on x-axis and the values of scatterness on the y-axis. Simple. Let me get this triggered. I get an error, but that error is. This is fine. I don't think we have to have an additional one. Yeah, extra bracket was there. That is the reason it was showing me an error. Okay, let's execute it now. Now you can see I got something developed here. And this chart is actually a elbow looking chart, elbow like chart, just like the way you have an elbow in your body part. The way how we can conclude this elbow is, or interpret this chart is, wherever there is a sudden flatness, from this to this, you can see there is a sudden drop. But from this dot onwards, this is getting flattened. Yes or no? This concludes one thing, that if you relate the idea with the points I was discussing, creating the number of cluster or increasing the number of cluster from 1. You remember the first cluster was having the scattern of 681, guys? Do you remember that? So this is nothing but a dot is coming on 681 on the scale you can see. So 681 as a scatterners got reduced to just 152 when you got that increase from 1 to 2 cluster, and that further got reduced to 78 when you got increased from 2 to 3. But after the 3 cluster, even though you are increasing the cluster, you are somehow getting the flatness, and this flatness in the scatterness, this is nothing but scatterness, right? This flatness in the scatterness means and translates into the idea that, boss, even though you are increasing the number of clusters, but there is no improvement as such in the bifurcation, in the homogeneity aspect of the data. So there is no point for me to unnecessarily get the load being extended. So I should be now having the number of clusters being 3 here optimally. So this is what the idea is. Am I clear? So this comes to a fact that wherever the elbow turn comes into the picture, in my case it is 3, this tells me that was 3 is the optimal number of clusters. Statistically, business can say that was you have to get 4 clusters or 2 clusters only. That's a separate thing, because business always overrides the mathematical rules what you have. But at the end of the day, this is what the basic bottom line is. Am I clear now? Let me get this discuss how the k-means works. Okay. Let us now discuss how the k-means algorithm works. Though you are not required to get this manually done, but I am telling you how this works behind the curtains, back end. I'm dropping the 2-dimensional or n-dimensional charts. So let us now try to explore the idea how the k-means works. And to do so, I am getting some data points being generated and reflected on the n-dimensional space. It could have been any number, okay? Just as an assumption I'm sharing with you, keeping it simple for you. The moment you will trigger the algorithm by passing any value of k, like in our case, I can consume it to be 3 as an example I'm sharing. Let us suppose you are running the algorithm by value of k being 3. That means you wanted to have 3 clusters to be there for the data to be splitted. The moment you will trigger the algorithm with the k number of clusters, be it 2 or 3, that many same centroids or nucleus will be randomly dropped, like the way I'm showing to you. Okay, randomly. It could have been at any place initially. So the moment you will run the algorithm, you will get 3 nucleus or centroids, which is actually the epicenter of the clusters getting started creating around them. Based on the homogeneity and heterogeneity, they will be then shifting onwards. How come? I will be explaining you. Just assume that you are somehow trying to get, this object to be identified in which cluster it should ideally fall or counted in. So what the process will start getting to continue is that the distance of this sample will be manually started after finding and doing the comparisons and everything. Whichever the closest distance this is somehow considering, like in my example, currently this falls very closer to green color. Hence, this will then be counted under the green cluster or green group as this. So this is how the clusters are getting generated, evolved, and shifted. How come? Now, because this is a group, so a new centroid position will be redeveloped at a average value, mean position, mean distance. I'm showing you with the striped color. This is actually the new position, which is at the mean value, mean distance value of these 2 clusters. And what does that mean? When you are actually getting any new object to be calculated, like if you are calculating this one, in which group it should fall. So the distance of this will be counted from this, obviously, Okay, let me change the color using the orange one, okay? And now from this at an average mean value. Am I clear? Because it's a 2-dimensional demonstration, complete pictorial flow. Reason being, this comes more reasonable and lucid when you are actually watching the videos. Reason what is interesting is that I would also like you to understand one aspect which I can't really explain it right now, considering the fact that we are going into a 2D description. The object which have been earlier, let us suppose, I'm talking about this. just by any reason, okay? Just assume that. Kindly don't feel like saying that Ankur, this seems more closer to blue, why it is now in green. Don't say that, but just feel about that, okay? There might be a possibility if an object has been earlier allocated to a green cluster after the reshuffling of the group, this can be later on consumed to be into the blue group. So shuffling and the readjustment of the elements also happens because of the homogeneity and heterogeneity and the further fine-tuning and alignment of the cluster. And that is the reason every now and then, every time you are running the cluster, you would be getting the best cluster in a way that each cluster is homogeneous and heterogeneous based on the proximity. Am I clear now? Because their centroid is getting shifted is the reason you can have this, because this will keep on getting the changing, right? So based on that, earlier it might be there into the green color, but later on it could be there into the blue group as well. Sorry for that. Yeah. So I would strongly suggest you guys to kindly please take a look into the complete way and the pictorial flow of how this k-means work. But this is what the idea is. I think I very well explained you what that k and what that means in the data. Means average value. I hope this is clear now. What does that algorithm means? Because you are actually operating on the average distance of the values every time. So this is what the fundamental idea is behind the what, why, and how. I am getting started with Jupyter Notebook, and within that, I have a case study there with me with the name called K-means mall customer data. In this data, I have the details of the customers in my mall with their gender, age, annual spending, and income, spending scores. Like in India, we have the credit card score and so on, based on which you have the spending score. So on the scale of 1 to 100, higher the score is, better he is good in spending. Lesser the score is, poor they are in their spending habits or traits. Considering this data, I am now doing some sort of clustering so that I can see how the data looks like after the clusters are being created. So for that sake, I got this exercise being generated. I will walk you through with each and every single piece and the line of the code there. This file has been properly documented for your further understanding and reference. Like k-means clustering only works with the numeric variables, which is actually a distance-based algorithm. Euclidean distance is the formula runs behind that. So categorical variables at least would not be working in a direct fashion when you are just using the k-means. For getting the categorical variable being enrolled, there are some different methodologies. K-mod is there as an approach. Rather than taking the mean, you are taking the mod. And in this case, because it is unsupervised learning, is a part of the umbrella of unsupervised learning, hence there is no such a targeted y variable to be achieved. Let us now get started. In starting and in the beginning, I am getting the required libraries being imported, that is NumPy, Pandas, and Matplotlib. K-means is the algorithm which comes from a module called cluster under the package of sklearn, which is what you are going to have into the place. Immediately after that, I am getting the mall customer CSV file data being imported into an object called dataset, which is my data frame here. For the sake of our easy understanding, I am just getting continued with only two columns, which is like income and spending scores, excluding rest of the other ones, just to make it more deliberate approach. I'm getting this name of an object called X. It could have been anything. You must also be getting lost and confused why it is X when there is no Y. So don't kindly feel that why it is X. So it is just a name of an object I have been given. Technically, there is no Y, so there is no such a significance here with the name called X. But I'm subsetting my original data for these two only columns to be continued. In this case study, I have been properly aware with the complexity of the data, that there is no missing values, problem of outliers, and so on. Hence, I really need not to get into the trouble of EDA, cleaning, and preparing. But I have written a comment like, if it would have been a new data being exposed, you have to have a proper steps being taken up to understand the data and then to clean it accordingly as part of your usual game in any of the engagement. Then this is way how you are getting started with the k-means clustering, because clustering, getting the clusters being created has never been a challenge. This is number of cluster being 3. You can down the line also be looking at the optimal number of clusters with the elbow-like chart as well. So a couple of the interesting things for you. I got this model and fitting that on the X data. So this is where the model is literally getting built. Plus, after getting this model being built and trained on this data, or executed on this data, applied on this data, you are finding something called inertia in Python. My dear friends, this inertia as a keyword is actually the very same idea and the keyword corresponding to what you have within SS in R. Do you remember that? A measurement of scatterness. So in Python, the only difference is like you have a different keyword, which is like in inertia now, whereas in R, the same thing was being called as within SS. So hence, there is no difference in the concept, but the terminologies are only getting changed. Plus, if you will find and look into the details of this code, where I am finding the optimal number of clusters with the elbow-like chart once again, you will find very much similarities of this code, how it is getting worked there as compared to what you were getting or doing there in R. Similar, exactly similar or almost similar. Let me show you. Here you are getting the empty vector in R being created so that you can store the various scatterness values. But in Python, you are now getting the empty list being created. Can you see that? So whatever exactly I'm doing that in line number 31 here of my R code is what literally I have that being done in this piece. Here also I'm getting started with the range for loop from 1 to 10 because last element is excluded. Running the k-means, and then this is nothing but getting that added into the list with the within SS inertia. What we were calling that as within SS is now being called as inertia. Simply plotting that and labeling that, which will end up giving you this piece of layout. When you will look into the code, in this piece, you have been getting this type of elbow-like chart, which is probably getting flattened from this point onwards. So I can assume that 5 are the optimal number of clusters. And based on that input, later on I started working that with the number of clusters being 5. So this is what the input is. First level due diligence being done. Let me show you what I'm trying to convey. So this is one thing. And when you will look into the k-means as a bottom, then k. So there would be one of the variables which is actually asking for the threads here, initial threads and so on and so forth. So try to read more about that and try to fix one of such variables which is handling the threads here. Thread means parallel computing. While getting the clusters being created, how many parallel computations are being taken up. This is all what it comes across. Am I clear? Threads. Can you see this? Put it -1 there. This has been deprecated actually. And jobs and will be removed. So try to fix this. So yes, that is also correct. I also missed that.
In today's session, we'll be talking about some common machine learning algorithms. Okay, so let's dive in. Okay, so we will be discussing some popular algorithms that are useful for machine learning purposes. So basically, as you can see here, in machine learning, we are having two kinds of learning. Okay, the first one is the supervised learning, and the second one is the unsupervised learning. So what does supervised and unsupervised means? As the name suggests, supervised learning means that we are supervising our model. Okay, we are training our model on top of some data set. Okay, and after training our model, then we will try to predict, we will try to test our model. Okay, and we will see if our model is able to predict the future outcome or not. Okay, and if you talk about the unsupervised learning, so in unsupervised learning, we, as the name suggests, unsupervised means we will not supervise our model, we will not train our model. The model will get to know about the data set itself only. Okay, if you basically here we don't provide any learning to the model, to the machine. Okay, we will just provide a data set to the model, and after providing the data set, the machine, with the help of some algorithms, it can able to understand what the data set is trying to say. Okay, basically we will be analyzing the data. Okay, so let's discuss supervised and unsupervised in detail. So first, let's talk about the supervised algorithm. Okay, so in supervised algorithm, the first set of algorithm that we will talk about here is linear regression. Okay, so what is linear regression? See, basically in supervised algorithm, we are having two kinds of problem. The first problem is the regression problem. Okay, the second one is the classification problem. So what is regression and classification? If you talk about the regression problem, then regression basically deals with some kind of, you can say, continuous set of data. Okay, let's take an example here. If you're having some data set, okay, and in that data set, you are having some like a list of houses. Okay, and then I want to predict what is the retail price of those houses. Okay, so the price there will be a continuous set of numeric values only. Okay, so here we are talking about some regression problem because we have to predict some numeric value, okay, of those houses. So that is why that problem come under the linear regression problem. Okay, so here we will talk about like we have to predict some value. Okay, some value that is not categorical. Okay, categorical means like if you're having some yes or no kind of value in your data set. Okay, let's suppose let's take an example. If you talk about some like if that particular customer is churning out of any company or not. Okay, so this is kind of a categorical set of values. Okay, but here in this linear regression problem we will only deal with the uh, exact values. Okay, the salary of any person, or you can say the price of the houses. Okay, so this is what we talk about in linear regression. Only like they are having continuous set of values we have to predict. Okay, now if we talk about the other algorithm, that is the logistic regression. So as the name is have the logistic regression is having the name as regression, but in logistics we always work with classification data. Okay, the regression name is only present in the logistics part, but we always work with the classification problem. So what is classification here? Let's take same data set only. Okay, the data set that is having list of houses. So in logistic regression, we will try see there will be some retailed price of that particular house. Okay, let's suppose there is a house and that house is having a retail price as $10,000. Okay, so if with the help of logistic regression, we can calculate, or you can say the model can predict that that particular value, that particular house has been sold at a higher price or the lower price. Okay, if you talk that particular house is there. Okay, let's say house number 1 is there. Okay, and in house number 1 you want to like I want to predict, okay, that particular house has been sold at a higher price or a lower price. Okay, so this is what a categorical value is there. Okay, if it is sold at a higher price or a lower price. If you take another example, let's take heart disease data set. Okay, we are having heart disease. So there are many set of customers, many set of patients, the values, the data sets that is having all the value of the customers. Okay, so uh, for that data set, for the heart disease data set, we have to predict, okay, if I'm having these kinds of symptoms, then that particular customer is having heart disease or not. So this is also a kind of classification problem. Okay, because we have to calculate that either that particular customer is having heart disease or not. So this is a categorical value. Okay, so this is what we talk about in logistic regression. We always talk about the classification problem. Okay, that is the categorical values. Then again, our next set of algorithm in supervised algorithm is decision tree. Okay, so if we talk about decision tree, so as you can say, the decision tree means we will be talking about some tree structure here. Okay, so basically a decision tree is also a kind of, in decision tree we can work with classification problem also and regression problem also. Okay, if we want to calculate exact value, or we have to calculate the categorical value, that either that particular customer is having heart disease or not. Okay, so these things we can calculate in decision tree. So let's take an example for explaining the decision tree. So let's suppose there is a bank. Okay, and that bank like I want to build a decision tree so that how my model can able to like there are some customers that want to have their loan approval. Okay, so I want to build a model so that my model can able to analyze, okay, if this particular customer is coming to me and that particular customer wants to have a loan. Okay, so if I give loan or not to that particular customer. Okay, so it will build a decision tree. Okay, like it will see their past loan credentials. Okay, it will see, okay, that particular customer has paid the previous amount of loan or not. Okay, if he has paid, then okay, I will go to the yes part. Okay, I will go to the yes part, and then it will see, okay, if I'm having higher loan or lower loan. Okay, higher means like if that particular customer wants higher amount of loan or lower amount of loan. If yes, if that particular customer is having higher amount of loan, then it will not give the loan. If the particular customer is having lower amount of loan, then it will give the loan. Okay, so this is what decision tree is. It will make some decisions regarding the past history of the data. Okay, it will see the past data of those customers. Okay, so this is what our decision tree is. Then if we talk about our fourth algorithm, that is the random forest. So again, in the random forest, I'm having multiple sets of decision tree. Okay. So if we talk about the random forest, so basically random forest combines the output of multiple randomly generated decision trees. Okay. And it will give our final output. So basically random forest is a group of decision trees. Okay, in decision tree we will only build one tree only, but in random forest we can make 100 trees or 300 trees or 400 trees, and with the help of all those trees, with the help of the combination of all those trees, we can able to predict, okay, if I want to give that particular customer a loan or not. Okay, so this is what our random forest is. If we talk about our naive bias, so basically guys, in naive bias we will be dealing with some kind of uh, like you can say data set that is having we can say okay, so if we talk about the naive bias, so in naive bias is also a kind of the classification problem. Okay, so naive bias basically deals with some probabilistic classifiers. Okay, so if I want to you can say talk about, basically in naive bias we deals with some text classifiers. Okay, we will deal with some text kind of data. Okay, here in the linear regression, logistic regression, if you talk about decision tree and random forest, we work with some kind of data frames. Okay, but in naive classifier we always work with some kind of text categorization. Okay, we are having some text kind of data. You can take all those texts in Excel format, and you can work with that data set, and you can able to predict your the whatever task you are having in your text data. Okay, so these are all kinds of common algorithms that we use in supervised learning. Okay,
the problem statement. So the problem statement is here. Your client is a large MNC and they have 9 broad verticals across the organization. So one of the problems your client is facing is around identifying the right people for promotion and prepare them in time. So it is only for manager position and below. So currently the process that they are following is, first one, they first identify a set of employees based on recommendations and past performance. Then the selected employees go through the separate training and evaluation program for each vertical. These programs are based on the required skill of each vertical. Then at the end of the program, based on various factors such as training performance, KPI completion, employees gets promotion. So talking about the KPI completion, so only employees with KPIs completed greater than 60% are considered. Now this is the actual problem statement. Now let us look at the scenario that is provided by the company. So the final promotions are only announced after the evaluation, and this leads to delay in transition to their new roles. Hence the company needs your help in identifying the eligible candidates at a particular checkpoint so that they can expedite the entire promotion cycle and they can speed up the process actually. So the first thing is they have provided multiple attributes around employees past and current performance along with demographics. Then they have provided multiple attributes around employees' past and current performance. Now the next and the second point is the task that we have is to predict whether a potential promote at checkpoint in the task set will be promoted or not after the evaluation process. Now this is what we have to do. And moving ahead, let's understand the data set and the parameters. So let me go to the training and the testing data set. Now this is our training set and this is our test set. So now let me go to the training set and this is the employee ID. So we are not much concerned about the employee ID. So it will not actually help us in the prediction. This is the department section, including sales and marketing, operations, then technology, analytics, operations, sales and technology, again technology, then research and development, then there is finance, procurement, and so on. There is also a department called HR, and the next one is region. So this is region 7, region 22, region 19, and there are many regions. So region will actually not help us to predict the outcome of the model that we have to build. Then comes education. So education can be the factor for predicting the promotion. So the list of education that is provided over here is masters and above and bachelors. So also here the empty data is there, which means that there is no data provided over here. So we will deal with the missing values also. And then comes the gender. So the gender is male and female. After that comes the recruitment channel, that is sourcing and other.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts. Just a quick info, guys. Test your knowledge of AI by answering this question. In which of the following application does AI has its expansion? A. Planning and scheduling. B. Game playing. C. Robotics. D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
Then comes the number of trainings. So that is 1, 2, and we'll scroll down. It includes 3, the number of training that are provided to the individuals or the employee. Then the next thing is the age. So this is the age of the employee. Then comes the previous year rating. So this can be one of the most important factor in the promotion. So the previous year rating is 5, 3, 1, 3, and so on. And this position or this, so this is 3-star, 4-star, and this is empty. So it denotes that the employee is not at all having a rating. So it can be because the employee may be a fresher. So let's check out the length of service. So here the length of service is 1. So that is why the previous year rating is not shown over here. So we'll sort out this thing also for making the model more accurate. Then comes KPI metrics, that is key performance indicator. So it denotes and it indicates the metrics for the performance of the employee. So 0 over here denotes that the performance is not at all good for giving them promotion, and 1 indicates that the performance is decent enough to give the promotion. Then comes awards 1. So this is 0, 0, 0, and here it is 1. So award 1 is 1 over here for a particular employee whose ID is 77981. And now average training score. So this is the training score of an employee while pursuing a training for the company. Here it is 85, 73, starting from 49, 60, 50, and so on. So it can be a major factor for predicting the promotion for the employees, that is how well they perform in the training and what is their score in the training. Then comes is promoted. So 0 means that they are not promoted and 1 means that they are promoted. So in this data where the promoted thing is 1, so this is the average training score, and here this shows the KPI metrics, that is also 1. Then the next one is the length of service, that is 6 years, and so on. So these are the parameters and the data set on which we'll be working on for making an AI model to resolve the business problem. Now let me go to the training set. So this is the training set, and it consists of, let me go to this part. Okay, so this also consists of employee ID, then department, region, education, gender, recruitment, number of trainings, age, previous year rating, then comes length of service, KPI metrics, awards won, and then average training score. So these are the parameters over here. So we have divided the dataset into train and test set so that we can train the model using the train set, and we can test the model using a separate dataset, that is HR_test. Now the reason for using the test and the train data for the model is that we do not want our model to overfit the data. So in future it may get different sets of data and it may face issues in giving accurate results because the model is overfitting the data set that it is having. That is why we are using a separate data for training the model and a separate test data for testing the model. Now we have understood the data, that is trained data and the test data. Now let us move on to the steps that we'll see further. So the next step that we'll be going through is pre-processing and feature engineering. So in this we'll pre-process the data with using the different types of pre-processing. That is, we will manipulate the data, we will remove the null values and the missing values from the data set, and before that we'll use various and we will import various types of packages that are required for the implementation, and we'll see the info of the train and the test dataset as well as the description such as the standard deviation, the mean and the average of the values. Then we'll perform feature engineering for the model and for the dataset values. Then we'll build the model using various algorithms that are used to build AI based applications, and we'll apply feature scaling so that all the values comes in the common slot and the prediction becomes more. And finally we'll evaluate the model that is created using various parameters and metrics of model evaluation, and then we'll visualize it using models visualization. So further, let's go to Google Colab for the implementation part. Now this is our Google Colab. So first thing you have to do is just go to this folder option, click on this upload session storage button and upload the training and the testing dataset. So I have already uploaded it, so I'll just show you. So I'll scroll down and here is the data, that is train and test data that I'll be using. So whenever you open Google Colab, so the first thing you have to do is you have to load the dataset. Otherwise you cannot work with Google Colab and create algorithms and AI based applications. So also one thing more, if you load the dataset now, so it is for this instance on which you are working. If you will close the tab, then the dataset will be deleted. So again and again you have to load the dataset. Now I have written the code over here, the entire code. So I'll implement and I'll explain every code, what it is actually built for and how it is working. So first I'll import warnings and use this warnings.filter warnings ignore. So this is used to ignore the warnings that are displayed by the interface or by the Python library while implementing the program. So I'll run this and now you can see it has been successfully executed. Now the next thing is the scientific and data manipulation libraries. So I have imported pandas, I have imported NumPy, then import math, GC, OS and the sklearn package. So we use pandas basically for data analysis and data manipulation, and it provides various features for the analysis of data. Then comes NumPy, so we can work with multi-dimensional data and matrix arrays using the NumPy library. Then comes importing of maths that help us to implement various mathematical operations. After that, import GC for the garbage collection, and then importing OS so that the packages and libraries are imported so that the application which we are building using the various modules and libraries of Python, so it gets added according to the operating system. Then importing scikit-learn, that is sklearn. So scikit-learn basically help us to implement classification, regression, dimensionality reduction, and many other machine learning algorithms we can implement using the sklearn or scikit-learn library. So I'll run this, and now the installation of the scikit-learn is done. So I have already done. It may take a while for you to get this. So I'll run this pip install scikit-learn to install the scikit-learn library. So it will take a while and it will get loaded. So these are the basic steps that you need to implement before data pre-processing. So these libraries and packages are the first thing that you have to load and install or download for working further with the data pre-processing task or creating algorithms. Then comes more libraries. So in sklearn, we have pre-processing, model selection, tree, ensemble, and metrics. So from sklearn library, we import the packages for pre-processing and model selection, tree, ensemble, and metrics. So why we do that? Because we have to use label encoder, one hot encoder. We want to use min max scaler, normalizer, robust scaler. Then comes max absolute scaler, and then we used model selection thing for using k-fold, stratified k-fold, train test split, then cross validation score. After that comes the tree package, for which we have to use decision tree classifier, random forest classifier, and then voting classifier using the ensemble package of sklearn library. Then comes the metrics package of the scikit-learn library, using which we'll evaluate, or first we'll load F1 score, then confusion matrix and classification reports that help us to implement the functions for F1 score, calculating confusion matrix for accuracy, and the classification report. So we'll use this from sklearn.preprocessing, import standard scaler, min-max scaler, normalizer, robust scaler, and for loading all these modules from the library, we'll use these commands. So let me run this. So it shows that it is successfully executed. So before moving ahead, let me explain you the standard scaler, min max scaler, so all these, why we are actually using it. So starting with standard scaler, it actually removes the mean and scales each feature or variable to unit variance, and this operation is performed feature wise in an independent way. So standard scaler can be influenced by outliers, so the values lying beyond the common slot of area where the actual values are lying, so it can be influenced by the outliers, and it involves the estimation of the empirical mean and the standard deviation of each feature. So it scales it, so it helps the model to predict in a better way. Then comes min-max scaler. So min-max scaler rescales the data set such that all the feature values are in the same range from 0 to 1. So actually there are too many values and it can have different values from 1 to any of the value. So we need to rescale the value in a common slot such that we can create a plot out of it and gets a better visualization. So min-max scaler helps in this way. After that comes the normalizer. So the normalizer rescales the vector for each samples to have unit norm independently of the distribution of the samples. Now then comes the robust scaler. So unlike all the other scalars, the centering and scaling statistics of this scalar are based on percentiles, and therefore they are not influenced by a few number of very large marginal outliers. Then consequently the resulting range of the transformed feature values is larger than for the previous scalars, and one of the most important thing to note is that they are approximately similar, and for both features and for most of the transformed values they actually lie in a range of -2 to 3. Now coming to max ABS scalar, so it differs from other scalars and such that the absolute values that are mapped, they are in the range of 0 to 1. So they are the absolute values, and on the positive data, the scalar behaves similar to min-max scalar, and therefore it can suffer from the presence of large outliers. Then comes the voting classifier. So the logic behind the voting classifier is creating a separate dedicated model and finding the accuracy for each one of them. So we actually create a single model that is trained by the other models and predicts the output based on their combined majority of voting for each output class. So that is the logic behind the voting classifier, and we'll use this voting classifier for our project. So I hope the importing of the libraries and packages is clear. Now we'll move ahead and we'll import the class and we'll install the cat boost. So I'll click on it. So you have to use this command pip3 install cat boost, as we'll be using the boosting algorithms such as xgboost, lightgbm and cat boost for preparing our model. So it will just take a while to load, and I have already loaded this and I have downloaded the packages related to cat boost. That is why it is showing requirement already satisfied. Then I'll import the xgboost and use an attribute that is xgb for it. Then lightgbm and then cat boost. So I'll click on it and it is successfully executed. So why do we actually use XGBoost, LightGBM and CatBoost? So XGBoost is a scalable and accurate implementation of gradient boosting machines, and it has proven to push the limits of computing power for boosted trees that are used for implementing the algorithms for the sole purpose of checking the model's performance and improving the model's performance and the computational speed. So that is why we use XGBoost. So also XGBoost is used for supervised learning problems where we use the training data to predict a target variable. So that is why XGBoost is used for building the AI models. Then coming to LightGBM, that is a gradient boosting framework that uses tree-based algorithms, and it is designed to be distributed and efficient with the following advantages, that is faster training speed and higher efficiency. Also, it has support of parallel and GPU learning capable of handling large-scale data. So that is why LightGBM is used as a classifier. Then coming to cat boost algorithm, so it is an algorithm for gradient boosting on decision trees. So it is basically used for search, recommendation systems, personal assistant, self-driving cars, weather prediction, and many other search tasks. So one of the major benefit of using cat boost is it can handle missing values internally. Also, by default, cat boost uses one hot encoding for categorical features with a small amount of different values in most of the modes that we use. And so coming to one hot encoding, we use it for all the categorical features with a number of different values less than or equal to the given parameter value in a specific range. So we'll use all these algorithms for our AI project for building our model, and I hope you are clear with the algorithms that we are using. So let me run this and you can see it is being successfully executed. Now I'll run this. That is from XGBoost we are importing XGBoost classifier. So it is also successfully loaded. Now comes the data visualization libraries. So we will use matplotlib, seaborn and plotly package for the data visualization. So I'll run this. Okay. Now comes the randomness of the data that is being selected. So we'll use np.random.seed. So it is actually used to save the state of a random function so that it can generate same random numbers on multiple execution of the code on the same machine, or it can be on different machine. So the seed value is the previous value number generated by the generator. So that is why we'll use this np.random.seed. After that, we have to set the location path from where we'll use the dataset. So we have already loaded the dataset, and you have to do it again and again for the Google Colab if you are using Google Colab. So now I have already imported OS. So It is just written over here. From Google Colab, import files, then train pd.readcsv is used to load the dataset. I'll run this and let us see. Okay, so it is being successfully executed. Now we'll display the dataset of train and test. So we use this display function to display the values. So I'll run this and it will display the training values and the testing values. So let me scroll down. So the first one is training value and the second one is the test values. The second one are the test values. So this shows the index. Now employee ID, department, region, education, gender, recruitment channel, then number of trainings, age, previous year training, length of service, KPI metrics that is greater than 80, and awards 1, average training score, and is promoted. So as we have already discussed the training dataset, and the KPI metrics should be greater than 80% to get the promotion. So here it is. Now let us check out the test dataset. So again, these are the index, employee ID, department, region, education, and it will not have the is promoted column because this is the testing dataset. That is, these are the independent variables using which we have to predict whether the person has to be promoted or not. That is the variable is promoted. Now further, let me go to the exploratory data analysis that we have to perform. So for this, first we have to look into the information of the training set. So for this, we'll use train.info to display the information of the trained data. So let me implement this. And now we get the training data. Along with it includes the non-null count and the data type. Also the count of the types of data type, that is float 64 is 1 time for the corresponding column, and it is previous year rating, and integer is 8 times and the object is 5 times. Also it shows the memory usage, that is over here it is 5.9 plus MB. So this shows the information related to train set, and then let me display the information related to the test data. So here it shows that there are 23,490 entries starting from 0 to 23489, and data columns total there are 13 columns, and non-null count along with data type and the count of data type over here, and the memory usage is 2.3 plus MB. So this is the information regarding the test and the training data. Then comes displaying the descriptive statistics of train data. So just talking about exploratory data analysis, so it is a part of the data pre-processing where we actually gather the information related to the data. So we check the info, we check the description of the data such as the average, the maximum and the minimum values, along with the mean or the standard deviation, the type of data, memory usage, and the non-null count, and many other factors. So we look into that in this data pre-processing step, or you can say the EDA, that is exploratory data analysis. So let me run this train.describe. So it shows more information related to the training dataset. So it shows the count, it shows the mean for all of these columns, then comes the minimum value, maximum value, and the interquartile range. Now let me check the description about the test data. So I'll run this, that is test.describe. Again, it shows the count, the mean, the standard deviation, minimum and the maximum value, and the IQR, that is interquartile range. So this shows us the description of the train and the test data.
Okay guys, a quick info, if you're looking for an end-to-end training in artificial intelligence, Intellipaat provides a master's in artificial intelligence in collaboration with IBM, which covers everything you need to know about AI. So the details are available in the description box below. Let's continue with this session.
Now further we'll display the number of unique values and the actual values. So we have to first define a function def for defining the function, that is display unique, and it will take the argument as data. So here we have passed the argument of train data. So display unique, we have called the function. Now what does this function do? So for column in data dot column, that access the columns present in the data set. So we have to print the number of unique values in the column, that is the column corresponding to the trained data set that we are accessing to. Then the columns are then using the str function data, then column dot n unique. It will fetch the unique values from the data set or from the column. Then the actual unique values in column. So again, now further to get the actual values, so here we use again the str function and then the sort values function that sorts the data in the ascending order, because the ascending is set true over here. So for getting the actual values, we have to use this sort underscore values function, and this na underscore position takes two strings, input last or first, to set the position of null values, and accessing this unique function gives the unique values from the data set. So it shows the number of unique values simply, and using the sort values function we can access the actual values in the column. So let me execute this, and now here we get the output. So number of unique values in employee ID are 54,808. So starting from 1 and it goes till this index. So these are the actual values, and then comes the number of values or unique values in department column, that are 9. But the actual unique values in the department column are analytics, finance, HR, legal, operation, procurement, R&D, sales and marketing, and technology. So the actual values are shown over here. So these are the actual values. So this is how we actually access the actual values using the sort underscore values, and we can keep descending also over here, but we have kept ascending order. So these are the actual and the unique values for all of the columns of the trained data set. So we can check it for test, but we'll leave it for now. And now we'll move on to displaying how each feature is related to the target variable in a flow. So for this we will use a plot using the parallel categories diagram. So the parallel categories diagram actually it is also known as parallel sets, and it is a diagram, or you can say a visualization of multi-dimensional categorical data sets, and each variable in the data set is represented by the column of rectangles, where each rectangle corresponds to discrete value taken by that variable. So here we pass in the columns. So the columns are department, education, gender, previous year rating, KPI metrics, then recruitment channel, and is promoted, and color is based on the is promoted column. Then we use the continuous color scale. So using this sequential.agrenil, so we plot the figure using multiple colors. So this figure.show help us to show the figure. Now let me implement this and let us have a glance at the figure that we get. So it will just take a while to load. Till then you can just wait. Okay, this is the figure that we had. So this figure is very descriptive and it shows you the data. So let me show you how you can actually read this figure and how actually you can understand the various dependent or independent variables from this figure. So there are columns named department, then education, gender, previous year rating, KPI metrics, recruitment channel, is promoted. So is promoted is shown over here. So it consists of the value as 0 to 1. So hence its scale is from 0 to 1. And then comes the individual categories of the columns. So in department, there are multiple departments such as sales and marketing, operations. So this section is the operations one. So you can see when I have kept my pointer over here, so it shows the relation, actually the data relation from other columns such as education, gender, previous year rating, KPI metrics, recruitment channel, and is promoted.
Just a quick info, guys. Test your knowledge of AI by answering this question. What is artificial intelligence? A. Putting your intelligence into computer. B. Programming with your own intelligence. C. Making a machine intelligent. D. Putting more memory into computer. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
So the count it shows is 11,348. That is, there are 11,348 employees for the operations department. When I kept my mouse pointer for sales and marketing, it shows the count as 16,840. And then comes the count of this sales and marketing, and then technology. So the count is, let me click on this. So the count is, you can see over here. So this shows the count as 7138. Then comes analytics, that is 5352, R&D, which is the least, and then procurement, finance, HR, and legal. Now coming to education, so when I kept the pointer over here, so it shows the count for the masters and above degree as 14,925. So here the category is written over here. Then when I came to this bachelor's, it shows the count as 36,669. Then coming to below secondary, it is 2409. And then the final one is the below secondary one, and this, so this last one is the below secondary one, that is 805. Now coming to gender, then the count is 16,312, and the count for the male employees is 38,496. Now previous year rating starting from 5. So the employee who are having the rating as 5 are 11,741. Then 3, rating of 3 is 18,618 employees are having a rating of 3. Then 1, it is 6223. Then rating of 4 is of 9877 employees. After that, the rating of 2 is 4225. Now the KPI metrics greater than 80. So for 1, that is the metric, KPI metrics is greater than 80, the count is 19,291. And for the employees for whom the KPI metric is less than 80% are 35,517. Now again, the recruitment channel is sourcing, other, and referred. So for sourcing, it is, the count is 23,220. Then for others, the count is 30,446. Then for the referred one, it is 1142, that is the least. Now I'll come to the is underscore promoted column. So the count it gives is 50,140 people are not promoted, that is the value is 0, and the promoted people's count is 4,668. So you can see over here the structure of the figure. Now for the next one, we will have a heat map. So we will display the correlation between the features through heat map, and lighter color, higher correlation, and if close to 1. So lighter color shows the high correlation. So for this we use sns.heatmap, and as we are making the heat map for the train dataset, so we'll use this train.corr for correlation, and this annotation or anot is true. So I'll run this and we'll get the heat map. So here are the employee ID. So these are the columns: employee ID, number of training, age, previous year rating, length of service, KPI metrics greater than 80%, awards won, and then average training score is promoted. And this scale shows the is promoted thing starting from 0 and 1. So the values are only 0 and 1. Now the x-axis of the figure, so it is not actually x-axis, but it is the other side of this figure. So it has again employee ID, number of trainings, age, and previous year rating, length of service, KPI metrics, then awards won, and average training score, and is promoted. So a heat map is a two-dimensional graphical representation of data where the individual values that are contained in a matrix are represented as colors. And the Seaborn library, we have imported it for this purpose, and the Seaborn Python package allows the creation of annotated heat maps, and which can be tweaked using the matplotlib tool as per the creator's requirement.
Just a quick info, guys. Test your knowledge of AI by answering this question. In which of the following application does AI has its expansion? A. Planning and scheduling. B. Game playing. C. Robotics. D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
So we are creating this for the correlation, finding the correlation. So this color shows us the correlation between all these parameters that we are evaluating. So this is the heat map that shows the people who are promoted, or not the people who are promoted, but the correlation between these columns. Now let me go to the next part, which is finding the duplicate rows from the trained data if it is present. So we have to check for duplicate rows to remove them. So we will create a method that is remove duplicates that will have an argument of data. So in this we'll print before moving or before removing duplicates the number of rows, comma data dot shape. We'll give the argument as data dot shape. Then we have to implement the logic or the action, that is data dot drop duplicates. To drop the duplicates, keep equal to first in place equal to true, and then again we have to print after removing duplicates the number of rows. So again the argument is data dot shape. So actually this data dot shape returns the data in the form of array, and then we'll return the check duplicates. And now I'll just implement this, run this, and now I'll call the remove underscore duplicate and give the data or the argument as train. And now I'll click on this. Further, after the successful execution of the code, we'll get this. Before removing duplicates, the number of rows are 54,808, and after removing the duplicates, the number of rows are again 54,808. Now it will return the checked duplicates. After that, we'll handle the missing values. So remember that still we are in the data pre-processing or the manipulation part. So we have to deal with the missing values. So missing values are present in the previous year rating and education columns in both train and the test data. So here I have just written for the reference why is data missing in column previous year rating. So data was not entered because those employees were fresher. So as I have already told you when we were discussing and when I explained you about the data set, so data was not entered because those employees were freshers, that is length of service is 1 is equal to 1, and they did not have the previous year rating. So the no data would have been there in the data source itself for these employees. So logically we are imputing with 0 as freshers with 1 year experience and may not have previous year rating at all. So filling the missing values in train and test data. So what we'll do is we'll use this train dataset and the test dataset, and in this bracket we'll give the column name, that is previous year rating. And what we'll do is, again, to access the previous year rating, so we are actually accessing the previous year rating, and then we'll use this dot fill na with 0, so it will fill those values with the 0. So the next thing is, we'll access the column of fresher for the train dataset, and then we'll use this previous year rating and apply function, and then we'll use this lambda. So here we'll put the condition, so if x is equal to 0, then the employee will be a fresher, otherwise the employee is an experienced professional. After that, we'll display the fresher column with the value counts, and again the previous year rating, length of service, and this fresher tag that we have used using the condition that is applied over here for marking the tag as a fresher. Again, we'll use this display function to display this previous year rating, length of service, then fresher for the first 25 values, and for this we'll use this head function. Now I'll run this, and here we get the output. So these are the columns, and they are replaced by the values as 0, 1, fresher. So this is the fresher column, and this is the fresher tag that we have displayed using the display function and putting the condition over here. So the experienced professionals are 50,684 and the freshers are 4,124, and the data type is integer again. So we have used the previous year rating, length of service, and the fresher column for displaying the data. Now again, we have displayed the data for previous year rating, length of service, and this tag I should have changed it to experienced. So okay, so I have put a condition over here, so let me go to that one. Okay, so here if x is equal to 0, then it will be a fresher, otherwise experienced. So that is why it is showing data over here for experienced as well as for fresher, and the length of service, previous year rating. So this is actually about the removal of the missing values and sorting out the missing values that were there in the data set. So we actually saw some empty blocks in the data set, so we filled in with the values as 0. So for that we used fill na and filled with 0. So this is done. Now next what we'll do is we'll display the missing values in the train and test data. So to display that, we'll use this display function, and this will give the text as train corresponding to the missing values in train set. So we'll use this train.isNull.sum. So isNull for counting the for getting the null values, and sum function to sum all those, and to display it we'll use this display function. Same for the test. So I'll run this.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So for training set, so this is employee ID, department, region, education, gender, recruitment channel. So for all other columns, the null values, so there are no null values, there are 0 null values, but for education there are 2409 null values present. And for the test column, the employee ID, department, region, and all other columns are not having any null values. The count is, or the sum of those null values is 0, the count is 0. And for the education it is 1034. So as the test dataset is less than the training dataset, so it is showing less. So we have counted the null values over here. So now after executing this, let us handle the null values. So for this we'll use ffill, bfill. So I've written this for a reference, so you can read this. So talking about ffill, so this is forward fill, that fills the missing values with previous row value, and if previous row value is null, then it moves to the next element without filling. That is why we use ffill and bfill both. So what does bfill do is, so it is backward fill that fills the missing values with next row value, and if the next row value is null, so it moves to the next element without filling. So what actually happens is, for example, for just explaining you, if the system goes to 4th and 5th row and the 4th one is empty, then it iterates to the 5th row and fills the data of the 5th row into the 4th row. So this is actually the backward fill. And in forward fill, what happens is it fills the missing value with the previous row value. For example, if 4th row is having a data and 5th row is empty, the data is not present, then the value present in the 4th row will be added for the 5th row data. So we use both forward fill and the backward fill to fill in the data. Also, filling with mode and new category called others are most commonly used technique which didn't work here, so we are not using that. So we can assume that while collecting data relevant members, data were collected close to one another, so it is not too fluctuating, that means. So talking about the training, now we'll fill in the values for the education column. So here we have used this train, inside it we have given the argument inside the square brackets as education. Then we'll use this dot ffill for forward fill, and we give the argument in this way, that is access is equal to 0 for all of the train and the test data. And finally we display the data and we try to actually calculate the sum of all the null values that are present in the training data set and the test data set using the isNull and sum function. So I'll run this and let us see the output. So it will just take a while to load. So here we get the output for the train and the test data set. So employee ID, department, region, education, gender. So you can see over here, so we have implemented it on the education column by using the forward fill and backward fill. So the count has come down to 0 for the education column. Now after this we'll work on feature engineering. So based on the age distribution, most of the employees are in the range 20 to 40 who will be also waiting for a promotion. And so we have created 2 bins, 20 to 29, 29 to 39, and remaining 1 bin for 39 to 49. So we have used dist plot, so plot a univariate distribution for the observations. So I have written this for the reference so that you can refer it in future if you have any doubt and all. So you can see the description of this. Okay, so moving ahead, we'll use this sns.distplot and we'll give the train as the data and this age column, and after that we'll use this train, and inside this square brackets we'll give the age. We'll use this pd.cut and give in the argument as train and the age column. So the train data set along with the age column, or for the age column, and bins will be 20, 29, 39, 49, and labels that would be given to these bins are 20, 30, 40. Same for the test one. For age column, pd.cut, bins will be 20, 29, 39, 49, and the labels will be given as 20, 30, and 40. So let me run this, and now we'll get the plot like this. So feature engineering is nothing but extracting the feature or the properties from the data set and the expertise and the knowledge that we have. So this is the plot that we have after plotting the age column Now after this, we'll split the train data into predictors and the target, that is independent and dependent variables. So this is the step that we have to do before creating our model. So here we'll split train into x underscore train, that is features, and y underscore train, that is target. So in x train, we'll select all of the columns, that is department, region, education, gender, recruitment channel, number of trainings, age, previous year rating, length of service, KPIs, metric, that is greater than 80%, awards won, and average training score. And in this y train, we'll select the is promoted column, that is the separate column that we have to predict using the test dataset. So we will add this in the y train section, and then we'll convert the y train into a frame using 2 underscore frame, because it is a single parameter and the output is expected to be in data frame. So we'll use this to convert it to a frame. Now comes the x test. So we'll use this x underscore test, and inside it we'll give the argument or the number of columns, that is department, region, education, gender, till average training score. So now we have successfully splitted the train and the test data. So after running it, so it has no error, that is it has been successfully executed. Now as we have splitted our data set into train and test, now we'll perform the data encoding using the label encoding and the one hot encoding. So what does it actually mean to perform these operations? So actually label encoding refers to the converting of the labels into numeric form, so that to convert it into the machine readable form, and the machine learning algorithms or the AI algorithms that we are using for building our AI based application can then decide in a better way on how those labels must be operated. And using one hot encoding allows the representation of categorical data to be more expressive, and many or the various machine learning algorithms cannot work with categorical data directly. So the categories must be converted into numbers. So this is required for both input and output variables that are categorical. So we use one hot encoding for that. So we'll define a function that is data encoding, and given the parameters or the arguments, that is encoding strategy, encoding data, and encoding columns. So let me go down and check where I have called this. Okay, encoding data encoding. So I'll check where I have called this function. So this is data encoding, I've called over here, then encoding strategy, and then the data, then the columns that we have to give. Now I'll go back over here. Now what does this function do? So if encoding strategy is label encoding, then we have to print if label encoding, and the encoder we have to put in the label encoder because we are using label encoder. And then we will put a for loop over here. So for column in the encoding columns, we have to print column, then encoding data, and in this encoding data the column will be inserted, and then this function has to be executed. So encoder.fit transform, and then the argument must be given. So tuple encoding data, again we'll use the column as the argument. After that, if this is not true, then we put in elif condition where encoding strategy is equal to one hot encoding. So if this is the scenario, then we have to print elif one hot encoding, and then encoding data we'll use pd.getDummies for encoding data. So this PD is the instance of the pandas library, and this getDummies will give us the categorical values, the dummy categorical values. And after that comes the dtype list that we have to define for float 64, float 32, int 64, int 32 for the data type. So this is the data types list. Then encoding data as type will use, and then data types list, and then we'll access the data types. So after implementing if elif. These two lines of code will be implemented, which shows the data type, and then return encoding data. So using these condition will implement the data encoding technique. So here for description I have added this quote and many points related to it. So let me read it for you. So applied one hot encoding, it will be applied to object categorical columns only, and it's most common to one hot encode these objects columns since they can't be plugged directly into most models. Then pandas offers a convenient function called getDummies to get one hot encodings. So using this getDummies, we get a dummy variable or a dummy value for the categorical or for the encoded values. So get this using getDummies. And many machine learning algorithms cannot operate on labeled data directly. Then they require all the input variables and output variables to be numeric. This means that categorical data must be converted to a numerical form, and a one hot encoding can be applied to the integer representation. Finally, this is where the integer encoded variable is removed and a new binary variable is added for each unique integer value. So you can go through this description for the reference. So I'll run this. So it has been successfully executed, and you will get the result in the next code when we'll implement it. So just for reference or example, I have added the data encoding for this color, that is red, blue, green, red, blue, green. And I have created this df as the data frame, and then pd.dataframe. I have given the data over here columns as color. Then I'll print before one hot encoding and call the function as displayDF, and then I'll print after one hot encoding and display pd.getDummies. So for the first one, so we get the result as before one hot encoding, it is displaying the data frame, and in the second one we get the result after one hot encoding. So I'll run this in one go. So let me explain this one also. So encoding columns, encoding strategy. So I'll go in this code. So we have created a function data encoding, and the parameters are encoding strategy, encoding data, encoding columns. So over here are encoding columns, encoding strategy. So encoding strategy is label encoding, one hot encoding, and the encoding columns are region, age, department, education, gender, and recruitment channel that we have to encode. So while implementing this, we have to just give in the index. So here I have called the data encoding function that we have defined earlier. So xtrain encode, xtest encode, and we have called data encoding and data encoding strategy. So index is 1 and the data is xtrain and encoding columns. So it will take the entire column, so all of the columns, and then the second one is encoding strategy xtest on xtest and encoding columns. So it will take all the columns. Then for displaying the encoded train and test features, we'll use the display function and we'll display the first few values using the head function. So xtrain encode, xtest encode. So let me run this, and the first one gives the color data frame, that is red, blue, green, red, blue, blue. So these are encoded in 0, 1, 2, 3, 4, 5. So we have performed one hot encoding, and after performing one hot encoding we get the following results, that is color blue, color green, color red. So these three are the colors, red, blue, green, and these are the indexes, and the encoding that is done is, so this is the data frame. So we have converted it into a data frame, that is why it is showing a data frame over here. So color blue, color green, color red. So this is these are the encoded values for it. Now let me go up and let me check. So this was the color part, and then we defined the encoding strategy. Then we have called data encoding 2 times, for train and test, and it is showing one hot encoding, one hot encoding. So it has performed one hot encoding. So why it has performed? Because the index that we have given over here is 1. So here it is 0, label encoding is 0, having an index of 0, and one hot encoding is at the index position 1. So one hot encoding will be performed. So for performing one hot encoding, first it will print LF one hot encoding that shows that it is performing this type of encoding, and then it has performed the one hot encoding using the pd.getDummies. So it is displayed over here. So these are the result for the encoded rows, the columns that are over here. So you can check it out, the encoded values. So we have encoded it for region, and then it shows various region and the values, then for gender, recruitment channel, and so on. After that, after the encoding has been performed, so our data is encoded, and now we have to perform scaling. So we have already discussed about the scaling types, that is robust scalar, standard scalar, min-max scalar, and max ABS scalar. So I have told you about these type of scalars. So we will directly create a function using this data underscore scaling, and we'll give the argument name as scaling strategy, scaling data, scaling columns, and we'll give in the condition as if scaling strategy is robust scalar, then the scaling data will be, and inside this square brackets we'll give the scaling columns that we need to scale, and then we'll use the robust scalar dot fit transform to scale the values using the robust scalar, and then the scaling data which we have used and we have passed in the argument, and the scaling columns that we need to scale. Same with the standard scalar. So we'll give in the condition as LF. So scaling strategy, if scaling strategy is equal to standard scalar, then we have to use this standard scalar dot fit transform, and again the scaling data along with the scaling columns, or you can say the corresponding scaling columns.
Just a quick info, guys. Test your knowledge of AI by answering this question. In which of the following application does AI has its expansion? A. Planning and scheduling. B. Game playing. C. Robotics. D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
That we have to put in over here. After that, again LF scaling strategy is equal to min-max scalar. Now same with the min-max scalar and max ABS scalar. So scaling data, then scaling columns, then again using the fit underscore transform method and given in the parameter as scaling data with the corresponding scaling columns that we need to scale. And final else condition consists of the robust scalar. So if any other scaling sent by mistake, it still performs the robust scalar. So we'll use the same line of code that we used for robust scalar, that is scaling data, corresponding columns, and then robust scalar function dot fit underscore transform, and finally we'll return the scaling data. So I'll run this and let's check. Okay, so it has been successfully executed. Now the next one is where we will call the data scaling function or the method. So this is the data scaling method that we have created over here. So this is the description that I have given for reference. So let me read for you. So robust scalar is better in handling outliers. So standardization of a dataset is a common requirement for many machine learning estimators, and typically this is done by removing the mean and the scaling to unit variance, and the outliers can often influence the sample mean variance in a negative way. So in such cases, robust scalar, which uses the median and the interquartile range, often give better results. So here we have defined the scaling strategy. So that is robust scaler, standard scaler, min-max scaler, and max ABS scaler. Now we'll use this X train scale and X test scale as the variable or the instance, and we'll store the values after calling this method, that is data scaling. We'll pass the argument as scaling strategy, that will be 0 in the first one and 0 in the second one. So 0 indicates that it is calling the robust scaler. So we have created the scaling strategy and we can call any one of this. So we have called the robust scaler. Then here we have given the X train encode and then X train encode columns. So what it actually shows is we are scaling the encoded values of train and the test dataset that we have encoded in the previous steps. Okay, then we'll display this X train scaled value and first few values of it for the train and for the test. So it should be test over here. Now let me run this and let us see what we get as the output. So this is the number of training previous year, length of service, KPI, metrics, award won, average training, department. So now we have successfully scaled the values using the robust scaler. So what actually is robust scaler doing over here? So you already know. So it is handling the outliers and it is making the model more accurate and helping us to create such a model to give more precise results. So this is done. Now comes the most important step, that is creating baseline ML model for binary classification problem. So we will use some machine learning algorithms and you can also say that AI algorithms. So we have already looked around it earlier, that is XGB classifier, then cat boost, light GBM. So here we will create a dictionary, that is key value pairs for ML model name, and then ML model functions with hyperparameters. So these are the hyperparameters. So we'll given the name as classifier and at the 0th index we'll give the XGBoost. First will be cat boost, second will be light GBM. So using this XGB classifier we'll define the hyperparameters, that is learning rate, n estimators, max depth, subsample, verbosity, scale, position weight, updater, base score. So the learning rate over here is 0.1. The number of estimators are 494. Maximum depth is 5. Subsample is 0.7, that is 70%. Then verbosity is 0. So what actually verbosity is? So verbosity in keyword it arguments and it usually means that showing more wordy information for the task. So actually giving the more description. Then the scale position weight, that is 2.5. Updater is grow hist maker, then base score is 0.2. So we'll see the plot which will be plotted. Then it will be same for the cat boost classifier, learning rate, number of estimators, subsample, max depth. Then for light GBM, the importance type come in for extra. Then verbosity is -1. So you can see over here the verbosity is -1. Here it is 1 or 0. Sorry. So here it is 0. Here it is 1. So the more is the verbosity, the more wordy or the descriptive is the model, or you can see it is more adaptive and it shows the more information. So here it is -1, so it is low. Then maximum number of bin is 60, number of leaves 300, boosting type is Dart, learning rate is 0.15, number of estimators are again 494, max depth and other things are same as the cat boost and XGBoost.
Just a quick info, guys. Test your knowledge of AI by answering this question. What is artificial intelligence? A. Putting your intelligence into computer. B. Programming with your own intelligence. C. Making a machine intelligent. D. Putting more memory into computer. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Now, after creating a dictionary, after creating baseline ML model for the binary classification, we'll print. So we have to use this list, then classifiers dot keys and classifiers dot values for it. So after implementing it, let us see what we get as the result. So XGBoost, CATBoost, Light GBM, and this is what we get. Now our model is created and there are so many parameters to evaluate it. So base score, booster, column sample by level, and so many others. But we need to improve our model, as no model is perfect in AI or machine learning. So what we'll do is we have to improve the machine learning or the AI model. So as we have used this machine learning algorithms, so it is same for AI also. So I have written over here the ML model. So to improve the ML model with voting classifier, with model evaluation metric, we'll use this F1 and predict target for S promoted. So we'll evaluate the F1 score. So actually what voting classifier is, we have already discussed in the previous section while importing the libraries, modules and packages for the voting classifier. So we'll use the instance or the variable as voting model, and then we'll use the keyword that is reserved by the library or the package, that is voting classifier, and the estimators will given as the XGBoost, and then the second argument will be then list classifiers dot value to fetch the values, and for 0th index is the 1 for XGBoost, and the 1 or the first index is for CATBoost, then Light GBM. Then we have given over here as soft voting, and the weights are given over here 5, 5.2, 5, 5 and 5.2. So actually in soft voting, the output class is the prediction based on the average of the probability given to that class. And you can consider an example. Suppose you are given with some input for the 3 models and the prediction probability for class 1 and class 2. So if the probabilities are 0.1, 0.2, 0.3, and for the next one it is 0.2, 0.3, 0.4. So obviously the average of the second class is greater. So the winner is the second one. So this is the soft voting that we call in machine learning. So it is given over here. So then we'll use this voting model that we have created and use this fit method, and inside it we'll give the parameters as xtrain scale for the scaled values that we have created in the data engineering process, and we'll give in the y train for training the model. Then we'll evaluate the predictions of the voting using the voting model that we have just now created dot predict probability, and we'll give the x test scale for checking the performance of the model on the basis of test dataset. So we'll take the entire test dataset. So let me run this, and it will just take a while to get executed. So now get the output. So you can see over here. So the learning rate and the total time, remaining time. So you can see it is still executing. Now again it will take time. So let me tell you the next part that we'll implement. So next we'll work on the result. We'll see the result and try to improve the F1 score. So for this we'll, okay, it is completely executed. We see the values. So it took a total of 10.4 seconds to predict the outcome, or to learn the features of it. Then the next part that I was talking about is the result and the improving of F1 score. So for this we have to round off the probability results, and for this we'll simply use an instance as prediction, and we'll give in the round function, and before it we'll use the integer that converts it to the integer, and then we'll have a for loop. So for value in predictions of voting that we have just now implemented for the voting model or the voting classifier, so predictions of voting will be counted over here, and then we'll create a data frame table for this result, and we'll store it in the result promoted section. So we'll use this pd.dataframe, and we'll give in the employee ID and is promoted, and it will have the predictions and the test set of the employee ID. Then this thing you need not to take care of. These are again the classifiers, and then you have to print list classifiers keys over here. So this will be same as previously we have used the classifiers over here. So this is the same thing. Now let me implement it and let us see the results. So list of classifiers, so XGBoost, CATBoost and Light GBM. Now next we'll print result promoted. So I'll type in print, then result, and now I'll run this, and you can see employee ID and is promoted. So these are all the IDs of the employees who are being promoted. So here you can see that the ID number 5973, so employee corresponding to this ID has been promoted. So this is how we implement it and get the result using the round of probability. Now next we have used the classifiers, that is classifier 1, classifier 2, classifier 3 for XGBoost, then Light GBM and CATBoost. So we are fetching the values and the index as same. We have used 0, 1, 2, and then we have used the array from the NumPy library and given the index over here, and then finally use the voting classifiers, and we have given the estimators as XGBoost, CATBoost and then LGBM for classifier 1, classifier 2 and classifier 3 represented by CLF 1, 2 and 3. Then voting again is soft. Then we will predict the class probabilities for all the classifiers using the predict underscore prob function and giving in the argument as X, and using the classifiers for the XGBoost, CATBoost and Light GBM along with the voting classifier that we have built over here. So all this we are using for predicting the probability. Now to get the class probabilities for the first sample in the dataset, we'll create two classes and then we'll create a 2D array and put a for loop where we'll use the probus instance that we have used for predicting the probability for the model using various classifiers. So these two has been created, and now we'll plot what we have created or what model we have created. So we'll plot. So we'll use n equal to 4, that is number of groups, then ind instance for np.arrange, so arranging these groups, and these are the group positions, and width will be 0.35, that is bar width. Then we'll use figure and ax as the instance for the subplots. So we'll use the plotly package. So plt.subplots is the function that we have to use, and then bars for classifiers 1 to 3 and bars for voting classifiers. So for classifiers 1 to 3 we'll use the instance of p1 and p2 and use this ax.bar function where ax is the instance, and bar is the function taking the parameter as ind, that is the group's position, in np.hstack that takes the class probabilities that we have created, and the index -1 shows that it is taking all the values. Then the width is 0.35, then color, h color, and same for the second one, that is p2, where we'll use the second class that we have created. And for the bars, for voting classifier, we'll use the p3 p4 instance, we'll create it, and ax.bar, where bar is the function that we are using and ax is again the instance, and here the parameters are quite different, that is ind is same, but here we are giving 0 0 0. So instead of hstacks, that is np.hstack, we just given the values as 000 because it is a voting classifier and we cannot use hstack in it for this scenario. So the color is quite different, and now we'll set the plot annotations using the axv line. So it takes the argument as the value 2.8, color equal to k, line style equal to dashed, and then ax.set underscore x ticks with ind plus width. So it is a matplotlib function that takes when the values are true and a minor tick when the values are false. Then set the x tick labels for xgboost, catboost, lightgbm voting classifier, and the rotation will be 40. And now we'll give the y limit, that is 0 to 1, plot title, that is class probabilities for sample 1 by different classifiers, then plt.legend, that creates a legend for any plot, so for p1 and p2, and the values given over here is promoted no and is promoted yes, then location is upper right, then plt.tight layout, that helps to automatically adjust the subplot parameters according to the padding. Then finally we'll use this plt.show to show the plot. Now let me run this. So this is the final step of building our AI model and optimizing it using various feature engineering processes, classifiers and encoders. So this is the class probabilities for sample 1 by different classifiers. So here the dark green color shows the people who are not promoted and the light green color shows the people who are being promoted. And this is the voting classifier and its average probabilities. So this is the visualization of the probabilities for the employees who are being promoted and who are not promoted, but the actual values we already saw using these classifiers over here. So there are 23,490 records of 2 columns consisting of employee ID as it is unique. So it shows the corresponding ID and the promotion status of the employees. So I'll just go up. So here we have created the model and we saw that the model took 10.4 seconds, and this is the learning of the model we have created. The model using the voting classifiers and XGBoost, CATBoost, LightGBM, gradient boosting or extreme gradient boosting instead of that. And after that we have the results and we worked on improving it. Then we get the result of promoted, and finally we have visualized using the plot our results. So this visualization of the data is just for our understanding, but how actually is the code implemented using the algorithms in real time is by integrating it using other softwares. So company will not use this code directly. So what they will do is they will create the model using the code that we have built, and then what they'll do is they might have another application that shows the information of the employees and their various parameters such as age and other things that we saw. Let me go to that section where we have looked around the data. So employee ID, number of training, age, previous year rating. So they might have an application that show the data. So there they can add a feature that predicting the promotion, and whenever they click on that, so this code is added in the backend. So before it shows the prediction of the employees or before it shows the list of the employees, this code is being implemented and the results are shown on the interface. So this is how artificial intelligence or machine learning algorithms helps the company to resolve the issue for their various business problems. So here it is the status of the promotion, whether the employee has to be promoted or not. So it is not about this problem. There are many real life business problems that can be resolved using artificial intelligence and machine learning. So these algorithms and these methods are added in the pipeline of a static software or an application, and it gives the output and the result that is the best prediction according to the analysis using the algorithm along with using the data set that is being provided by the organization, and it makes that software or the application as AI based application. So this is how we implement various scenarios using artificial intelligence.
Okay guys, a quick info. If you're looking for an end-to-end training in artificial intelligence, Intellipaat provides a master's in artificial intelligence in collaboration with IBM, which covers everything you need to know about AI. So the details are available in the description box below. Let's continue with this session.
Just a quick info, guys. Test your knowledge of AI by answering this question. In which of the following application does AI has its expansion? A. Planning and scheduling. B. Game playing. C. Robotics. D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
And then we need to understand why we require artificial intelligence. Guys, again, head to the comment section and let me know your top reasons of why you think we require artificial intelligence around us. I mean, human beings are the most intelligent species out there as of now. I mean, sure, that's debatable, but as of now, that's how it stands. Well, so why do we need artificial intelligence then? Well, let me tell you, humans are the most intelligent beings, but then there is only so much that we can do. For example, consider handling a huge amount of data, right? So in this world we live in, basically we live in a world which is a big data problem. So we have terabytes, we have hexabytes, we have petabytes worth of data coming in from each and every Fortune 500 firm, pretty much every single day, every single hour of every single day, in fact. So this data is growing exponentially, and then when the data is growing at this rate, you cannot expect a human being to be on the other side all the time to handle it. So this exponential growth of data is handled by machines very easily. And then when we talk about the variety of data as well, let's say you need to go on to merge some data, split some data, basically bifurcate some data. There are varieties of data. There's unstructured data, semi-structured data, structured data. So it might not be possible for one human or a team of human beings to basically go on to do this with the amount of data I just told you, right? So when you think about it practically, the variety of sources through which the data comes in is again unlimited almost. So having a machine on the other end of it to take the brutality of the variety of sources, the types of data, the amount of data is going to make life more efficient for the employer as well as the employee. And then we come to processing speed.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors, and industry experts.
Yes, again, I'm going to restate the same thing. Human beings might be the most intelligent beings out there, but then we do have machines which can be exponentially faster than humans when it comes to certain basic things, let it be mathematical calculations or anything as such. So, this will provide unparalleled performance when we have to compare a human being's work directly to an artificial intelligent being's work. If we have to go on to directly juxtapose them. So, this brings us to artificial intelligence developers. Who are these guys and what do they do? Well, you need to know this. Again, AI developers are basically computer science based people, and these people have to do a lot with coding. Programming languages such as Python, languages such as R, and many other programming concepts. So why do they need all this programming? Well, this is basically to ensure that they can design, maintain, test, evaluate all the artificial intelligence solutions that certain organizations need. So let's say again, the AI technology which has gone into building Siri at Apple might be extremely different, is definitely very different than the technology which went into Tesla's autopilot, right? So these developers need to understand what the problem is, make sure they can formulate the problem and then formulate a solution for that problem as well, right? So designing a solution for an artificial intelligence requirement, and in fact maintaining that product after it's been designed, and evaluating to make sure that it is performing right where it should, is again very important aspects of an artificial intelligence developer. And I have a quick question for you guys on that note. So I'm pretty sure most of you guys use social media, right? It might be Facebook, it might be Instagram, it might be Twitter, and it might be all the other fancy social media apps out there. Coming to Facebook, let's see how AI developers pretty much work out here, right? So AI developers are pretty much responsible again to handle about 350 million photos a day which has been uploaded to Facebook, and they do a lot with face detection and image recognition as well. So let's say you and your friends decided to go on a vacation. Let's say there were 10 people of you and you clicked about 300 pictures. Now imagine tagging 10 of these people in all the 60 pictures, right? So again, 600 tags you have to do manually, and this is going to take many hours if you have to do this. But then Facebook already would understand who the person that is in the picture, where the picture was clicked, and much more. That is what geotagging means, and location options too. So this is told to you very subtle. It says, hey, was the picture clicked here? Is this person that? I mean, it'll show you the name of the person and it'll show you the location as well, and you might be like, yes. So at that point of time, you might not recognize and realize the power that's working behind it to get you all the details, right? Again, and another important thing is automatic friend suggestions, right? So let's say you added someone on any of their other applications. Now Facebook owns WhatsApp and Instagram. So let's say you're in touch with someone on WhatsApp where you've saved their number or something. Facebook will tell you, it'll give you a friend recommendation saying, hey, why don't you add that person on Facebook as well? So imagine all the processing that goes behind this particular thing. I mean, it's so subtle, as I mentioned on the first slide, that we don't even know it's there anymore. And then when you talk about Instagram, see, there are 95 million photos which get uploaded to Instagram, and handling that is definitely a task, right? And the best thing that Instagram is known for these days is customized advertisement. So you go to Amazon, you're searching for the latest mobile phone, or you're searching for a mobile cover, tempered glass, whatever it is. As soon as you come back to Instagram, it's going to show you one advertisement which is beautifully put together. You'll feel like clicking on the advertisement. Basically, that's how customized these advertisements are. And again, face detection and object recognition as well. So that plays a very important role in Instagram. Location recommendation systems, again, it'll just tell you where the photo was clicked, what time the photo was clicked, and much more. Friend recommendation again. So let's say again you added someone on Facebook, or you guys just let's say there are two people who use Instagram. You guys have talked on another social media, but then you guys decided to meet for breakfast or dinner or whatever. And as soon as you come back to Instagram, it's going to give you a friend recommendation saying, why don't you add this person on Instagram? Again, how does this work? Artificial intelligence is at play, my dear viewers. And then coming to Twitter, Twitter handles pretty much 6,000 tweets per second. Again, there has to be some form of pretty much, a pipeline, a channel for the data to flow through in and out of the Twitter's storage area, where pretty much they need to understand, they need to work with this data, because it's not all about storing the data when it comes to Twitter, right? Because they perform sentiment analysis of every single tweet. They check if the tweet has a positive sentiment, a neutral sentiment, a negative sentiment, and what pretty much they can check to the depths of what person in which area liked or disliked this tweet in the on the face of the globe, basically. So this will add power to their organization. This will make sure that marketing can be done using Twitter, and in fact, at the end of the day, you're bringing more sessions to Twitter and they are happy. Coming to outreach analytics and customized marketing, again, pretty much it'll tell you who your audience is, when they're watching your tweets, when they're reading it, and why as well, right? So coming to data analytics, again, you can pull out any number of statistics you want with respect to sentiment analysis of any tweet that's present on Twitter, guys. So think about it. We never knew a simple tweet can have this much of a complex circumstance in the back end when we talk about data and artificial intelligence, right? So this brings us to the most important aspect of this video, guys, which is the skills needed to become an AI developer. And let me tell you about 3 important skills that I think you should have. And the first one is all about mathematics and all about algorithms, guys. Because at the end of the day, you need to understand how numbers can in fact be used to achieve artificial intelligence. There is so much that you might not know, and to the intermediate level viewers, pretty much you will know how much of importance mathematics and statistics play a role. And then coming to algorithms, all the machine learning algorithms are again one step closer to making the machines intelligent. All concepts such as machine learning, deep learning, neural networks, all these are work under the same umbrella of artificial intelligence. All of these terms that I told you, all of their goals is to achieve artificial intelligence at the end of the day. So having very good mathematical skills and being well versed with the top algorithms which works with, again, based on statistics, is very vital. And second of the 3 most important skills is probability and statistics, guys. Why did I mention statistics again? Well, it is that important. You need to understand all the concepts, everything from the basics of correlation, all the way till how you can basically churn through data and make sure the data will give you insights that the naked eye might not tell you at all. So that is one of the reasons why statistics is extremely important. Coming to the world of probability, again, we need to sometimes understand that the values can be continuous, the values can be discrete. We need to find out what a possibility of occurrence of something is, right? So that, again, pretty much an artificial intelligence algorithm of today will not give you 100% accuracy all the time. It will give you an accuracy of 80, 90, 95, 98%. Again, this 98% is 9 on 10 probability. So it says that there are chances that it might fail 2 times out of 100 times. Again, probability, right? So this is a very important second skill to have. Coming to the third most important skill is having the knowledge of a programming language, guys, because again, there are languages like Python and R which form a very strong requirement when you have to learn about artificial intelligence and to help you become an AI developer. And you can either go on to learn Python, you can go on to learn R, but then beginners do prefer Python because R actually has a steep learning curve which some of the beginners might find difficult. But then do not worry, you can pick up either Python or R and you can be on your way to become an AI developer. And then coming to what R is majorly used for, well, R is actually used to do a lot of data plotting, a lot of statistics, and it involves a lot of bringing mathematics and programming together, is what I want to tell you guys. And then in a gist, again, most of the companies which basically has open positions for AI developers has these roles always present. So you need R and or Python, you're going to need statistics, you're going to need to work with algorithms, machine learning, and so much more. And on that note, here is a step-by-step guide on how you can become an artificial intelligence developer. Let us begin with step 1. Step 1 is pretty much, again, you understanding data structures in detail. You might be wondering why you need data structures, right? Again, if you understand how your data is stored, how your data is talking to the other entity that is present next to it, then you will understand how you can increase the performance of an algorithm by making it improve itself by drastically changing its understanding of its neighboring data. So understanding the right data structure, understanding when to use what data structure is extremely important, and this is step number one. Guys, I urge you guys to pretty much whip out your pen and paper or make notes of these, as this will help you a lot in case if you guys are considering to becoming an AI developer. Coming to step number two, again, as I mentioned, programming. So Python and R are the biggest names when it comes to a programming language to help achieve artificial intelligence, and programming knowledge is vital, guys. It is necessary. There is no work around this, and in fact, it is so much fun to work with, and I've been working on this for a couple of years and I absolutely love it. So working on Python, working in R, there are libraries for machine learning. There is TensorFlow, there's scikit-learn, there's PyTorch for neural networks, there's CNTK, that's the Microsoft's cognitive toolkit, and there are much more. There is Staffy, pretty much, guys. If I have to go on to naming the frameworks, I can keep on going. So when you think about this, there are so many things out there that you need to know, and this already forms the step number two. So what comes after this? Well, step three is understanding a little bit of mathematics, guys. You need to have some sort of clarity on how numbers can actually be used to drive a data-driven entity into making it self-sustain, because at the end of the day, statistics will play an extremely vital role in making sure your machine understands what's going on in it and derive some sort of continuous or differential inferences based on that. And then this brings us to step number four. Step number four is the most important part, ladies and gentlemen, because here again you will be finding a problem. This is how you have to go by with step number four. Find a problem which needs a solution. Let's say it might be a new startup that your friend is starting, or you just spotted a common problem across your daily life. So find that problem and make sure that you can formulate the problem and understand what the actual problem is. Now find a solution to that problem, and after you found the solution to that problem in a general human way, try to see if you can get the machine to do it. If you can implement artificial intelligence to do it almost as good as you, if not better, then your job is done. But then you need to understand that at the end of it, you becoming an artificial intelligence developer. So telling the world about it is again very important as well. So there is this website called as Kaggle, where pretty much it's an amazing community where people pretty much come together, give out their problems, give out solutions. There are challenges that you can take place in, and basically it's like a GitHub for programmers. Again, GitHub is the same thing, but when we talk about it, Kaggle is a little different, and I'm sure you guys will know how when you go on to explore Kaggle, which is your step number 4. So coming to step number 5. Step number 5 involves you to understand a little bit of cloud computing, because again, in today's world, half of the organizations we see around us are already scaled to the clouds. So everything from Amazon Web Services, we have GCP, which is Google Cloud Platform, we have Microsoft Azure, and much more. So taking artificial intelligence and scaling it right up in the sky through the clouds is now booming. And as my dear viewers, I have to tell you that having a good certification which will train you on all of these concepts is extremely vital. Working on AWS, working on GCP or Azure or any of these, so having cloud computing knowledge and bringing it together with artificial intelligence are very vital. And coming to step number 6. Step number 6 is again an important aspect for an AI developer, because not only you'll have to work with one single computer at point of time, you'll have to work with multiple entities, multiple computers, because at the end of the day, you're going to use this to exponentially increase your computing power. And this is basically done to understand how you can gain some sort of systematic knowledge onto scaling this artificial intelligence entity that you're developing onto a modern infrastructure. This is very vital, guys. So to revisit all the steps, here's a recap. Your step 1 will begin by understanding data structures. Step 2 with a programming language and some libraries. Step 3 is mathematics and statistics. Step 4 is finding a problem, analyzing it, and solving it. Again, the next step involves scaling artificial intelligence to the clouds, and the last step is to understand how you can make use of artificial intelligence on multiple machines at the same time, which is basically distributed computing. And To basically strengthen everything that I've said, here are some of the sample job descriptions that we can check out. So here's a job description for an artificial intelligence developer from the Penn State University in the United States of America. Their requirement is this. They say proficiency in Python is needed, experience with machine learning library TensorFlow, Infinite Cafe is needed, and pretty much they say proficiency in mathematics is needed, as we discussed, linear algebra, multivariate calculus, and much more. Skill is required in JavaScript or R, as we discussed, data structures, and ability to communicate technical topics to the people who might be non-technical audiences. And then cloud computing, AWS, as I told you, right? So we discussed all the 6-7 points, and again, you can see just in one job description, we can see all those 6 points reflecting onto us, right? And then in fact, coming to a researcher's jobs, we just checked out the artificial intelligence developer role. Let's check out the artificial intelligence researcher's role. Again, this comes from the Massachusetts Institute of Technology. It's called the Lincoln Laboratory. These guys as well, they require you to have experience in machine learning software, PyTorch, TensorFlow, MixNet, Scikit-learn, and much more. They would appreciate if you guys had experiences in working with large computer vision data sets, experience with big data, Hadoop, Spark, Elasticsearch, Cassandra. You'll be able to work in a multidisciplinary team environment. You have to have very good communication skills, oral skills, and sometimes you might have to travel as well. So guys, when we think about these two job descriptions of an AI developer and an AI researcher, again, when you come to think about it, we have validated all the points that we pretty much just discussed, right? And this brings us to the most important part of our live session, which is pretty much to tell you what the average salary is. So here is the average salary, guys. So pretty much again, when you think about it, the average salary of a junior AI developer is somewhere around $80,000 in the USA, 7 lakhs per annum in India, 45,000 pounds in the UK, and then a senior AI developer has somewhere around $115,000 in the US, 15 lakhs per annum in India, and 60,000 pounds in the UK, guys. So these are some of the very big numbers that you can see when we talk about AI developers, AI researchers, and then as I told you, this is a very lucrative career that you can pretty much jump onto, guys. Coming to the first question on these top deep learning interview questions set, the first question is, what are the differences between machine learning and deep learning? This is a very common question that's asked, and it is very important that you know the basic differences that lie between machine learning and deep learning. One very good commonality is that both of these are actually subsets of artificial intelligence, and deep learning itself is actually a part of machine learning. So when we talk about machine learning, we're making sure that we find a way where we're training machines with a lot of data. We give it some data and we hide some data from it, in fact, and we use the hidden data later, which we also call as the testing data, to make sure that the machine learns something, and to verify if it has actually learned from its experience. When it comes to deep learning, we try to find methodologies and ways where we can sort of trick the machine into making it think like a human being, making it use the human brain structure in terms of working. In the concepts of neural networks, the entire concept is named after neurons and the use of neurons as well, just because how very similar to how it works in the human brain. So this forms to be the basic difference between machine learning and deep learning. Moving on to the second question, it says, what is perceptron? Perceptron is a very important concept in deep learning because it actually matches what we see in an actual neuron in a human brain. So coming to how it works in deep learning, a perceptron actually receives inputs from a variety of entities, and then later it takes these entities, applies some transformations on it, what we call as functions. It applies functions on this, and then it becomes the output. So input, perceptron, applying function, output. That is how the order goes. So if you have to talk about when perceptron is mainly used, it is actually used when we go on to perform binary classification, where we use an input, we try to see if we can classify something based on the output. There's so many factors when we talk about the functions as well. There is weights, there is biases, and there's a lot of things in a neural network in deep learning that has a lot of impact. And in this system itself, perceptrons play a very important role to take an input and transform it and work on it to give you a valid output in the case of classifiers as well. Now coming to question number 3, it states, how is deep learning better than machine learning? Both deep learning and machine learning are very powerful in their own ways. To solve most of the complex problem in a very simple way, machine learning has got it covered. But then when you talk about deep learning will overpower machine learning, especially when it comes to working with data that has huge number of dimensions. Think about an Excel sheet which has about, let's say, 100 columns with 35,000 entries each, something like that. So when there's a lot of data in your data set and the dimensions are very large, deep learning will be exponentially efficient at working with things than compared to machine learning. So if your data is large, then a deep learning model will work very efficiently to actually solve it, handle it, and it'll make it easier for you to program and work with it at the same time as well. So this is how deep learning is having the upper hand over machine learning in a very simple and a concise way. Now, moving on to the fourth question, it states, what are some of the most used applications of deep learning? Again, this is a very common question that can be asked in your deep learning interviews. So at least make sure you mention at least 3 or 4 fields, and in fact I've put up around 6 fields on the screen right now. Everything from sentiment analysis, mostly Twitter, and all of that. Then we have computer vision to analyze graphics. Then we have automatic text generation, we have object detection, we have NLP, natural language processing, and image recognition. There are more fields. You can name about 10 to 12 offhand if you have worked a little bit on deep learning, but then it doesn't really add a lot of value if you just list 10 to 12. So rather just tell 5 or 6 and just explain 1 or 2 lines about what each of them mean. That way the interviewer has an idea that you are concrete with respect to all the concepts there as well. Now with this we can come to question number 5 that states, what is the meaning of overfitting? Overfitting and underfitting are actually two very common issues that have to be dealt with whenever you're working with data sets and whenever you're working with deep learning. Overfitting, as the name suggests, is a scenario where you have a deep learning algorithm and your deep learning algorithm is looking very hard into your data and it is trying to hunt for meaning. It is trying to find some meaningful correlations in between the data in the data set. Now, in a way, what happens in overfitting is that it'll start vigorously hunting for the data, and this makes it pick up noise, what we call as noise, rather than any sort of useful data. So with this noise, it hurts the efficiency, it hurts the detection capacity of the model. So rather than picking up any useful valid information, your model will start picking up noise, and that is not a good thing. So what happens is, at the end of the day, you'll have a very high variance in your data and a very low bias. This way, of course, you would already know that your model will be very, very inaccurate in terms of detection and very inefficient at detecting new things, even if it has a good level of accuracy as well. So when you think about it, overfitting needs to be fixed, and underfitting is just the reverse of this. Anyway, coming on to the 6th question, it says, what are activation functions? Activation functions are very important entities in deep learning because these are the actual functions that will take your input and make sure that you have something usable on it. So the transformations that happen, right, it is all because of the activation function. So what an activation function is basically is that it has the capability to decide if a neuron actually needs activation or not in that particular array, in that particular set of neurons, to see if there has to be anything modeled from that particular neuron in the chain in the neural network, or if it adds a value to the next set of neurons as well. So this is actually done by calculating the weighted sum of it and then taking the bias as well. So at the end of the day, whenever you're making use of an activation function, the model output will be non-linear. And if you have to talk about the types of activation functions as well, so there's rectified linear unit, or ReLU for short. You have softmax, sigmoid, linear, tanh, and many others as well. So it adds value that you answer it in a way where you tell what activation functions are, how they're calculated, what the output will look like, and what are the types of activation functions as well. With this, we come to the 7th question that states, what is Fourier transforms that is used in deep learning? Fourier transform is very, very vital to deep learning because it is one of these packages that is used to manage and work with a lot of data when we work with deep learning. As you already know, in deep learning, we will be working with huge data sets. So we need methods and tools and techniques where we can process these in real time, and we can make sure that we can handle it and work with it easily and quickly as well. So Fourier transforms is one of these packages that will make sure that you have high efficiency whenever you're working with data. And with Fourier transforms, your model is now open to a lot of signals where you can have the data processed from multiple entities, and to just make sure that you're opening up a dimension when you're working with the data as well. So Fourier transforms are a very, very vital part of deep learning. Now with this, we can come to question number 8 that states, what are the steps involved in training a perceptron in deep learning? There are about 5 to 6 steps whenever we have to talk about the perceptron learning, or training a perceptron as it's also called as, and these are the 5 steps. Firstly, the first step is always to initialize all the thresholds and the weights of the network. Then of course we'll be providing the actual inputs. The outputs are calculated based on a lot of things, and we have back propagation, all the algorithms that run in the back end, and after which we'll have the steps where we'll be upgrading the weights in every single step. So after the weights are upgraded, then we'll again provide another set of inputs. We'll be calculating the weights again, and this goes on from the starting initial node all the way till the last node of the output neural network. And this is how simple it is to actually train a perceptron in deep learning. Now with this, we can move on to the 9th question that states, what is the use of the loss function? Whenever we talk about neural networks and deep learning, we need a methodology, we need a number, we need a numeric where we have the ability to see if the model is working towards its goal or not, right? So the loss function is a measure of accuracy here as well, because we're trying to see if the neural network actually learned something useful from the data or not. And a loss function is a negative metric where if the loss function's value is less, then it's good for the model. If the loss function value is high, it means that the model is not performing well. So at all times, it is very vital that you mention that the loss function has to be kept to a minimal extent. Now with this, we can come to the 10th question that states, what are some of the deep learning frameworks or tools that you have used in the past? Now this is a very common question that's asked in the interviews, because they want to find out, the interviewers want to find out about the experience that you have with all of these tools. So just make sure to mention of all the frameworks, tools and techniques that you might have used in your projects or your certification programs, or whatever it is that you have used, the methodologies that you have used to learn. Of course, there are many top deep learning frameworks out there. We have an entire video on that on the channel as well, so make sure to check that out after this video. Among the top deep learning frameworks, we have TensorFlow, we have Keras, we have PyTorch, we have Caffe2, we have CNTK, that's Microsoft's cognitive toolkit. Then we have MXNet, we have Theanon, we have many others. In fact, you can list about 12 to 15 very good top deep learning frameworks out there. But then just make sure to mention 3 or 4. But then if you of course used more than that, then do make sure you mention that as well. But then make sure that you are very honest about it, and do not I would suggest that you do not state a deep learning framework that you might have not used, as that might lead to you being asked questions on that, and you not being able to answer as well. So make sure to take care about that. Now with this, we can come to the 11th question that states, what is the use of the swish function? So the swish function is nothing but an activation function, as we discussed a while ago. So it's something called as a self-gated activation function, and it is developed by the people at Google. So one thing to note about the swish function is that it is extremely popular because Google has put up a very good claim that it outperforms all of the other activation functions that exists today in terms of efficiency. So we discussed the different types of activation functions as well, right? Tanich, Relu, and all of these. So then Google came about, they devised an algorithm, the activation function algorithm, and they have put up saying that this will outperform everything else that already exists. So that is one of the reasons why this particular activation function has seen so much limelight as well.
Just a quick info, guys. Test your knowledge of AI by answering this question. What is artificial intelligence? A. Putting your intelligence into computer. B. Programming with your own intelligence. C. Making a machine intelligent. D. Putting more memory into computer. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Now with this, we can come to the 12th question that states, what are autoencoders? Autoencoders itself are artificial neural networks, and this is something which is very important that you know. And of course, they do not have any supervision, as they have the ability to automatically try and map inputs and to find out outputs and work with it on their own. So it's a very interesting concept to work with autoencoders, and these are very efficient as well. But then when we talk about autoencoders, it is very vital that we talk about two important things. One is the encoder and one is the decoder. These two are the very important entities that we have to discuss about. An encoder will make sure that the input is taken and it is converted into a format which is understood by the neural network into an internal computation state, of course. And then we have the decoder, which does the exact opposite of this. It will take the computational state data and it will make sure to convert it back into the output. So encoders, even though the name only has encoders, there are two operations that's going on. One is the encoder operation and the other one is the decoder operation. Now with this, we can check out the 13th question that states, what are the steps that have to be taken whenever you make use of a gradient descent algorithm? There are actually 5 to 6 steps that have to be discussed whenever we talk about initializing and making use of the gradient descent algorithm. The first step is always, you have to initialize all the biases and weights for the network as well. And after you have initialized all the biases, you have to send the input data throughout the network, which forms to be, of course, the input layer, the first layer of your neural network. And then we'll actually calculate the loss function, right? So you'll have an expected value that you're expecting at that point of time, and there will be a value which is predicted by the model as well. So calculating the difference between this will give you the error of how far away the neural network is from the actual goal. Now, after that, you will actually change all the values in the neurons to make sure to find ways where you can minimize this loss function, this difference that we just found out in step 3. And after which, of course, this entire process is an iterative process. You'll be looping it and doing across multiple iterations to find out what biases, what weights, and how best you can do to keep the loss function at its minimum. So these are some of the steps that have to be followed whenever you're working with gradient descent algorithm as well. So with this, we can come to the 14th question that states, differentiate between a single layer perceptron and a multi-layer perceptron. We already discussed that, if we're talking about a perceptron, in case if it's a single layer perceptron, it will not have the ability to classify non-linear data for us, but then a multi-layer perceptron completely can, classify non-linear data. And a single layer perceptron is a bit limited in one aspect where, the number of parameter that it takes in is very less when you compare to a multi-layer perceptron. And this in big deep learning models can have a very, very, disastrous effect as well for efficiency, for effective working and whatnot. So again, for the second point, I think multi-layer perceptron wins. And when you talk about the third difference, of course, a single layer perceptron has many things that it can do well. But if we are talking about efficiency when making use of large data, again, a multi-layer perceptron of course takes the higher end because it is extremely efficient to work with in the case of large data sets. Now with this, we can come to the next question that states, what is data normalization in deep learning? So data normalization is a very, very important step. It is actually a pre-processing step where we try to make sure, we can move around the data, rearrange the data, and we can make sure to refit and pack this data into one particular range. This is the entire process of normalization. Why we do this is to make sure that if your data is in one particular range, it means that your network has the ability to learn very effectively and be very efficient as well. So when you're performing steps like backpropagation, having a data in a very structured range, a specific range, will make sure that your network can learn that much faster as well. So these are one or two reasons why this pre-processing step that we take called as data normalization is very important. Now with this, we can come to the 16th question that states, what is forward propagation? So backward propagation is the scenario where we work from the output layer to the input layer, and here in forward propagation it is the exact reverse. We follow in the order of the neural network. So we go from the input layers to the hidden layers and then the output layer. So when you're talking about a complex neural network, there'll be more than one hidden layer. So for every hidden layer, the output of the activation function is actually calculated, and this is done until the next layer can actually be processed. The reason they call it forward propagation, as I just mentioned, is to make sure we work from the input and towards the output, and this is the exact opposite of the backward propagation algorithm as well. So to make sure that we use the output of the activation function and to calculate it for the next layers, forward propagation is very, very important. Now with this, we can check out the 17th question. Again, coming back to the very main important question, your interview could start with this question itself. What is backpropagation? So backpropagation, instead of talking about what, the first thing you have to always discuss is why backpropagation is even important, right? So it is to make sure that we keep the loss function or the cost function less, and to see how the values changes whenever we, work with a variety of biases, a variety of weights. Whenever we change all of these, even a slight change can have a very big impact on your model. To understand how these work, we require the backpropagation. It's called backpropagation, of course, because it starts from the output layer, works backwards towards the input layer direction. So how is backpropagation calculated? Well, it is very easily calculated whenever you work by understanding the gradient that is calculated at every single hidden layer itself. So it's as easy and straightforward as that. Now with this, we can check out the 18th question that states, what are hyperparameters in deep learning? So when you talk about hyperparameters, even though the term is very complex, they're nothing but variables that are actually used in deep learning to actually determine the structure of a neural network. So these variables are put into place to make sure that we have an easy way of understanding so many different factors and parameters in the deep learning model, be it the number of hidden layers that are present, or the learning rate of the model, and much more. So hyperparameters are very important variables that will give us a lot of insight into how the model or the neural network is functioning as well. So moving on to the next question, it states, how can hyperparameters be trained in neural networks? So training a hyperparameter is very important, and understanding how you can convey this to the interviewer is also very important, because these are long procedures and your ability to concisely answer it is very important. So, to train a hyperparameter, we'll require 4 very important components. It's the batch size, the number of epochs, and there's something called as the momentum, and there's a metric called as the learning rate. So what happens in batch size is that we'll take the input, we'll split it into batches. Batch size can be varied depending on however it is required based on the efficiency and a lot of other things. These batches can be cut into further sub batches as well, if that is the requirement. So instead of pushing all the input into a concurrent pipeline, we just make sure to dig it up into batches and then vary it across. Now when you talk about epoch, an epoch is basically a denotion of how many times the training data is run through the neural networks where it can train. So the number of epochs is the number of iterations at which the neural network trains as well. So it's an iterative process. The number will depend on so many different factors. Doesn't mean that if you have a large number of epochs that your model will be very, very accurate with every single iteration. It will go up to a point, and then of course your model will work in fact in the opposite direction. Now when you talk about momentum is actually put into place where we have an idea to check out what happens in the next consecutive steps. Whenever data is being moved around in a neural network, it is vital to understand what happens next, right? So there is no point if your model is very inefficient, where it's passing around data and not driving any momentum from it. So momentum is this particular track where we make sure we understand what's happening next as well. Now coming to the last component, it's a very important component. It's the learning rate. Learning rate is what we are all after when you work with deep learning, because this is used as a very important parameter where we're trying to denote what is the time that's required to actually update all the parameters when your model learns, and when your neural network is ready to take in certain inputs and give you meaningful outputs as well. So these 4 form to be very, very vital, very important components in the world of deep learning whenever we go on to train hyperparameters. Now with this, we can come to the 20th question that states, what is the meaning of a dropout in deep learning? Now dropout might seem like a very common term, but it is actually a technique in the world of deep learning. Dropouts are a very important technique in fact, because these are used to avoid overfitting. Overfitting and underfitting are common problems, as we discussed a couple of questions ago. So to avoid overfitting, to make sure that your model doesn't hunt for noise, what we actually do is we purposefully remove a bit of data which might not be useful for the model to learn as well. So if you have a dropout value to be very low, low, it'll have a minimal effect on learning because you're not removing enough data and your model can still go towards overfitting. But then if you remove a lot of data, then what will happen is the model will not have enough data to learn. So it'll underlearn and then cause inefficiency as well. So this value, right, this drop off value should be very, very vital, because if you have it too low, it will not have an impact. If you have it too high, then your model will not learn effectively anymore. So understanding this is a key concept. Now, coming on to the 21st question, it states, what are tensors? Tensors, you might have heard of these. These are another name of arrays, guys. So tensors are actually multi-dimensional arrays that are mostly used in deep learning, where we have to represent data across either one dimension or in fact multiple dimensions as well. So why can't we just call them arrays and not tensors, right? So tensors have the specialty of a name because they have been very famous. They have been very vital whenever we work with data of higher dimensions. So one very big advantage when we talk about tensors is that whenever we make use of it in any of the programming languages, right, the syntax is very readable. It's a very high level syntax. So what that does is it gives us a clear picture of tensors, even though if we do not have very high amount of training in terms of making use of tensors or its terminology. As soon as we look at the programs, we'll have a keen idea about what tensors are and what they might be doing in the program as well. So this is one very good advantage when it comes to working with these multidimensional arrays called as tensors. Now we can move on to the 22nd question that states, what is the meaning of model capacity in deep learning? Model capacity is again a very important metric that we have to discuss about, because model capacity deals with the capacity of the model to actually take in a variety of mapping functions. So how many mapping functions can your model handle? How many can it concurrently work with as well? One thing we drive out of this metric is that higher the model capacity, it literally means that there is a large amount of information that can be stored and worked with in the network. If the model capacity is low, as the name suggests, it means it cannot handle and effectively a large amount of information at a time as well. So model capacity is something which is very straightforward, but yet it forms to be a very important concept in deep learning. Now with this, we can come to the 23rd question that states, what is the Boltzmann machine? Boltzmann machine sounds very complex, but it is actually a type of a neural network, that we call as an RNN, or a recurrent neural network, where we make use of binary decisions, biases, and to do a lot of functioning and working for us as well. So Boltzmann machines are, like as I mentioned, RNNs. They are hooked together to create something that we call as DBNs, or deep belief networks. So these deep belief networks are extremely sophisticated. They have multiple number of hidden layers, and they're put into place because we have complex problems that require effective solving. So the entire goal of deep learning, in fact, is that we have extremely complicated problems and we need to find ways to make use of the power of computing to simplify that to a good extent for us, and a Boltzmann machine will do exactly that. Now, after understanding this, we need to check out what are the advantages of making use of one of the top deep learning frameworks out there called TensorFlow. So, of course, this could be a very important question in case if you work with TensorFlow, because understanding the advantages of it is very vital. So TensorFlow has many advantages, and to me the most important advantage is where it will give you a lot of flexibility and platform independence whenever you're working with it. The platform independence is very vital because we all have multiple operating systems, multiple platforms that we work on, and of course, so it has the ability to power through and train on both CPU and your graphical processing unit as well. And with new technologies with GPUs, it just makes it very efficient to work with tensors too. And then when we talk about auto differentiation and the features it brings with it, is again a huge impact. When we talk about threads and its ability to handle asynchronous computation, this is where TensorFlow wins over many other deep learning frameworks as well. The second most important advantage to me is that it's open source. It has a beautifully large community, so you don't have to pay for it, but then at the end of the day, there are so many things that are being added in terms of features, technologies, fixes, and so much more. And this entire community of open source is just a beautiful thing, and I'm sure you can relate to this if you work with TensorFlow as well. So with this, we come to the 25th question that states, what is a computational graph in deep learning? So a computational graph, as the name suggests, is a scenario, or is a graph itself, where we try to take inputs, arrange them into meaningful entities called as nodes, and later create a graph structure out of it. So these are done to simplify certain mathematical calculations as to visualize them better. So in terms of deep learning and in terms of backend functionality, it helps a lot whenever we're working with parallel processing, as it provides a huge performance boost over a single threaded performance in terms of making use of actual computational graphs, as your processing power is now 2, 3, 4, 5 or 10 times 10 folds better than how it was before as well. So computational graphs are very important units when it comes to working with deep learning. Now, we can come to the 26th question that states, what are CNNs? CNNs and RNNs.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Are very different types of neural networks. CNN stands for convolutional neural network, while an RNN stands for recurrent neural networks. Now, coming to the talk of CNNs, CNNs are mostly used to perform visual analysis or working with a lot of images and classification as well. You can have multiple images of many channels as well. So when we talk about images and channels, mostly we talk about colored images and black and white images. Colored images will have like 3 channels: red, green, and blue, RGB structure, and so much more as well, right? So a CNN has the ability to easily work with, classify, and give you meaningful outputs on all of these images and visual data. Now, if we talk about a little bit more about CNNs, the next question can be saying, what are the various layers that are present in a convolutional neural network? So when the talk is of this, understand that there are 4 important layers in a convolutional neural network. One is the convolution layer, we have the ReLU layer, or the activation function layer as it's also called. Then we have the pooling layer and the connectedness layer. So when we talk about the convolutional layer, this is where we apply things and entities called as filters across the main data to have them as parameters to teach and train the network. So after the convolution step is done, we'll use the activation function to squish it and bring it into a range which is workable and understandable by the neural network. After the activation function is done, then there's something called as pooling. Pooling is where again we shrink the data to make sure we are not losing any of the existing data, and what happens after convolution is we lose certain data as well. So we do stuffing in the pooling layer as well to make sure that we add certain bits, dummy bits, to make sure that the size of the image is actually maintained after every single iteration. So with every iteration the image shrinks a little, and with padding we make sure that we are not letting it shrink out of context as well. And then when we're talking about the 4th important layer of the convolutional neural network, it's connectedness. Here we're just making sure that all of the activation functions are applied correctly by making use of the bias and generally checking that the entire neural network is connected thoroughly and it's working as expected as well. So as the name suggests, this is a very important layer to verify the understanding of the neural network. So these are the 4 very important layers that you have to know about in this particular order itself. Whenever you're mentioning the working of it, the questions can be like, what is the working of a CNN, or what are the layers that are present as well. So this will develop as both of those questions. Now, when you talk about RNN, as I just mentioned, next question can be, what is an RNN in deep learning? So RNN, as I discussed, it stands for recurrent neural networks, and unlike CNNs, the working here is very different. The use of it is very different because RNNs, or recurrent neural networks, are very efficient at working with a lot of string data, textual data, genome data, handwriting data, and much more. So if you have already worked with any basic use cases where you're performing, let's say, handwriting prediction or detection of handwritten letters or whatnot, then there's a good chance that you've made use of an RNN. RNN uses the technique called as backpropagation that we've already discussed for all its training requirements, and it is very effective at doing this as well. Just like how CNN is very effective for working with images, it shows similar girth whenever you're working with textual data as well. So this is again a very important aspect in deep learning. Now with this we can come to the 29th question that says, what is a vanishing gradient whenever you make use of recurrent neural networks? A vanishing gradient, to be honest, can be considered as a scenario, because we already saw in the last answer that RNNs make use of backpropagation, right? So if there is backpropagation, then there's the calculation of the gradients at every single step. And whenever we work with backpropagation, whenever we calculate gradients, they tend to get smaller and smaller as the data works backwards from the output layer to the input layer. So since the value becomes extremely smaller towards the end as we approach the input layer, it causes a problem. So this basically means that your model will learn very slowly and it cannot be efficient. It will underlearn sometimes and it will cause a lot of problems. So this is a scenario of occurrence where your gradient values are becoming very low, and that scenario is what we call as the vanishing gradient. Now, I hope this is clear. So with this, we can move on to the 30th question, which states, what is exploding gradient descent in deep learning? Just like vanishing gradient, exploding gradients are another issue which work in a very different way, because here is a scenario where we're clumping up all of the gradients. Means what it does is it will create a large number of updates for all of the weights in the model whenever it's training. So your model weights are being updated constantly more than required, and and we already know the working of gradient descent, right? So it's based on the condition to keep all of these updates small to make sure that your upgrades are controlled, and only then can your gradient descent have some meaningful impact on your deep learning model. So with this, we have to understand that whenever you control these updates that happen to the weights of the model, right, this will have a huge impact, in fact direct impact on the efficiency of the model as well. So this is another scenario, what we call as the exploding gradient descent, where we have large number of updates that happen to the weights, which make it very, very inefficient at the end of the day too. Now with this, we can move on to the 31st question. So the 31st question states, what is the use of LSTM? LSTM is again a very important type of recurring neural network that we use to perform a variety of operations whenever we work with textual data and string data, as I just mentioned a couple of slides ago. So it stands for long short-term memory, and the working of it is slightly different because it makes use of something called as feedback chains, where it gives the network the ability to perform like another general purpose computing entity as well. So when it comes to that, it is very efficient at working working with a lot of data, especially when we're talking about genome data and genomic sciences. LSTMs are very efficient at working with that as well. So again, just being a type of another RNN, it sort of trickles down to having all of the features and the general working of RNNs too. Now with this, we can come to the 32nd question that states, where are autoencoders used? So we checked out autoencoders before, but then there might be a follow-up question to that stating where they are actually used, right? So you have to understand that autoencoders again have a lot of usage in the real world. So whenever we talk about it, you can have about 10 to 15 uses that of course that you might know already, but then it is vital that you at least mention 3 or 4 very popular applications of it as well. So let's say in the real world, if you have a black and white image and you want to have it colored out to what it actually was in its real life, then adding color to black and white images are very important use cases. And if you have any other old images where you have to remove noise, autoencoders are used here too. And then when you talk about dimensionality reduction and feature removal or feature variation as well, autoencoders seem to be very popular, and in fact more than popular, they're popular for a reason, that is because they're efficient at handling all of these tasks. So make sure you mention all of these real life applications which are very popularly used as well. So with this, we can come to the 33rd question that states, what are the type of autoencoders? So, there's actually 4 types of autoencoders that you have to mention. One is the deep autoencoders, we have convolutional autoencoders, we have sparse autoencoders, and of course we have the contractive autoencoders as well. So you really don't have to explain when you're asked for the types, but then it might add value if you can just state 1 or 2 sentences about each. But then it is very important that you mention all the 4 types that exist for autoencoders as well. So moving on, we come to the 34th question that states, what is a restricted Boltzmann machine, or an RBM for short? An RBM is actually a graph, if you have to talk about it in general. It's a graphical based model that we make use of in deep learning today, and it does a lot of things and can do a lot of things efficiently as well. So when you have to talk about performing operations such as classifications, or let's say regression, dimensionality reduction, be it collaborative filtering, topic modeling, or all of these operations that need to be performed that require an algorithm to do it, an RBM can do it very effectively in today's world of deep learning, where it can make use of the computational power of today and work with it effectively as well. So an RBM is again a very, very important, I know there's a lot of efficient being used in the case of deep learning, but then of course an RBM is very tricky to work with at the same time, but then the output that it provides is worth the effort. Coming to the 35th question, it states, what are some of the limitations of deep learning? We've been talking about advantages for, say, 34 questions now. So it is very vital that you know what some of the limitations or the disadvantages are. There are not many disadvantages, but then there are, a few disadvantages as well. The first one is, whenever you expect very good, very accurate output, you need large amounts of data, and your network has to have the capability to work with large amounts of data effectively as well. So that is one disadvantage. To gathering all the data might not be the case in all the factors. And then when we talk about how complex it is to implement, for example, an RBM is pretty complex for a beginner to work with and to get it working efficiently as well. So in a couple of cases, not just RBMs, RBMs might be easy to you, but then there are many concepts where it can be a little convolutional, it can be a little confusing, and it can be a bit complex to work with as well. So that is one of the disadvantages. And just like any other deep learning concept, your main focus always will be to make sure that your models are very efficient. So you'll be hunting on keeping that loss function down. You'll be hunting on making sure that your goal parameter is being met, and it is being met in a way where your model is very accurate. It is not overfitting a lot, it is not underfitting a lot, and it is performing as it should at its best. So hunting for these can take a lot of time, and it is not as simple as it's put out as well. So in case if you have had first-hand experiences working with deep learning, you will know what I mean with this. Now, we can come to the 26th question that states, what are the varieties of gradient descent that are available, or what are the variants of gradient descent? There are actually three very important distinctions whenever we talk about gradient descent. One is the SGD, or the stochastic gradient descent, then we have the BGD or the batch gradient descent, and then we have the mini batch gradient descent. And whenever the talk is about stochastic gradient descent, the first important thing is that we only make use of one training example, and we calculate gradients based upon that. We update all the parameters based upon this single entity, this single example that we have. But then this is not the case when we talk about batch gradient descent, because once we calculate a gradient for batch descent, as the name suggests, we'll take the entire data set and calculate the gradient for all of the entities that are present in that data set, and then of course we update all the parameters one after the other in every iteration as well. And mini batch is again very similar to batch gradient descent, but then the batches itself are broken down into digestible pieces or small sized chunks, or small sized batches as it's also called, and then work with it just like how if it was a stochastic gradient descent, where we again take a simple training example and we make sure that we calculate gradient, update all the parameters, and perform the same operations for different values across a variety of iteration as well. So these are some of the three important gradient descent, stochastic gradient descent, batch gradient descent, and mini batch gradient descent, that you have to mention when you ask this question. So with this, we can check out the next question that states, why is mini batch gradient descent so popular? So why is mini batch so popular, right? So this is again a question that's asked a lot. In fact, it's a very frequent question if you talk about the previous question or a follow-up to that as well. So one reason why it is popular is, of course, because it is very efficient when you directly compare it against stochastic gradient descent. And when we talk about avoiding the concept of local minima, mini batch gradient descent will help, because we'll be approximating all of the gradient values for the entire data set, and this is done because we use a concept called as generalization rather than hunting for specific values every single time by doing this concept where we're finding the flat minima and working with it. So what this does is make sure that we can avoid the local minima, we can approximate the gradient for the entire data set by the process of generalization, and it can be done very easily as well. So it packs a punch without having much effort into it. So that's one advantage of mini batch gradient descent. Now with this, we can check out the 38th question that states, what are deep autoencoders, right? So we checked out regular autoencoders. So what are deep autoencoders? Deep autoencoders are actually an extension of the regular autoencoders that we just checked out before. So here the difference lies where, the first layer is actually responsible for what we call as the first order function of the input. And if you have a second layer, then the second layer will take care of what we call as second ordered functions. Third layer will have a third order function. Fourth layer will have fourth ordered functions, and so on. So it goes on like that. So when we talk about a deep autoencoder, it is basically a combination of making use of two or more symmetrical DBNs that we discussed, right? So DBN is a deep belief network. So here in an autoencoder, we combine two or more of these deep belief networks, where let's say the first 5 layers is kind of considered as the shallow layers, which will take care of the encoding aspect of it, and the last 5 layers, or in fact all of the other layers, can handle the decoding part as well. We checked out that encoding and decoding are two very vital aspects of autoencoders, and this is where deep autoencoders shine, and how they are complementary to the regular autoencoder as well. So with this, we can come to the 39th question that states, why is the leaky ReLU function used in deep learning? So ReLU stands for rectified linear unit. So leaky ReLU is also called as LREL. In case if you asked about LREL, make sure to understand that it is the same as leaky ReLU. So, we use leaky ReLU in a concept, let's say, where we have the input values, and if they, if the input values are all less than 0, right? So what we try to do is we allow the passage of, small sized negative values to the function, where we use it to actually manage the function, work with it, and then, to drive the activation based upon that as well. So whatever neurons require activation, if the values are less than 0, leaky ReLU is very popular there, which will allow the usage of small negative values and drive meaning out of that at the end of the day. So after understanding leaky ReLU, it becomes very vital that you check out some of the examples of supervised learning algorithms. So, this is a machine learning question, but then we've seen this has been asked a lot in deep learning interviews as well. So what are some of the examples of supervised learning algorithms in deep learning is the question. You have to understand that there are 3 main supervised learning algorithms in deep learning. One is ANN's artificial neural networks, then you have CNN and RNN, convolutional neural networks, and recurrent neural networks respectively. So you have to mention the 3 types or the 3 main supervised learning algorithms usages in the field of deep learning as well, and these will cover all of the subfields that come under them. CNN has a lot under it as well. RNN has a lot of types, as we just checked out in the previous set of questions, but then mentioning these 3 should be more than sufficient. Now, there can be a follow-up question to this stating, okay, what about unsupervised learning algorithms? Can you state examples of that in deep learning? Well, yes, there are 3 very main important unsupervised learning algorithms in deep learning. We've checked all of these out. One is the autoencoders, then we have the Boltzmann machine, and of course we have something called as self-organizing maps as well. So these 3 form to be very, very important unsupervised learning algorithms that find a lot of usage in the real world when we make use of deep learning and its concept too. Coming to the 42nd question, it states, can we initialize the weights of a network to start from 0? Can the weight be 0? The answer is very tricky. You might be, leaning to say no, but then understand that the answer is yes. It is actually possible to start with 0 initialization. But then, of course, it is not recommended to use, because setting it up to 0 will make sure that your neurons will be giving the same output and the same descent and the same gradients whenever we go on to make use of back propagation. So the learning is almost next to 0 or next to nothing here. What this means is that your network cannot learn at all if we start with 0, because there is no asymmetry, right? So each of the neurons have to be unique from each other, and they have to do a unique task that is assigned to them. So if everything is set to 0, then when we work with back propagation, there is no way to tell apart from one neuron to the other. So the learning rate is 0, as I just mentioned, and it really doesn't work. But then yes, it is of course possible where you can have 0 initialization done to the weights before working with the network as well. So after understanding this, it becomes very vital that you understand something called as same padding and valid padding in CNN. So you remember CNN is used for image classification as well, and padding is done as a part of working with images. So whenever we perform iterations, with every iteration the images are being shrunken in size. To make sure that they're not shrunken beyond usage, we do padding, where we apply more dimension to the existing matrix, right? So there are 2 types of it. One is valid padding, and we have same padding. Valid padding is where it is used where it is where there is no requirement for padding actually. So the output matrix will have the dimension n minus f plus 1 multiplied with n minus f plus 1, which happens after the convolutional state. And with case of same padding, padding elements are common padding elements, in fact, are added across all of the output matrix as well. So same padding is a situation where we try to match the dimension of the input matrix as well, but then valid padding might not be matched because it can have its dimension on its own, which is calculated by the formula given there as well. So same padding will try to match all of the elements after padding to make sure that your output matrix will have the same dimension as the input matrix. So that is the basic difference that lies between valid padding and same padding. Now, it is very important that you might be asked this question, so make sure to concentrate on this as well. So, what are some of the applications of transfer learning in the case of deep learning? Transfer learning is a very popular scenario where we take a large model, we train it with a huge data set, yes, of course, and then we make sure to use this model, which has learnt on very complex data, large amounts of data, to work on simpler data set. So, what this does is its efficiency is boosted to a very high extent because it has actually trained on complex data, but it is now working on simple data. So this way it is very efficient, it is very accurate, and in fact transfer learning is being implemented in our daily lives very well as well. But then if you have to talk about the complex use cases of it, we have BERT, we have ResNet, we have GPT-2, we have VGG16, and many other popular examples of where transfer learning are made use of and how efficient and effective they are as well. But then understand the basic working of it. So you train your model on something very complex, but then you actually show simpler data to it at the end of the day where it can work with it effectively and be more efficient too. It's as simple as that. Now with this we can check out the 45th question that states how is the transformer architecture better than recurrent neural networks in deep learning? So, whenever we make use of something called as sequential programming, there are two important things you have to be concerned with. One is how much of processing power you're making use of at every single point of time. And so what is the difficulty that you're facing whenever you have to work with parallel execution, right? So sequential processing will raise these two red flags. And what this does is this actually gave away these two concerns with the primary reasons why we have something called as a transformer architecture now. So in a transformer architecture, we have something called as the attention mechanism. The attention mechanism will take all of the dependencies that are available and it will map in between each of the sentences whenever things have to be processed as well. So when we talk about concepts such as NLP, right, natural language processing, here since the data is mostly sequential, it'll of course bring up the two concerns as mentioned above. But then by making use of these attention mechanism, by mapping all of the dependencies, by making sure your model can recognize these entities faster and map it across to a dictionary faster, let's say, then transformer architecture is very effective as you can think about it. So with this we can check out the 46th question that says what are the steps that are involved in working with an LSTM network, long short-term networks, as we discussed in a couple of questions before. So whenever you're working with LSTM, there is three important steps that you have to think about. The first step is concerned with the network actually picking up all of the information where it has to remember certain things, it has to identify what it has to not remember and what it has to process as well. So that is the first step, where your network has the capability to know what it has to remember and what it has to forget. And then when we come to step number two is where we actually update all of the cell state values, but then updating all of these will depend directly on the outputs of the step one, because depending on what information needs to be remembered or not, the cell state values are updated based on that. The third step in fact also depends on step number two, because here what we're trying to do is getting the network to calculate and analyze what is the current state and which part of the current state should in fact make it to the output and which should not as well. So the most important step is step 3, but then without step 1 and step 2 it is very difficult to directly move on to 3, because you will need what is vital and what is not. Then you have to update the cell state values based on that, and lastly you have to make sure your network analyzes and calculates which part of the current state should make it to the output and which part should not as well. So these are the 3 steps that are very vital in the working of an LSTM network. Now we can come to the 47th question that states what are the elements in TensorFlow that are programmable. So what are the programmable elements whenever you're working with TensorFlow as a deep learning framework? So the answer is very simple. It is very straightforward. In TensorFlow, all the users have the ability to program 3 main elements. One are the constants, one are variables, and one are placeholder entities. So these 3 entities are very important that you state out explicitly, because these are the entities that you can program explicitly, program manually, and work with them, depending on whatever model it is that you're working with as well. So after understanding this, we have to check out one more small concept called as bagging and boosting in deep learning. So the question can be, what is the meaning of bagging and what is the meaning of boosting in deep learning? So what happens in bagging is that, we actually take a data set, we split the data set, and we randomly shuffle around, move the data into multiple batches, or in fact we call it as bags since the term bagging is used, and we use it to train the model as well. And then boosting is a different scenario where we take incorrect data points and we force a model to actually produce a wrong output. We give it a wrong input, we make sure it gives the wrong output. So this way the model has the capability to understand that okay, this is wrong, and then it can retrain itself and increase accuracy as well. So this is a negative way of teaching the model, but then it works very, very well. If your model can understand what is wrong, that means that it knows what is right. So this way, making use of bagging where we're splitting the data set, or making use of boosting where we are giving it the wrong input and the wrong output derived from it to teach it better, both of these are helping very effectively in the case of working with deep learning as well. Now with this we can come to the 49th question that states, what are GANs or generative adversarial networks as well? So GANs are again very, very widely used. They are used to achieve this concept called as generative modeling in deep learning. What it is that it is an unsupervised task that basically is involved in a lot of pattern detection and pattern hunting in the data. So whenever we have an input data, we try to see if we can find out any patterns in it and make sense of it and convert it into a meaningful output. So GANs are very, very useful for this. So the generative part of it comes from the generator, where it is used to generate more than one example at a time, while we have another entity called as the discriminator. A discriminator will classify the examples which get generated by the generator. So the two entities, generator and discriminator, and it would add some value to your candidature if you actually mention these explicitly to the interviewer as well. So GANs are again they're very widely used, because whenever you think about it, everything is pattern detection in today's world, right? So GANs have a lot of implementation and a lot of requirement by us as well. Now with this we come to the last question that states, have you earned any sort of certification to improve your learning and implementation process? Well, the answer to this is very important, because as you might already know, a certification program can give you a lot of advantages. Structured method of learning, a lot of use cases, real-time projects, expert guidance, live classes, and to you this is fine. But then to the interviewer, what they are trying to understand from your certification program is, with the certification program, you are trying to show that you want to exceed in your career, that you want to build something, that you want to advance in your career. That is the first important point. The second important point is that, let's say if you're a fresher, if you learned it all on your own without having to learn it in college or something, that shows grit, that shows aspiration. And if you're a person who's moved from another programming language to come into the field of deep learning as well, that again shows very strong aspiration, that you are willing to put some time and effort, and that you've already put time, effort and money into learning all of these as well. And at the end of the day, that adds up to a concept where you're proving yourself to the interviewer that you are effective at what you do and you want to do this. So one very important thing that you have to know whenever you're talking about certification programs, right? So yes, you can list all the certification programs that you have had, but then what will add the most value is to tell the interviewer what you learned and how you used your learning to implement something new. See, because not just certification, any IT concept in the world, right? So we're trying to solve a complex problem using a simpler thing. So we're trying to make the complex problem very simple. So how have you taken a complex problem, how have you worked on it, and how have you simplified it by making use of your certification program is very important to the interviewer, and that is what you should talk about. Explain what you learned from it, explain how you learned and what you took away as well. And here is a small bonus for you guys. Apart from this, what would add a little more value is to make sure that you mention that that you're planning to use your learning in this particular way for that particular company that you're applying for, right? So you would have learned a lot of things. If you put it out in a way where you're telling the interviewer that, hey, I learned all of these and I think I can use it this way to help your company, that will impress the interviewer as well. So that is one very important way on how certifications will help you rapidly increase your career's dimensionality basically. Well, with that, you have reached the end of this top deep learning interview questions. I take this opportunity to wish you all the best for all the interviews ahead. So you make sure to use this guide to understand how you can approach the questions effectively and how you can answer them precisely and with as much content and quality as possible.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.